Hello and welcome again to Time Series Analysis Hands-on Python course. In this first session, we want to discuss the content of the course. It is very important and necessary, so please do not skip this part and listen carefully. The three first sections of the course are somehow introductory and requirements of this course. So if you think you don't need these parts, just skip them and go to section 4 directly. But my suggestion is completing the course from the beginning to the end, so you don't miss anything. Okay, let's see what we have in these three sections. In section 1, we start from the introduction, that is somehow Python IDE installation and installation of required packages. In section 2, we go after useful packages like Numpy, Pandas, and Matplotlib that we need them during our course. In section 3, we go after time series analysis with Python, with Pandas, that is actually somehow very important. We start with how we can create a date time with Pandas, how we can set a date as index with Pandas, and what is resampling and how we can do that. Then we go to section 4. This is where the exciting parts actually begin. So sit tight so we can go through them all. Section 4, we start from the introduction and we go after the ARIMA concepts and methodology. So ARIMA is actually one of the most famous statistical model for time series forecasting. So that's why we start from that one. And then we go from after the implementation of ARIMA model, a real project in Python environment. Then we go after the Variance models and concepts of that. That is actually the seasonal ARIMA with exogenous variables. We go after how one implementation of a project, a real project in Python. And I will show you how you can add exogenous and endogenous variable, what are them and how we can add them to Variance model, and using Variance model for a multivariate to solve a multivariate problem. Then we go to section 5. Section 5 starts, that is actually my favorite. I start explaining a complete introduction of deep learning and neural network. You may don't believe that, but we start from the biology aspect of neural nets. That means if you don't know even anything about neural networks, you will understand the concepts. So in the section 5, we also start from the introduction and the neural network basic concepts. As I told you, from the biology part. And then we go after the recurrent neural network concept that we want to use, and all especially the important part, that is the important branch of recurrent neural network, that is called long short-term memory, LSTM, that is specially designed for time series analysis and time series forecasting. Then we go after development of that LSTM model, real project in Python environments. And then for the first time, as far as I know, I will show you how you can use LSTM for multivariate models, and when you have several features instead of single features. And I know most of you are looking for such a thing, and this could be very interesting for you. So in this part, I will show you how you can use LSTM for multivariate forecasting and development of a multivariate model using LSTM in Python environment as the last chapter. So that's it. Let's do not waste more time and go straight to the next session and start our journey with together. See you there. Hello and welcome back to Time Series Analysis Hands-on Python. So this is a very quick tutorial. In this tutorial, I just want to show you what is the IDE and how many IDEs we have. IDEs, integrated development environments that can give you so many options and make the Python environment friendlier, and it makes it easier for you to code and develop your model. So different IDEs we have for Python. For example, we have a Jupyter Notebook that is specially designed for data science and data scientists. We have PyCharm that has its own advantages and disadvantages, and if you are professional in coding, I suggest you use PyCharm as well as your IDE. And we have a Spider that is my favorite, and I like it so much because with the Spider you can actually, first of all, it has a very user-friendly environment. And second, you can go through the variables in the Variable Explorer, you can check different variables, and it is very easy to find out what's going on in your model. So because of that, in this course, I choose Spider. And in the next session, we are actually going to know how we can install Spider in very simple steps. And also after that, we install different packages that we need to continue our course. So that's it. This was a very quick tutorial. I will see you in the next tutorial. Until then, keep exercising and enjoy time series analysis. Hello and welcome back to the course. As we promised, in this session, I will show you how to install the Spider IDE. It's very easy, so just concentrate. The first step that is very important is actually installing the Python itself. So if you have the Python in your computer, any version, that's okay. Just skip this part. And if you don't have it, just go to Python org-downloads, and from the downloads you can just download any version that you like related to your operating system, Windows, Mac, or other platforms. So my suggestion is not downloading the last version, because it takes time between Spider and Python to adjust. It takes time for Spider to adjust itself for the last version. So my suggestion is go after the previous versions. For example, myself, I'm using 3.7. So if you want to be in parallel with the course, just download the 3.7. You can see the different versions in the website, and you can download any version that you like based on your operating system. So after you download this and install the Python, that is very easy, just like other softwares. Then you should close this one and go here on your, for example, if you use Windows, on your search section, or if you're using Mac, just open your terminal by typing CMD. You can see the command prompt window or your terminal. Just right click, run as administrator, and click yes. Then this will appear on your system. So here we just need to first check that if pip is correctly installed with our Python packages, because when you're installing Python, pip is somehow simultaneously installed with, will be installed with the Python itself, because it's one of the packages of the Python. So if you install your Python correctly, you should have pip on your system as well. In order to check that if you have pip or not, you can just type here pip help and press enter, and you can see the information of your pip package. If in this command prompt you type pip help and it showed you pip is not recognized, or it gives you any kinds of other kinds of error, it means that the pip is actually not installed correctly with your Python. So try to uninstall your Python or install it again with different versions. So after you make sure that the pip is installed by this pip help, just like this, when it gives you the information of the pip, you can easily install Spider by saying pip install Spider, because I already have a Spider on my computer If I press enter, it mentions that is already satisfied, the requirement already satisfied, but for you, you should download the spider and install it very fast. It shouldn't take so much time. So if I press enter, you can see that it mentioned that requirement already satisfied in all lines, but for you, it should be different. So after this, it takes maximum 1 or 2 minutes in order to install the spider based on the configuration of your system, and it may take a little bit more time. And then very easily, anytime that you want to open the spider that we just install it with together, you can type spider here very easily, very straightforward. Okay, and if I press enter, it automatically should open up the spider. As you can see, spider is opening here. And if, yep, it opened the spider for me very easily and very fast. So you can see that spider is now installed, and this is the environment of the spider. We can go through that and I will show you around of the environments of the spider in next sessions. That's it for today's session, today's tutorial. Until the next tutorial, keep exercising and enjoy using time series. Hello and welcome back to Time Series Analysis Hands-on Python. So as promised in the previous session, I want to show you around the environments of the spider a little bit before we go to installation of our libraries and we start our course officially. When you install the spider, and you open it, you have such an environment, and as you can see, it's very user-friendly. You have 3 main sections. You have your editor here, you have your variable explorer, help, and plot files here. You have your console here. So we are working with these 3 main environments. And the most important thing that I want to show you before we start actually installing the libraries is setting the Python that you just downloaded, and I showed you in a previous session any version that you downloaded from the Python website. Setting it as the interpreter of this spider is very important. So you need to go to from these tabs, you need to go to Tools. You need to go to Preference, and something like this window will appear. So in the preference, just go to the Python interpreter here, and you have 2 options, default and using the Python interpreter that you define. So if you go after default, it is actually the default of the spider, but we don't want that because we are trying to use the pip installation, and also we want to use pip of that Python that we just downloaded in order to install our library. So just click on this use following Python interpreter, browse in your system and find the Python that you just downloaded and installed. So this is for example the location of the Python exe that's python.exe that I have on my computer, on my Windows. And my version, as you can see, is 3.7. So you can just add this location to here just by clicking on this and go to section that you want and add it to this section. And after that, you can apply the changes and press OK, and that's it. Before we close this, here you have lots of interesting options as well. If you for example, if you open your spider, it may be in the white environment or other colors that you don't like. So just for your information, you can change these things. For example, you can go to the appearance of your the first one, the appearance. And if you want it like me, because I like the dark environments and I like it like this. And it showed you the preview here. So the preview of my selection is something like this. So if you like it like this, you can just search for the interface theme as automatic. And the icon theme here is a spider tree. And you can also, for the syntax highlighting, you can search for you have lots of options. You can search for Spider Dark, and here as well I set it for the font. I set it for these two, MS Shell DLG and also console. So these are my setting. If you wanted just like me, you can just go ahead and change your, you can change your font size. So it's very user friendly, and you can change it easily. And the last thing before we close this session is that I want to show you is a keyboard shortcut. It's very important because during the course I use different shortcuts, keyboard shortcuts than you. So it's not bad if you change it just like me, so you don't be confused. For example, the most important thing is actually running one line of code. So you can change all of these very easily. So if I search, for example, for run, you can see that for running cell, running for running selection, for example, this is very important for me. Running selection, this one. So I use the F9 in order to run the selection, because I, for example, select 2 or 3 lines of code and run them together with pressing F9. You can just put any shortcut here as you like, but during the course I may say that okay, I press F9, so don't be confused. And if you want, you can just change it just like this, F9, just like me, and we are good to continue. And as I said, you can just change any keyboard shortcut that you are not happy with here very easily. That's the 3 important things that I like to show you, and it was very important for me. But you are most welcome to go through all of the other options that you have with your Spider and change them as you wish. So that's it. I press OK, and we are ready to go for our libraries installation, the last step before we start our coding and our lessons. So until next session, keep exercising and enjoy time series. Hello and welcome back to Time Series Analysis Hands-on Python. So in this session, I show you how to install the different libraries that we need during the course. I show so this is very easy. Typically, you just use 3 words pip install the name of the package that you want to use, but we will go through it one by one so you don't have any problem. So the first package that we need to install, because I already have installed the packages on my computer, so it may you may see different results from me. So if I say pip install numpy as the first package that I want to install, for you, it should go and download and install the NumPy package, or if you already have it, you should have the same result that just like me, mentioning that the requirements already satisfied. But if not, if you don't have it on your system, so it goes and download and install it for you right after you press enter. So the next one is Pandas. So just like the previous one, we use pip install Pandas and press enter. Again, it mentioned requirements already satisfied. The third one is the matplotlib, so I use pip install matplotlib and press enter. It mentioned requirement already satisfied. As I mentioned, for you it should go download and install the package for you, so you shouldn't have any error when you write pip install matplotlib. So the fourth one is the Seaborn, so we may use that one as well. So let's say pip install Seaborn, and by pressing enter, it goes and download and install for you. The other one is the Scikit-Learn. We may use the Scikit-Learn during our course, not very much, but for the metrics we may use that. So let's install it, pip install -u. So this is the only one that you shouldn't just type the name. So -u SCIKIT. So Scikit, again -learn. Okay, so if I press enter, it goes and download and install it for you. And the other ones are actually for these libraries. We use them for the libraries that we already installed are basic libraries, but from now on we want to install the libraries that we need for our forecasting. The first two are for statistic model. So let's say the first one is the stats model library. So pip install stats model. Don't forget the S at the end. So if I press enter, it goes and downloads. You see, this is what happened when you don't have the package. I don't have the stats model on my computer, so it goes and download it and then try to install it. Let's see. Yeah, finished very easily, very fast. So first download the package for me and then installed the downloaded package for me, and now successfully installed stats model. So it should give you this notification that the package that you requested successfully installed. This is the end. And the other one is PMD Arima. So I use pip install PMD Arima. This is also for our statistic model. So if I press enter, it goes again. I don't have this, so it mentioned that downloading and then successfully installed the package that I requested. The other one is the Keras library that we needed for the neural network development. So we need to say pip install Keras. I press enter. It mentioned requirements already satisfied, but for you, it should just like this, download and install the package. And the last one that we may use that as well is the pip install TensorFlow library, TensorFlow. So try to check the spelling because it may give you error if you have a typo in that. So TensorFlow is fine. If I press enter, it for me it's mentioned already satisfied, but for you it may take several minutes, but because TensorFlow is a little bit heavy library, so be patient. It will download and install the package for you very fast. Not very fast for the TensorFlow, but very easily. And that's it. We installed our required package for this course. During the course, if I find some other libraries that we need them, we will go back to this terminal and we will install it. But for now, it's enough. I think these are all the libraries that we need during the course. So that's it. I'm very excited to start the next session because we actually want to start our course before. These were just introductory and the requirements that you need to start the course, but from next session we start our course. So I'm very excited to start that. Until then, keep exercising and enjoy using time series analysis. Hello and welcome to this section. Because we need NumPy, Pandas and Matplotlib libraries as the basic packages for the rest of the course, I brought complete tutorials of them from my other course on Udemy named Machine Learning and Data Science A to Z Hands-on Python, so you can be familiar with these important packages. Therefore, in this section, even the theme of the spider environments will be different from the rest of the course, and I may say something that is not related to this course, and you just ignore it and learn the concepts that I'm explaining in this section. So I'm saying all these because I don't want you to be confused in this section. Again, If you think you have already passed my other course and you're familiar with these basic packages and you have already studied them and worked with them, just skip this section and continue with the next section. Okay, let's not waste more time and continue. Good luck. Hello everybody and welcome to this machine learning tutorial. So in this tutorial, we're going to learn what is NumPy and how we can use that. NumPy is an open source library that is used when we want to work with arrays. So it is one of the most important libraries that we use in data science and machine learning. So listen to this tutorial carefully. I will give you some tricks about the NumPy and we go deep into it and we find lots of interesting things about this package. So let's switch to the Python environments, actually Spider environments. So if you remember, this is our environment. I just made a new project here just by clicking this one. You can produce as much as you can, this new editors. So you can also save them by this and make a name for them. I just named them Python NumPy coding and just save and this will appear. So this is our editor section and we are already introduced to the Spider environment, so you're familiar with that. Let's start with our coding with just giving a title to our code. That is, I want to say, for example, by putting my title in this double quotations, NumPy coding, something like that. So if I want to close this, I just put another double quotations here to just close it. And from this line, I will start my code. So anytime that you want to put a comment or you want to put a title or something, you can put it between double quotations or you can put square and then type your comments. So let's start. I want to start with importing my NumPy library. So I easily type. It is very, Python is very straightforward coding in it, so it's not very complicated, especially for machine learning and data science. So I just say, okay, Python import NumPy for me as, you can say NP. So this is you can say NPS, NPSP, something like that. So anything that you like. Import NumPy as a name that you like to use. Or even I can say import NumPy. That's it. From now on, I should just use the NumPy name. But in order to be faster in coding and also because it's time consuming to type the package every time, so I should say I should put an abbreviation for it. So import NumPy as MP. That's it. That's the line of code. So if I just select this and put a run key, so sorry, select this and run. If you remember, we used F9 for running the selection in the previous tutorial. I taught you how to change your keyboard shortcut for running a selection area, selection code, selection line of code with F9 or any other key that you like, but I put F9. So I just selected this line and put and pressed F9, and here you can see the NumPy actually imported. If you check the console, import NumPy as NP. So now Python understands the NP for me. So from now on, anytime that I type NP, Python understands that this refers to NumPy library that I just imported. So the next line of code would be starting with NumPy and being familiarized with the arrays. What are the arrays as we discussed? So for start, let's say, okay, NP, let's make an array. A very simple array, NP dot array. And inside of this array, you can put, okay, parentheses. Inside of these parentheses, you should put 2 brackets, and inside of these brackets, you have, for example, 1 row, 2 row, separate brackets. For example, I have 2 rows, and each row has 3 columns. So I should say, for example, 1, 2, 3, something like that. Sorry. And comma, and then another bracket, and I say, okay, the other one is 4, 6, 7, something like that. It's just for, this is an example, for instance. So this is an array that we made. If you want to see this array, just again select this line and press F9. So press your run button, and by pressing this, you have an array. You can see that an array with 2 rows and 3 columns. Uh, to evaluate this more and better in our Variable Explorer section, let's put this array that we just built together very easily into a variable. I can say, for example, nump underscore array is equal to NP array. So this is our new variable, and if I run this, it should appear here in our Variable Explorer. So np.array, this is equal to nump array. So if I select this and press run, so you can see here we have nump underscore array here. So this is very interesting here. So it gives you all the information about this array, the name of your array, the type of your list or array or series. So here we have an array of integers because we have all integer numbers. There's no floats in it. And this 32 refers to the memory. It's not very important. And here you have a size of your array that you have 2 rows and 3 columns, as you can see. Even you can open it up and you have a very beautiful array that we just built together. So we have 2 rows and 3 columns, or 2 samples and 3 features actually. So this is our array that we just built together very easily. That's it. This is for the first tutorial of the NumPy. In the next tutorial, we will talk about how we can do some mathematical operations on this array that we just built together. And this will get for sure very interesting for you. And until next tutorial, enjoy machine learning. Hello everybody, and welcome to this tutorial. So in this session, if you remember the previous session, we talked about how to build our first new array and to import the NumPy library. And now we want to start doing some mathematical operation and the arrays. So imagine that we want to build 2 other arrays together. Just do it with me, code it with me. It will help you to understand it better. So imagine, for example, our NumPy array 1 is equal to np, just like before, np.array. And in the parentheses, we use double brackets. And inside of the brackets, we have, for example, 2 rows that one of them is 1, 3. The other row is, for example, 4 and 5. And we have also another variable that we want to make, NumPy array 2, that is np.array. In the parentheses, again, we have double brackets, and inside of the brackets 1, we should say, for example, 3 and 4. And also we should have another one that is 5 and 7. Okay, so we have 2 NumPy arrays that we just built. Let's run this code. Just select these 2 lines and press F9 or run button. And you can see we have np1 and np2 here. If you just take a look at them, we have 2 arrays with 2 rows and 2 columns as a size. This is our np1, this is our np2. And you can see the information here as we talked about. This is array int 32. The size is 2222, both same size. Now we want to multiply these two arrays together. What should we do? If we want to do it, we have two types of multiplication here. First is when we want to multiply the first array to the second array in a matrix way. For example, if I say, let me show you. If I say MP1, so if I use this @ sign to MP2 and put this in the multiply of MP, something like that. Put this in this variable, MNP. And if I run this, select and run. Okay, if I check this, you can see that we have 18, we have 25, we have 37, we have 51. What happened here? So let's go to the presentation quickly. So here we have, these are our arrays that we made with together, if you remember, 1, 3, 4, 5, 3, 4, 5, 7. So with using this sign, @ sign, we actually do a matrix, multiplying matrix that we learned in high school. If you remember, when we want to multiply this matrix to this matrix, we should say 1, 2, 3, 3 to 5. So this is 3, this is 15. So we have 18 here. If you want to say, for example, this one, we say 1 to 4, 3 to 7. So we have 4 here, 21 here. So we have 25 here. Again, just like the other one, 4 to 3, 5 to 5. So we have 37 here, 4 to 4, 5 to 7. We have 51 here. Just like what we learned in high school, how to multiply two matrices together. This is when we use the @ sign. But let's go back to our coding environment. And this time I want to say, okay, MNP2 is equal to NP1. This time I use star MP2. So if I run this, you can see that MP2, this is, okay, MNP, this is MNP2. Our MNP was this, 18, 25, 37, 51. Our MNP2 is 3, 12, 20, 35. So it's completely different. So what happened here? Let's go back to the presentation modes. So this time we use a star. So what happened is we just multiplied each element by element together. So imagine I want to multiply this to this, and this is the result. Multiply this to this, 3 to 4, this is the result. 4 to 5, 20. 5 to 7, 35. So the difference between using @ sign, this sign, and the star sign is when you want to multiply your arrays, just like multiplying two matrices, you use @ sign. When you want to multiply each element of your array to the other elements of the arrays of the other array, we should just use the star sign, just like this. So it depends, what do you want to do with your multiplication of the arrays. So let's go back to the coding environment. So the other thing that I want to, before closing this session, I want to mention is we can use this, or we can say, okay, MNP, let's name it 3, so do not confuse it. MNP3 is, I can use MP dot NP1 and NP2. What happens here that I'm saying, okay, I'm using a class of NumPy that names dots, and I'm using my two arrays here, my first array and my second array, and I'm telling this class of NumPy that names dots to multiply these two arrays with together. If I just run this, you can see that the amount of MNP3 is actually equal to MMP, the first one, the @ sign. So instead of @ sign, if I just cut this and put this here, it will be more understandable. So this one is equal to this one. You can use either the @ sign and multiply your arrays with together, or you can use this class of NumPy that mention MP dots, the array 1 and the array 2. No difference, the same results. Again, for the second one, you can, for the star one, that's actually multiply each element of the array to the other array, you can use another class of NumPy that is, okay, we can name it, for example, MNP4, that is equal to MP, multiply MP dot multiply, MP dot multiply, yeah, multiply. And inside the multiply, I just mentioned the MP1 and MP2. Again, just like the upper one, I'm using the class multiply of the Python NumPy and telling it, okay, multiply this to this elements by elements, not just like matrix way. So if I want to do it in a matrix way, I use dots. If I want to use it element by element, I use multiply. If I run this line of code, you can see that the MMP4 is exactly equal to MMP2 that we already calculated it using the star sign. So that's it for multiplying the arrays with together. In the next tutorial, we are going to talk about how to sum or subtract two arrays with together. Yeah, that's it. And until the next tutorial, enjoy data science. Hello again, and welcome to this session of the machine learning tutorial. So if you remember in the previous session, we talked about the arrays, how to import the NumPy, how to make an array, we built an array together, and how to actually multiply two arrays together. Now in this session, we want to talk about how to sum or subtract these two arrays together. It's very easy. So if I say, for example, the summation of the MP1 and MP2 that we previously built together in previous session, these two arrays, the summation of it, put it in the, for example, summation 1 is equal to, very easily I can just say MP1 plus MP2, and if I run this, it's very easily, first I should run these things because okay, now we're good to go. So if I run this, it's now the summation 1. If we check that, yes, you can see that the summation is something like this. So this is MP1, this is MP2. So it comes and just add up each element with together. 1 with 3 is 4, 3 with 4 is 7, and so on. So it adds up element by element of the matrix or array that we have. So for the subtracting, we have a same procedure. So we can just say sub1 is equal to MP1 minus MP2. So if I just run this line by pressing F9, so I have sub1. You can see that element by element, it just do the subtraction for element by element. 1 minus 3 is minus 2. 3 minus 4 is minus 1, and so on. So it's very easy. Just element by element, it goes and subtract or add up the elements of the array. There are other, for example, for the subtraction, we can use the NumPy classes. We can say, okay, I'm saying sub2 in order to not confuse them with together is MP dot, I'm using one of the classes of NumPy that you can see. There are lots of classes. So subtract, you can see that it's just suggested to me. So inside of the parentheses, if you just forget, you can just press Control I and see what's going on here. So for the subtraction, you should two things that are not optional, and you should give it to the class subtract is x1 and x2, as you can see here. X1 is the one, your first array, x2 is your second array. The others are optional. You can just forget about them. So just I want to say, okay, here I want to subtract for me numpy array 1 and numpy array 2. And if I run this and go back to my Explorer, if I run this, you can see that sub2 is exactly equal to sub1. This is sub1 that I previously calculated. This is sub2, exactly like each other. So you can use this or you can use this, no difference, the class of Python. And also another trick that I want to show you here for the summation. For example, imagine that for numpy array 1, okay? Here you want to add up all the elements that you have here. This is a very small array, but imagine that you have an array with thousands of elements, and you want to add up all the elements, all the rows and columns with together, all the cells that you have. You want to add them up. And to do that, you have a very good class in NumPy that we can say, for example, element summation, something like that, is equal to numpy or np dot sum. And inside of the parentheses, you can tell the numpy what is your array. For example, np1 or np2, any array that you have. So if I run this, what should we give? Okay, we have an array of this np1, so it's 1, 3, 4, 4 plus 4 is 8, 8 plus 5 is 13. So I should get 13, I know that. So if I run this, so if I go to the L sum, you can see that it's number 13. You can just easily delete this. Don't need it as variable. So if I run this, I can see it in the console. It's 13. So it just add up all the elements inside of the numpy 1 array that we just built, and it gives you the summation number. So that's another one that can help you during your coding, your modeling. Sometimes you want to add up the arrays elements, you can use this class. And the other important thing before we close this session is one thing that I want to show you is the broadcasting thing. What is broadcasting? So actually, the broadcasting is when you are adding a number with your array. For example, imagine that you have an array np1, okay, and let's put the number here, a variable here, for example, broad nump. Okay, so this is let's say, for example, np1 as our array, and you say plus 3. What will happen? So I imagine that you will say, okay, the Python gives us an error for this because we have an array and we have a number here. So what will happen? Let's run this and see what will happen. So if I run this, there is no error, and also I have a broad nump here. You can see I have the same array here with same size, 2 rows and 2 columns, same size as np1. What has happened here is if we go back to the presentation mode and we see here, okay, so here, as you can see, we have, okay, we talked about this, and okay, here, this is the array that we talked about. For example, 3, 4, 5, 7. This is one array, 2 rows, 2 columns. You want to add this up to a number. What Pythons do is actually changing this number, this just one elements number to a matrix or array with same size of the array that you are adding it up. So adding it up to. So if it has 2 rows and 2 columns, it changed a number to an array that has 2 rows and 2 columns with same numbers. So it's 3, it's just 3, 3, 3, 3, just like that. So now it comes and add up each element by element. So 3 to 3 is 4 is 6, 3 to 4 is 7, and so on. So it's just like that, when you add a number to an array, it's make the number to a same size array to that array that you are adding up, and then do the calculation just like before that we discussed it, how summation of 2 arrays works. So if we go back to our working environment, I want to show you another example that for example, imagine that you have an array MP1 and you want to make another array named, for example, MP3, okay? So this array is mp.array parentheses bracket bracket, and inside of the bracket you should have, for example, 3, 4, 5. No, 3, 4, okay? So what will happen here? So you have an array of just 1 row and 2 columns, and you have an array here, MP1, for example, that has 2 rows and 2 columns. So if I say MP1 plus MP3, what will happen? So if I run this, oh, MP3, I didn't run. Okay, first run this line. So now you have MP3. So if I run this, now you can see I have an array. What will happen here? So let's go back to this environment, and okay, what will happen here is, for example, you have 3 columns and 2 rows, and you want to add up an array that is not the same size as the previous one, and it has just 1 row. So what will happen here, just like the above example, Python gives you change this second array to the same size as the first array to add it up. So just copy this first row to the second row to just make these 2 arrays in the same size. And then now that they are in the same size, it just added up elements by element, 1 to 4, 5, 2 add up to 5, it's 7, and so on. So you can see that the broadcasting is expanding the array, the number or array that you are giving to Python to add up to other array in order to make it the same size as the first array or previous array that you want to add up to. So it's very easy. Just imagine that Python is doing expanding your number or your array to the same size of the array that you previously gave it to add it up. So if we go back to our environment, you can see that we have done several things. If we review it very fast this session, we know how to add up or subtract 2 arrays together with the class of Python, or very easily by just adding them up by the operators, summation and subtracting, and also how to add up all the elements inside of the array, and what is broadcasting, and how Python calculates when we add when we want to add one array with the other array with not the same size, different sizes. So that's what we'll learn together, and in next tutorial we will go with how we can divide the 2 arrays together. But until then, enjoy using data science. Hello and welcome to this section of the NumPy tutorial. So in the previous section, if you remember, we talked about how to add and subtract 2 arrays together, and also summation of the elements of the arrays, and we also talked about the broadcasting. Now we want to talk about how to divide 2 arrays together. So it's very easy. So we need to just define a variable, for example, d, and this d is equal to np. We want to use a class of numpy, so np divide. Very easily, you can just write that down. And inside of this, what should we learn? What should we write? We can just use help as usual. If you just forget about anything, just Control I and go to help. It's very easy. So inside of these parentheses, I need to mention x1, x2, and the other parameters. So what is x1? X1 is the divided array, the array that you want to divide. And x2 actually is the divisor array. So what array or number that you want to use as divisor. So if you don't know anything about the parameters that mentioned here, just come down and you can see the parameters definition right here. So first of all, I need to mention the divided array. So the array that I want to divide, for example, is inside of the brackets. I can mention a list, something like, for example, 12, 15, and 16, some random numbers. So I want to divide this array by number 5, for example. So this is my divider. This is my divisor. So that's it. If I run this, I should have my result. So if I just select this and press run, and if I go to my variable explorer here, I can check the D. You can see that we have our array that is actually it gets these results is coming from dividing 12 by 5, that is 2.4, 14 by 5, that is 2.8, and 16 by 5, that is 3.2. You can also divide this array to another array. It's not, it's the divisor could be another array. Also, we can do something else. You can say, okay, I don't want my results to be integer, to be float like this. This is not integer. I want my result as integer. So to do this, you can do several things, but something that I'm doing here is something like this. I can say mp dot, instead of divide, I can use floor underscore divide. You can see it gives me as a suggestion floor divide. So I use that. So inside of this, again, I can copy and paste this one, this divider and divisor, okay, here. And if I run this line, select and run, you can see now D is 223. It was 2.4, 2.8, something like that. It was a floor number. But now, as you can see, the type here, the type of D is array of integer. The previous one, if I run it again, it was array of float. Look at this. D type is array of float. Now, if I use floor divide class and run, the D changed to array of integer. So that's how you can have integer number instead of array of float. So yeah, that's it. And the other thing, the last thing that I want to mention here before to go, because this was a very quick tutorial. The next tutorial will be more interesting. This I just want to mention that you can do some mathematical operation as well on the NumPy array that you have. For example, imagine that you want to have a radical. So let's say is q is equal to mp. You can use np.math, math class. So np.math, and for example, I want to have a sqrt. You can see here, if even I don't press this, if I press tab, it should give me some dot tab. Yeah, sorry. If I press tab after the dots, it should give me some of the function that I can use from this class. For example, the function sqrt, the function sinus, the function log, and lots of other functions. The floor that we used, if you remember, exponential function and other functions too. So I want to use, for example, SQRT. If I press enter and I have, for example, I should define my array that's just a number. For example, it's a 10. And if I don't need to put this in the variable, so I just delete this. I want to see it in my console. So if I just run this line, it gives me the SQRT of the 10 that is here 3.1. So you can use SQRT for the array. So I just wanted to mention that NumPy has a math class, so you can use different function of this math class to work and play with your arrays. That's it for this tutorial. In the next tutorial, we will talk about the distribution, how we can generate random numbers and the way of distribution, normal and uniform. And that would be a very interesting tutorial. Until then, enjoy data science. Hello, everybody, and welcome to this session of the NumPy tutorial. So, if you remember in the previous session, we talked about the how we can divide two arrays with together, or divide an array with a number, and how we can generate division of the array, how we can floor it. I mean, having integer results or float results. So in this tutorial, we are going to, we also talked about the math class of the NumPy and how we can use the different functions in the math class. But in this tutorial, we are going to talk about the how we can generate different distributions with NumPy or different arrays. So let's first take a quick look at the presentation slide that we have here. So if you look at these two graphs, you can see we have a uniform distribution and we have a normal distribution. So we will talk about the statistics and what is the standard deviation, difference of the standard deviation between these two graphs in future. Don't worry about that, but just for now that we want to generate some uniform distribution, normal distribution, I just wanted to mention this so you won't be you won't be confused in that section. So this is the normal distribution. That's this dispersion is not too much, so all the data are around gathered around the mean or median. And this is uniform distribution that is it has some dispersion that's the so you don't have the highest standard deviation. Sorry, you have high standard deviation. So we will talk about this more. Just for your information, this is the shape of the normal distribution. This is the shape of the uniform distribution for the data. So let's go back to our environment in order to generate these kinds of distribution. To do that, we want to actually first make a variable name, for example, normal distribution. So for normal distribution, we say, okay, we say np dot random because we want to generate random numbers. Random, we can say that normal, or we can say that standard normal. Yeah. And here inside of the parentheses, we should mention the size of the distribution that we want. If you forget about what you should put in the parentheses, again, press Control I, and inside of the parentheses, you can see we should enter just size of the distribution that we want. So we say, okay, the size, for example, is just 3 rows and 4 columns, something like that. So if I run this, and check the ND in my variables. So where is the ND? So here it is. We have an array of floats, not integers. The size is 3 and 4 that we mentioned. And if I open it, you can see that we have a normal actual distribution like we discussed in the presentation in a shape of normal distribution. we have such a number. So NumPy actually generates random numbers in a form of normal distribution. What about uniform distribution? If you want to generate, for example, uniform distributions, let's say it's UD, it's equal to sorry, MP dot, again, we use random, and this time instead of normal we go for uniform. So inside of the parentheses of the uniform, let's check the help. So we have low, high, and size. What is low is the lower bounds of your uniform distribution. High is the higher bound of your distribution, and size is the size of your distribution. So let's say, for example, we want to generate numbers uniformly between 1 and 12, and the size of our distribution is again 3 and 4. We need 3 rows and 4 columns, something like that. So we have lower bounds, we have higher bound here, and we have the size. So if I run this again, and I go to the variable explorer and check for UD, you can see that in the UD section we have generated numbers between 1 and 12. So all of the numbers are between 1 and 12, randomly selected, and the size is 3 rows and 4 columns. The other thing, so we generated randomly uniform and normal distribution. What if we want to generate a random float number, for example, between 0 and 1, something like that? So we say we don't want any distribution or these things, we just want random numbers. So we say NP, for example, that's random. And for this random, first of all, if you want integer variables, you can say rand int. If you want float variable, you can say rand. Okay, so we have np that's random, that's rand, gives you float numbers. np that's random, np that's random, that's rand int, it will give you integer numbers. So let me comment this. So if we want to generate float numbers, we use this. And if we want to generate integer number, we use actually this class. So this function in a random class. So we use np random randint or np random rand for floats. So for example, let's go for randints. I want to say, okay, for randints, I want the numbers between 1 and 50. And the size, again, for me could be, for example, 2 and, oh, sorry, in parentheses, you should say the size is 2 and 5, for example. So we can just put it in the random array is equal to np that's random, that's randint. We use randint function. And the first is the lower bound, the second is the upper bound, and the third, actually, you should mention the size. If I run this and check the random array that we just built, you can see that here it is, random array. So the type is array integer, as we mentioned, because we use the integer rand int, actually rand int function to produce integer array. And this is the size. If I just open it up, this is all 2 rows and 5 columns between 1 and 50 that randomly generated for integer numbers. So we can do the same for the float. You can do it as an exercise. It's very easy. Just define the lower bound, upper bound, and the size that you need to generate. NumPy generates for you random numbers. And the last things that I want to mention, so until now we understood how we can generate randomly uniform distribution, normal distribution, random numbers, not distributions, just random numbers between lower and upper bounds, and define the size. And you can also randomly generate zero arrays, for example. You need zero, or is that E? Let's say it's a variable name, is equal to np dot zeros. And inside of this, I can mention the size of the array that I want, for example, 3 and 4, something like that. 3 rows and 4 columns. If I just run this and go to the ZE variable that I just built, you can see that I built an array with just 0 numbers, and I have 3 rows and 4 columns. I can do the exact same thing with 1. For example, I can say ones is equal to np dot, this time I should say ones, and inside of the parentheses I should mention the array, for example, again 3 and 4. So if I run this, select and run, you can see I have an array. So let's open them up. So we just built an array of ones, an array of zeros. You can do it for any size that you like. So do it as an exercise for different sizes. This will help you very much. For example, sometimes you need to expand your array in future in your models, add a dimension or something like that. So you need to generate sometimes some arrays with zeros and ones for different reasons. So this is the classes that this is the function classes of the NumPy that you can do it with zeros and ones, and how randomly you can generate different kinds of arrays. The last thing in this tutorial that we want to close this tutorial, it's about how we can do some logic in the NumPy arrays. For example, uh, and how we can filter actually by some doing some logics, how we can filter the numbers in an array, and we have different scenarios for that. So let's start, for example, from filter. Let's say it's filter underscore nd, something like that, or AR. Okay, just the name of your variable, and say, okay, I want to filter my the nd that I just this nd that I just created here. If you remember, this is our nd. Okay, not this one. Let's go for the integer one that we created with each other between 1 and 50. If you remember, rand r. Where is that? Okay, this is the rand r. I want to say that, okay, in this array that we built between 1 and 50 randomly, I want to say, okay, in this array, I need the elements that are more than 30 in the rows and less than 50. So uh, let's filter this stuff. So I want the elements between 30 and 50. So if I say filter the array that we just built, so we should say np dot. I want to use the logical. Okay, in here we have different types of logical and logical not. If you can see, it just suggests you logical or, logical nor. So let's say we want to use logical and, for example. So here you should mention x1 and x2 exactly as it mentioned here as a suggestion. First of all, I should mention that my array that is here, random r, I just copy and paste it here. I want my random array more than 30 and less than 50. So if I just run this, I should have different array that does not contain, for example, this 12 or this 14, okay, or this 13. So let's run this to see what will happen. So if I checked filter AR that I just created it, you can see that it gives me a true or false array. And if I open up my previous array, random R, so you can see I asked NumPy to give me that if the elements of the random R are more than 30 or less than 50, I want just this range. For 38, it's true, it's more than 30 and less than 50. For 40, it's true, but for 20, it's false. For 13, it's false. So it gives me an array of true and false that are not in this range. If it's not in this range, it gives me false. If it is in this range, it gives me true. So that's a very good thing that can help you when you want to know how much of how much of the elements of your array are in a specific range. So we can filter them by doing this. Uh, so if you want to filter out these things, so we can easily say, for example, the filter random AR that we just built is equal to, and I just copy and paste this name here and say filter AR inside of the brackets. So what I'm saying here is telling that, okay, I want to implement this filter that I just built, this array that I just built, true and false array. I want to implement it on the array that we built previously, random AR. In order to do that, I need to put the name of the array, the name of the filter array that we just made inside of the brackets in front of the array that we want to filter it. So we put this result in f underscore random underscore AR. And if I run this and check the f underscore AR random AR, this one, you can see that these are all the numbers that we filtered out. These are all the numbers that actually more than 30 and less than 50. Let's quickly check it with together. This is the array this is the initial array. We wanted the numbers more than 30 and less than 50. So this number should be there. This number should be there. This, this, and this. So they are all there. 38, 40, 35, 48, and 32. That's it. We just filtered out the numbers that we want, the specific range that we defined from that array that we previously built. This is very interesting exactly when you want to filter your array in future models that we will discuss. And this can help you. This is a very interesting method that NumPy has for filtering with different logic, and or and nor. So that's it for now. So we finished some of the important notes about NumPy. In the next tutorial, we will finish the NumPy with doing some statistics, using some statistics in NumPy, and it will be very interesting, and I'm very excited to start that. Until then, enjoy data science. Hello and welcome to this section of the NumPy tutorial. Actually, this is the last section of the NumPy tutorial. So we just want to review very quickly about how we can get the average, the variance, standard deviation, and median, some of the main statistical parameters that we are dealing with for the arrays in NumPy. And just to give you this hint that we are going deep into the statistical parameters like variance, standard deviation, and also the distribution that we talked about before, the normal and uniform distribution in the statistical part in this course. So if you do not understand some of the terms here, please don't panic. So I know some of the terms maybe and maybe not, maybe it's new for you, but we will go deep into it in the statistics section. But here we just want to review quickly what are the main statistics and how we can implement it on NumPy so we don't come back again. So the ones that we want to use a NumPy array are mean, that is the average. So all of you know how to make an average of an array or a list or a set of data. So you have, for example, n number of data. So you should just sum them up and divide them by n. So that will give you the average of that. So we should do the same for array as well. For the variance, we will go deep into the concepts in the statistics section, but just remember that the variance is the formulation is like this. We have the summation of xi minus the average of the x, the average of the data, and the square of this divided to n will give you the variance. And if we just take a radical sqrt from the variance, it will give us the standard deviation. And also the median is the middle number when we are dealing with odd number of data in our array, and it's the average of the middle numbers if we are dealing with even number of data in our array, even number of elements. So, for example, if you have 5 number, the middle number, number 3, would be your median. If you have 4 number, number 2 and 3 should be you should get an average of number 2 and number 3, x2 and x3, and that would be your median. So that would be x2 plus x3 divided by 2. So that's it. These are all the formulas that we wanted to implement on our NumPy arrays. So let's go back to our coding environment, and we will do it with together. So first of all, let's make an array. I know you are now expert in making arrays, so just make an array with me. Let's name it, for example, data and NumPy data. And this is a NumPy array np that's array. And inside of this array, I will put just one bracket and a list of data that is 1, for example, 3, just random numbers, 4, 5, 7, 9, something like that. So this is my array. So if I just click, select, and run this line of code, you can see that data n should be appear here. I love lots of things here. So this is data n, 1, 3, 4, 5, 7, 9. It's just one row of data. So this is our array. So if I want to get an average of this array, I should just say, okay, the mean of n is equal to np. Very easily, we use the classes of there are different classes for statistics in of NumPy. We just put n. You can see lots of classes as well here, but if you don't find it, the mean is used for getting an average. So I should just easily type mean. It's very easy, nothing very complicated. And inside of the parentheses, I should mention the array that I want to take an average in it, and then put it in the mean underscore n. So if I put this array that I just built, copy and paste it here. So what did we do is we actually built an array, name it data underscore n, and now we are using a class mean a class of Numpy library that name mean. And inside of the parentheses, we mentioned the array that we just built. And the result of this average will be copied and printed, will be printed in the mean underscore n that we just built, this variable. So if I select this and press run, mean underscore n should be here. Yeah, it is here. And you can see it's 4.83. So this is the average of this array that we just built. This array could be thousands of numbers. So it's easy right now. You can say, okay, I can do it manually, but sometimes it can help you very much to get an average in just a line of code. So the other thing that we want to use is a median. So median of array n that we just built is equal to np. Again, just write the name median. So yeah, that's suggestion. And inside of the parentheses, we should just type again the name of the array that we built, data underscore n. So if I select this and run this again, so you can see the median underscore n here. So it's 4.5, as you imagine. So you can do it very easily yourself as well. If we go to the data n, you can see that these are our numbers. How many data we have? We have 1, 2, 3, 4, 5, and 6. So it's an even number. So if we go to the middle numbers, it's 4 and 5. So average of 4 and 5 would be 4.5. So that's true. So if come back here, yeah, median of n is 4.5. So that's it for median, and we want to what happened? We want to also calculate the variance and standard deviation. So let's say var underscore n is equal to np dot var, very easily. And inside of the var, you can say again the name of your array, data underscore n. And if I select this and run it again, so var underscore n would be here, that is 6.8. So the standard deviation would be the SQRT of this number. So we can do it by the math class, or we can use this. We can say standard deviation underscore n is equal to np dot. So for standard deviation, we type std. So that stands for standard deviation. And inside of the parentheses, we should say, okay, give us the standard deviation of the data underscore n, that is our array. So if I select this and run, so you can see the standard deviation is about 2.6. That is actually the SQRT of the 6.8. So these are the main statistics that we wanted to learn: the average, the median, the variance, and the standard deviation. These are the main ones and very important ones. Sometimes you need them. And very easily by different classes of NumPy, we calculated the average, median, variance, and standard deviation. What are these parameters? Again, we will go deep into them in this statistic section, statistic tutorial of this course. So don't worry about that. Just remember how we can easily calculate these numbers, these statistics parameter with NumPy classes. So that's it. And also, I wanted for the last thing I want to mention is what if we don't have this array? What if our array has different dimensions, not just one? For example, you have 2 or 3 rows, or not just one row or one column. You have, for example, several rows and several columns. How can you calculate the statistic that you want on that? Okay, for this, for example, imagine that you want to For example, one of these arrays that we built together, which one of them? For example, this array that we built together at the start, if you remember. We just copy and paste it at the end so we can remember it. So this was the array that we at the start we built it. You remember num.array as our first array. We built a 2D array. Let's just run it again if you don't have it. So num underscore array, where is that? So it should be somewhere here. Yeah, here it is. So here you have 2 rows and 3 columns. So in order to, for example, you want to get an average or you want to get a variance or a standard deviation in a special row, for example. So you need to, what you need to do is, for example, say var of nump, that nump array that we just built is np dot var. So before we go into the parentheses, let's press Control I to see if we have something here. Yes, we have. So for the variance, as you can see, first you should, this is mandatory that you should specify the array that you want to get the variance. And this is the axis. The axis actually give you this option that even you want to go for the rows or columns. So this is very important. That the axis is optional and the default, for example, the default computes the variance of the flattened array. But if you want to imagine that, okay, I want the variance of my first row, you should, or I want the variance of my rows or columns, column by column, you should define the axis here. For example, let's say for numpy, nump underscore array that we just built here, I want the axis to be, for example, is equal to 1. If I do that, what will happen? Let's var underscore nump. Okay, let's check for var underscore nump that is here. You can see we have 2 numbers. What does it mean? It means that if I open the nump array, this was our array. So it means that numpy went to these rows separately, okay, this row and this row, second row, and for each row it gets the variance and it will print it here. So for 1, 2, 3, the variance would be 0.66, and for 4, 6, 7, the variance would be 1.55. So this means that with the axis, you can easily tell the numpy that goes to the columns or rows. So for axis 1, it goes to rows, but for the, if you can check here if it mentioned it. Okay, it doesn't, but for the axis 1, it goes to the rows. And let's check axis 0 actually with together. So var underscore num, this time, for example, 2 is equal to np dot var, and inside of the parentheses we should say nump array again, and here this time I will mention the axis as 0, not 1. So axis 1 was the rows. Axis 0, for sure, it should go for the column. So it should give me 3 numbers, actually, 3 variants. So if I run this, and I should search for it in a variable explorer to find var underscore nump2, you can see that we have 3 numbers. It actually goes to the nump array. If I open it up, this column would be 2.25. This column would be 4, and this column would be 4 as well. So you can see that it goes to the columns and it gets the variance for us, and it's just printed in a variable that we define. So remember that for the arrays, if you want to get the variance, standard deviation, or median, or mean for each row or for each column. You should specify it in the axis format. That's the rows are in axis equal to 1, and the columns are axis equal to 0. Just remember this. Or you can use the help anytime that you forgot. That's it. So these are the main statistics that we wanted to discuss. And congratulations, we finished the we finished the NumPy tutorial. So in the next tutorial, we will talk more about the other packages like Pandas. And that would be very, very interesting because we are actually working with real data sets. And yeah, that would be. I think it's more interesting that NumPy because NumPy is a little bit mathematical, but Pandas is a bit interesting, more interesting than NumPy. But I like both of them because you can work and you can use both of them in your models, and it's very important to be familiar with NumPy and Pandas before we go to the modeling and interesting stuff. So that's it for today. And until the next tutorial, enjoy using data science. Hello, everybody, and welcome to this tutorial. In this section, we want to start Pandas library. So we finished the concepts of the NumPy library, and one of the other important packages that we need them so much in our modeling and machine learning stuff is the Pandas library. Pandas is actually the abbreviation of panel data and is another open source library just like NumPy. And uh, this library is designed for working with data frame and series data. If you remember, NumPy was designed for working with arrays. Uh, Pandas is especially designed for data frame and series. But what are the series and data frame? Actually, the series are 1D arrays. The differences between the array and series is the labeling opportunity and possibility of the series. So data type could be numerical or string, no difference, but remember we can label them. So series are 1D arrays with labeling possibility. You can see here I just brought an example age 1. This is a series of 4 ages in this series. Age 1 is 10, age 2 is 20, age 3 30, age 4 is 40. So we are actually labeling these numerical values and giving them the labels age 1, age 2, age 3, and age 4. So the different several number of series will make a data frame, as you guessed. So Pandas data frame are 2D labeled data with different types of features, different types of columns. So you can for example, this column is the age, this column is the grade of the, for example, imagine that this data set is for students. We have 4 students, student 1, 2, 3, and 4, and we have different ages for the students. So student 1 age is 20, this one is 25, 27, and 30, and these are the grades that each of the students have. We call this data frame. But if we just have the indexes, the labels and also the age, this is a series. If we have several of this series, we are dealing with a data frame. So this is the difference between series and data frame. So let's go back to our environment and implement these examples on the coding area. So if I go to my spider, you can see that I have created, you can just click on this button that just delete all the things that you have done before. So now we are ready to start our new code. So here, the name of the editor that I just opened is not my name, so I want to change it. So first, I saved this file in the same section that I saved NumPy coding. So I saved it at this time pandas coding. So if I click save, it just changed the name to pandas coding. Now we are ready to go and start our coding. First of all, I want to put a title, just what we did for the NumPy. So here we say series, for example. We want to start with series. Let's have a first pandas and close this. And here, just like what we did for NumPy, I want to import pandas. So import pandas as, you remember we said import NumPy as NP, import pandas as, for example, PD. This is usual name. So you can say any other name, but PD is is the standard format, and you can just import pandas as PD. And then in the next line, I want to start with my series. So let's say, for example, I want to put another title named series, because these examples are related to series and I don't want to make them confused with the data frame. So if you remember, we had an example for the age and different numbers. So the label was age. Let's make our first series. So the series name is age, for example. And how we can make it, we can use this PD that we just imported pandas as PD. So we should just use this PD. And I want to use a class of this PD named series. So I say PD dot and series. Say just with typing S, you can have the suggestion series. PD dot series, and what is important is inside of the parentheses that what we should type here. So first of all, you should type your data as a list. For example, say if you remember, it was 10, 20, 30, 40, something like that. For example, 10, 20, 30, 40, different ages. And I want to label these numbers that refers to, for example, age number 1, age number 2, age number 3, age number 4, something like that. So for this, I just type index is equal to, and again I use a bracket, and inside of the bracket, because we are dealing with a string, not number, we should put it in a quotation. So just remember, anytime that you want to tell Python that this is a string, you should put it inside the quotation. So this is age 1 and comma, age 2 and comma, age 3 and comma, and age 4 and comma, no comma at the end. So this is our data, and we press comma, and then inside of the index brackets we just mentioned our indexes in the quotations. So that's ready. Our series is ready. If we just import pandas as well at the start, yeah, pandas imported, import pandas and PD. And if we just select this line and press run, you can see that our age here, the type is series, the size is this, and if I open it up, you can see it very beautifully. It says age 1 is 10, age 2 is 20, age 3 is 30, and age 4 is 40. This is the first series that we made together. So if you remember here for the NumPy, it was an array. Now that we're dealing with pandas and series, it's a series format. And the size is exactly the 4 numbers that we just give it to it, and the 4 labels that we defined for that. So we are dealing actually with a series of objects of pandas, and we opened it already. So this is the first one. Congratulations. We have built our first series right now with the pandas. We can call special index in our series. For example, let's call age number 3. We want to know that what is the age number 3? What is the value of age number 3? We can say age, from age, from this variable that we just made, give us age 3. Okay, if we just run this, you can see in the console that age.age3 is 30, and it's true. Age number 3 is 30. So you can even put this into a variable, so you can see it here, no difference. But this can help you. All these methods, especially in Pandas, they can help you very much in the modeling. So please remember these things. And exercise very much on these very simple examples that I'm telling you that can help you very much in future. So this is how we call a label. And the other thing that I want to tell you is what if we want to filter, for example, something? What if we want to say, okay, between these ages, I want just the ages that are more than 20. I don't want these two. So imagine that you are dealing with a data set with 1,000 in your series, and you want to filter some of the data as you wish. It's very easy. It's even easier than NumPy, what we did for filtering in NumPy. You should just say, okay, in this age variable that I made, dots, I want to say, not dots, I want to say, for example, let's say the filtered age is equal to, okay, age. And just for this, I use a bracket. And I say, okay, I want the ages that are more than 20. So what are you telling to the pandas? You say, actually, in this series that I built, uh, go and select the ages, the number of ages that are more than 20, and filter it and give it back to me in this variable, filtered age. If I run this, you can see that the filter age is actually included just two ages, 30 and 40, and that's because just these two numbers are more than 20. So if I say, for example, 10, this should be 20, includes 20 as well. If I run this and goes here, you can see 20 added. So I just filtered 10 from this series. So this is how you can filter some of the numbers from your series. It's very easy. Uh, and it's very straightforward. It's not like NumPy. You should use classes and stuff. It's very straightforward. You can just tell the pandas that, okay, just filter these numbers for me from the series that I built. And we can call the indices and also our values anytime that we want. For example, you can say age that's values, and that's it. If I run this, it's very straightforward. You can say age that values here is an array of 10, 20, 30, and 40. These are your values. Or if you want to call your indices, you can say age dots indices, sorry, age dot index. Yeah, this is the correct formats. And just if I run this, you can see that it just prints the indexes for us. So let's comment this to not confuse these two. So this is for calling values of the series. And this will give us calling indices of series. Okay, so these are all about the indexes. The other thing that I want to tell you, and it could be very helpful, we can also change the indices. This can help us very much in future. So if I want, for example, I can say that, okay, I don't want my index to be age1. I don't want my indices to be age1, age2, age3, age4. I want it to be a1, a2, a3, a4, something like that. You want to change all these labels. So what you should do is you should say, okay, I want my age dots indices or age.index should be equal to inside of the brackets. I can use my new indices. I can say A1 comma, again just like what we did, A2 comma, inside of the quotation A3 comma, and at the end A4. So these are all our new our new indices, and we want to replace these indices instead of this. So if I run this, you can, and if I check the age again, you can see that the age in indices changed from H1, H2, H3, H4 to A1, A2, A3, A4. So that was very easy, very straightforward. I just call the index, call the indices, and say to Python, okay, these indices are equal to these, not these ones. So just type the new indices in the brackets and give it and call the index, and that's it. That's the pandas go and change the indices for you. And yeah, we can call our new indices here age dot index, and if I run that here, you can see that our new indices are A1, A2, A3, A4. So that's all about the series that I want to tell you. The most important one is data frame that we will use actually in our models mainly, but I just wanted to tell you some of the examples of the series so you will be understand the difference between series and data frame. So in the next tutorial, we will go after the data frame and we'll understand the concepts with some of the examples. And until then, enjoy machine learning and data science. Hello and welcome to this session of the Pandas tutorial. So I'm very excited to start this tutorial because we are dealing with actually data frames, and the things are getting interesting, believe me, in this section. And we want to actually create a data frame together and work with that. And this will be actually the first step in the pre-processing that we will be discussing in future section of this course. But here we will learn how the basics of that pre-processing and using data frame and playing with it. So let's start creating our data frame with a NumPy array that we already created with each other. Just if you cannot remember how to create a NumPy array, just pause this video, go back to the NumPy, the previous session of this course, and we talked about it. Just think about it, pause the video and think about it a little bit, and then come back to video. So I'll start creating my NumPy array. I start creating my data frame with using a NumPy array. And first, I want to import the NumPy imports the NumPy library here. So NumPy as NP, if you remember, just like before. And these are all familiar for you. You should be familiar to it. And actually, our data frame could be for example, let's say df is our data frame is equal to NumPy array, and inside of the parentheses, if you remember, we had two brackets, and inside of the bracket one, we have row one. We have, for example, let's say 20, 10, and 8. And let's say the second row is 25, 8, 10. And the third row is 27, 5, 3. And the fourth one is 39, 7. 39, 7. Okay, just code it with me. It was very easy. np.array, parentheses, inside of the parentheses, two brackets. And inside of the brackets, inside of each bracket, I should use my rows. So my first row, my second row, third and fourth row. So if I just run this first
import NumPy. Okay, import it. And let's actually delete the things about this series so we don't be confused. So just click on this bottom close tab. It will actually close all the things that has been done before in your console, and in the variable explorer will be removed as well. So it will clean your editor and also console, and it will clean your console and variable explorer. So again, import NumPy, selected, import. So our NumPy array, our NumPy library imported. Just go back to here and import pandas as well. So our pandas is actually imported. So we imported our two libraries that we needed. So we use NumPy to create this array and our data frame initially. So if I select and run, you can see that we have an array like this that the size is 4 rows and 3 columns. And these are the numbers, values. And the type is array of integers. So what we want to do, we want to change this array to the data frame format. What we should do is using a class of pandas and say, okay, our data frame, let's say the name is data frame data, let's say our data set, okay, let's name it data set, is equal to, instead of MP, this time I use PD. So PD dot, and I want to change it to data frame. So I use data frame class. And inside of the parentheses here, I just mentioned the name of the array that I want to change it to data frame. What is the name of the array? It's df. So I just type df. So that's it. I'm just telling the pandas to use the data frame class and just change this array that I just built and change it to data frame format and put it in this variable that I named it dataset. If I select this and run, you can see that my data set here is created exactly as I wanted. And here, just compare the types with each other. This one is array of integer. This one is a data frame format. So that's exactly what we wanted. The other things are the same. The numbers are the same. The size is same. So we just change the type from the array to data frame. And these are the indexes 0, 1, 2. If you remember, the Python starts from 0. So the indexes start from 0. Also, my columns start from 0. So this is my data frame, but it's not look like what I needed. So what I need is changing these indices and also changing these column names. So what should I do? Let's start with changing the indices. In order to do that, we want to define actually what are our indices. We should say, okay, instead of telling this to pandas, let's copy and paste it here. So I want to change something. Just say, okay, data set is equal to PD that's data frame df. Let's check the control I and check the help. You can see that first of all, we should name the data that we mentioned. This is our data frame. And then we can define the index, but we didn't. If you don't, the actually the default is zero, is the numbering. It's 0, 1, 2, 3, 4. And for columns as well. Let's start with the index, and then we will go after column. So if I want to define my indices, I should just say, okay, here I should just press comma, type comma, and then say index is equal to, and I should just create a list of index. Here I use quotation, and inside of the quotation I should put each index that I want. So the row number 1, row number 2, row number 3, let's go to the variable one. So this is what we have. This number, this row, this row, this row, this row, these are all the indices that we should press. So the first one is actually, imagine that these are all students age that we discussed in the presentation, student's age, student grade 1, student grade 2. And these are two grades that refer to each student. So let's say that the student 1 is S1, student 2 is S2, student 3 is S3, and student 4 is S4. So we had 4 students here, and instead of 0, 1, 2, 3, we want our data set to mention that this is S1, S2, S3, S4. So remember this, if I close this one and run this one again and check the data set, you can see that our indices change to S1, S2, S3, S4. So here, when we are changing our NumPy array to the data frame format, we can actually define the index for it, the index for each row. So it's not very difficult. Just say index is equal to these numbers, just like what we did for the series, if you remember. So the other thing, but still, this is not complete. This data frame is not complete. Why? Because I don't know what is this column, what is this feature. I don't know what is 1 mean, what does 2 mean. So I need to change this column as well. So what I would do is just copy and paste it here. You don't need to copy and paste it in your code in future. I'm just doing this so you can understand the process. So after telling that, okay, this is my data frame, this is my array that I need to change it to data frame, these are my indices, you should say, okay, comma, and then define the columns for it. Just by typing column is equal to, for example, age. Okay, what are the columns? Let's open up. So the first one is age, so I should say age. The second one is the grade 1, if you remember. So I want to say, okay, this is grade 1, and the third one is grade 2. For example, from 2 different courses. These are the grades that the student 1 has, student 2, student 3, student 4. So age, grade 1, grade 2 are our columns, and we defined it. So if I run this now, what will happen? Okay, we got an error here. So it's good to check an error here. So let's say, okay, actually Python gives you exact information what is the problem most of the time. So the type error here is inside of the parentheses, you got an unexpected keyword argument column. So it said that, okay, this has a typo or a problem. I don't understand this. Just correct this one. So if we go back to the column, you can see that I had a typo. So I need to change this to columns. Now that's it. I think now that we corrected it. Yes, columns. So if I run this again, this should be disappeared. So this is the error. If you receive an error, don't panic. Just read the error for yourself and to find out what's wrong with that. And in the worst case scenario, if you don't understand the code, that it's most of the time it's super easy to understand it. But if you don't, just copy and paste it in the Google so you can find some other suggestions for you in your future code. So now that we corrected our typo, let's go back, select it, and do this. Yeah, done. Super easy. So if we go to the dataset again, you can see our dataset is now more beautiful. We have our indices S1, S2, S3, S4, and we have our column names or the labels of each column that is age, grade 1, and grade 2. So this is what we have done to change the NumPy array to data frame format. And The next thing that I want to mention here is for example, if you want, now imagine that you have been asked to add another column to this data frame that could be done with Pandas very easily. So what we should do, for example, somebody tell you that this data frame is not complete, you should add grade 3 as well. You need another column here that mentions grade 3. Okay, to add this, it's super straightforward. You should just say, okay, my data set that I just created, my data set, and inside of a bracket, you should mention the name of the label that you want to add. For example, say grade 3. This is the one that you want to add to your data set. And if I say this one, now you should define the values that you want to add to your column. For example, let's say 9, 6, 7, and 10, these four numbers. So if I select this one and run it, you can see that we easily added another column, another values with the label grade 3 to our data set. So it was that easy. So working with pandas is super easy if you understand the concepts. So here what we just did is telling the pandas that, okay, this is our data set that you created for us. And inside of the brackets, create grade 3 label for us. And this label 3 is equal to these values that we define. So this is a very easy and straightforward in order to add another column to your data set. That's it for this section. In the next section, we will talk about a very interesting thing and playing with our data set. So that will be very exciting. Until then, enjoy using data science. Hello, everybody, and welcome to this session of the Pandas tutorial. So in this session, we actually want to be familiar with two very important and interesting class of pandas named LOC and ILOC, or you can call it LOC or ILOC. So what are these? Let's see. For example, let's say for the data set that we created in our previous session, let's say data underscore sets, and I want to use I want to use loc, L-O-C. I want to use it for the label S2, for example. So we actually use LOC when we want to select special object or series in our data frame. So if I even go to the hub, so you can see that here it mentions that for LOC, the definition is access a group of rows or columns by label or a Boolean array. So this is very important. By what? By labels. So just remember this one. And if I run this, for example, I want to say that in this data set that we just created with each other, I want this row. I want to access this row. I want to see the values, different values of this row. So I mentioned that data set, that look, that is coming from location of S2. Just show me the location of S2. Show me the row of S2. So if I run this, you can see that immediately it brings the location of S2. It actually brings all the values in the row S2 for me. That age is 25, grade 1 is 8, grade 2 is 10, grade 10 is 6. We can also put this into a variable. For example, we can say A is equal to dataset.log S2. You want to extract a row from your dataset and put it into another variable to use it in future, for example, something like that. So this is when exactly we want to extract a row using a label or index in our data set. But what if I don't know what is the name? I just know that I want, for example, the I want we want S1 student one that is index one, and we want grade three. So let's check the data set. I want this and this number, this 9. I don't know the name of S1 and grade 3 and this stuff. I just know that I want the first row and fourth column, okay? First example or sample, fourth feature. What if I want that? I should say, okay, if I want to use lock again, I should say data underscore set dot again look. And inside the look, I should say, for example, first row, and in the second bracket, I can say third. It's not third, it's actually fourth. If you remember, this is very important. Just uh, review it with yourself several times and exercise it, because it's very important that Python start with zero. Zero actually the starting points for Python. So when you say this is zero, this is one, this is two, this is three. So grade three is not four, it's actually three, because Python starts from zero. So if you want to address S4, you should say 0, 1, 2, 3. So this is number 4, but you should address it as 3 in Python. It's a little bit strange, but if you work with it very much, you will do it automatically, just starting from 0, not 1. So I want grade 3 that is 3, 0, 1, 2, 3, and first index student 2, for example, I want student 2 and grade 3 because I mentioned 1. If I want to mention student 1, I should mention 0, okay? I want a student 2 and grade 3, that is 6, okay? I want this number. So I should say 1 and 3. Let's run this to see if it works. Okay, as you can see, we have an error here. Cannot do label indexing in this class. So it is telling us that this class that you are using, look, is not for is actually for labels and not for numbers, and you should use another class. What is the other class? The other class is actually iloc. So if I say data underscore set, sorry, dot iloc, and then inside of the brackets I use one and also 3, just like previous one. Let's see what happens. What will happen? So if I run this now, it will give me the 6. So we are waiting for this number, row number 2, that is 0, 1, and column number 4, that is 0, 1, 2, 3. So we say 1, 3, and it should give me 6. With the iloc, I did it, but with look, no. But look, we use it for when we wanted to call the index name, so the label, we know the label. When we want to number it, we use iloc. So I hope you understand it well until now. So the difference between using loc, L-O-C, and iloc as iloc. And also you can do something better. You can use it like this. You can say data underscore set, that's iloc, and inside of the bracket, not separate brackets, we can just say, okay, this is 1 and 3. It mentions that the first one is the row number, and the second one is the actually column number. So that will give us again 6. If I run this, you can see that, okay, so I had a typo problem here for the sets. If I correct this and then do it again, you can see that we have 6 again. So no difference. You can type it in separate brackets. You can type it in just one bracket and separate them with comma. It's up to you. And also, I want to tell you that's how we can uh, use iloc to do fun things. So let's say data underscore set that's iloc. And this time I want to say inside of my brackets, I should say, if you remember this, uh, the column mentioned that all the rows. When I'm saying, you remember the previous one? One, it refers to rows, three refers to columns. So now the first one before the comma is mentioning the rows, the second one again column. I can say instead of this number, I can say column. This column means all the rows. I don't want to separate each row. I want all the rows, but I want to specify my column. And my column is, for example, 0. 0 means the first one. So if I open this up and you can understand better here, I don't want to say I want this number in this specific row. I want to say, for example, I want the whole row, the whole column, but for all rows, but for the first column or for the second column. You can do this vice versa as well. But let's put it this way: that I want this column, H column, for all the rows. Okay, you don't want to specify, for example, as two rows. You want all the rows, but for each column. You can say all the rows, give me all the rows, and the 0, 0, 1, 2, 3, this is 0. So 0 or first column. So if I run this, now you can see it will give me the number S1, the age column actually for student 1, student 2, student 3, and student 4. And you can see the name of the column and the type of the column that is integer. So that's how we can actually use iloc. It's very interesting. You can use it in so much times when you want to, for example, extract a row, extract a column, lots of things. You want to separate a column or some of the columns from some of the other columns, some of the rows from some of the other rows. So it's very easy to use this iloc thing. So you just should give it the index number or the column number and it will do it for you. That's very easy. Let's do one other thing together. For example, I want to say, okay, in this, I want to separate me this grade tree, separate it for me and show it to me, or for example, print it in another variable. So I want grade trees. Let's say data underscore set. Okay, just type it again wrong. Uh, data underscore set dot iloc, and inside of the brackets, I want to type all the rows, comma, and what is the number? Okay, it's 0, 1, 2, 3. It's not 4, it's 3. So I want number 3, column number 3. So if I run this, I should get these numbers. Yeah, I did a 9, 6, 7, 10. 9, 6, 7, 10. That's numbers for grade 3. So that's it. You can easily use this iloc and loc thing in order to extract data that you need from your data frame. Uh, and also, it's not just like this. You can also expand it to something like this. Let's do one last interesting thing with iloc. Imagine that this is our data frame and I want to, for example, let's say defining a range. For example, I want all the rows, S1, S2, S3, S4, and I want not just one column, I want, for example, this column and this column, grade 1 and grade 2, okay? So I want these two columns. What should I do? Here, we should say data underscore. Even this time I can put it in another variable so we can understand how we can just put them into other variables. So let's say, for example, this one here named filtered data, and filtered data is equal to data set. I want from data set, I'm telling pandas, okay, go and from the data set that I defined, use iloc class, and in iloc class, give me all the rows And from all the rows, I want 0, 1, 2, 3. So as you guess, this is 1, this is 2. 0, 1, 2. 1 and 2. I want 1 and 2, but I don't say 1 until 2. Why? Because the other trick that Python has is it starts from 0 and it also ends not in a number that you define. So if you want Python to end here, you should mention this. So it doesn't count the last number that you define. So if I say 1, 2, 3, it starts from 1, 0, 1, 1, 2, and it stops in 2. It doesn't go to 3. So this is another trick. Just believe me, I promise this is the last trick that Python has. So just remember these two. It starts from 0 and also it ends not in a number that you define, it ends one number before that. So if it's 1, 2, 3, it means that it's just 1, 2. It doesn't count 3. So we just want these two columns. So I say all the rows from column 1 to column 2. So this 3 is not counted. So that's it. If I close this and run this again, and if I check my filtered data, you can see that we extracted beautifully our grade 1 and grade 2 columns from our data set. So this is very, very helpful in the pre-processing stage that we are going through. So just practice this very much after this session with yourself. So it is very interesting using iLock and lock. That's it for today's session. In the next session, we are going to some other interesting things about the pandas. And until then, enjoy using data science. Hello and welcome to this session of the Pandas tutorial. So in previous session, if you remember, we talked about how we can use the look and iLook class of the Pandas, and it was very useful for us. In this session, we want to actually be familiar with other types of classes that Python that Pandas has, and it can help us very much in the pre-processing section. So, for example, imagine that we have, let's check our data set again, if you forget about it. So we had 4 rows, students 1 to 4, and different variables or different features here, age, grade 1, grade 2, and grade 3 as our columns. So let's put this here to not forget what we have. And let's say I want to actually drop this column. I don't want this column. This is a redundancy in my data set. So I want to delete this, remove this. How should I do it? It's a very straightforward line of code for this in Pandas that you can use drop class. So you can say data underscore sets that we already made it. This is the name of our data frame. Dot, you can use drop, yeah. And inside of the parentheses, you can use the name of the actually the label that you want to drop, the name of the column that you want to drop. So inside of the quotation, inside of the parentheses, we mention grade 1. Okay, so this is actually our column that we want to drop, we want to remove. And also I need to define the axis, that's because Python doesn't understand that which elements do you want to remove. Actually, you want to remove just this line, this number, or you want to remove the whole column. So we need to define that if it is in a row axis or column axis. So for this, I need in a column, I want to drop this column. So I should mention that the axis is, if you remember, for the column, we use axis 1. So if I say axis 1, it mentions that in the vertical way, go and remove this column, grade 1. So this is very straightforward. In datasets that drop using this class of pandas and say that, okay, in the grade 1 column, in the vertical way, just drop this for us. So if I run this and now check my data set again, oh, sorry, it was open. So let me run this and put it, if this is what we have here. If I put it again in a data set, it will copy it here. But this is what we're doing here. It's just showing it in a console. If I want to change it overly in here, I can say, for example, data set is equal to data set that drop. So the results of this will be copied in our data set. So this will be removed and we have something like this. But we don't want to do that. So just wanted to show you how you can do it. This is the first thing. In order to drop something from your data frame, drop a column or row, you can just define the axis and you can do it very easily. We can also let's check another important feature of pandas together. So we can replace any number in our data frame with replace comment. Imagine that in our data set, in our data frame, actually, we have number of tens, okay? We want to replace these tens with 12, something like that. So this is not true 10 here. We want to replace them. What should we do? We should say, okay, in our data set, let's actually do this and change it there. So let's say data set is equal to data set. This time I say replace. So you can see it's all straightforward, nothing very unusual. Replace, and inside of the parentheses, we should say what is the exact number and what is the number that we want to replace it with. So the replace number is 10. The number that we want to replace 10 with is, for example, 12. So if I run this now, and if I check my data set again, you can see the 310 number that I had, now it changed to 12 very easily. So I use the replace method in order to change my 10s to 12 in my data set. That's another one. These are all the important methods that I'm telling you. There are lots of them, but I'm just telling you some of the important ones that we can use them in our future models and in our pre-processing stage. The other thing is actually you can use also dictionary for this and replace any number or string. So, for example, imagine you want to replace several numbers. I want to replace this 12s with 10 again, or with 9, for example. Let's do it. Let's say data set is equal to, again, data set, because I want to copy it here, dot replace, and inside of the parentheses, let me change the location of this so you can see it. Inside of the parentheses, so data set is equal to data set dot replace, because I want to copy the results in a data set again so I can see it here. If you don't want to do that or just want to see it in console, you shouldn't write this. You should just say data set dot replace. So we want to change, for example, 12 to 9, and also 12 to 10, and also we want to change, for example, 25 to, or 9 to 30, for example. 9 to 30. You understood that, for example, here 9 is not a right number. I want to change it to 30. So let's say 12, again, I want to change it back to, I want to use a dictionary. So inside the dictionary, if you know the Python syntax, for the dictionary, for creating a dictionary, you should use accolade. So inside of this, I say, okay, I want to replace 12 with I use colon with 10 again, and with comma, I separate that and I say, and I want to change 9 with 30, something like that. So for the dictionary inside of this, I actually referred to two sets here, 10, that 12 that will be replaced by 10, and 9 that will be replaced by 30. So if I select this, let me close this. If I select and run this and then open it up again, you can see that we again change it to 10, and also the 9 has been changed to 30. Each 9 has been changed to 30. So that's when you want to change several things, several numbers, you should use dictionary for that. We have lots of other things, as I mentioned, but I want to teach you some of the important ones. If we have very large data sets and we want to check just some of the first or last rows, we need to use tail and head method. That is very useful, especially for data scientists. They use this very much when they want to check up very quickly their data sets. They use this. For example, they say, okay, my data set dot head. I want to see, for example, three first rows, something like that. So you have a data set including thousands of rows, and you want to just check three first rows in order to understand what are the types of the data and these things. So just run this and it will give you three first rows for you. So this is what we call head of your data set. So if you want to check the last rows of your data set, you can do it by data underscore set dot tail, and for example last two rows of your data set. And if I run this just like before, these are my last two rows. So this is especially important when you're dealing with big data and you have lots of data, thousands, hundred thousands of rows, and you just want to check the first 10 or first 5 or last 5 rows. I told you this is very useful sometimes when you're dealing with big data sets. And just remember it's that head and that tail, very straightforward. And inside of the parentheses, you should just write down the number of rows that you want to see. Uh, Now let's talk about another thing. If we want to sort our index or values, indices or values, again, we should use the axis numbers. For example, imagine that we want to, okay, let me say, for example, the data set, give you an example so you will understand it. Data set. We want to say sort method, sort value. So we have two things. You can see that I have two suggestions here. Sort values or sort index. If you don't have this suggestion, you can just press tab and it will give you the suggestion. Sort values and sort indexes. So sort values, I want to check this. And inside of the parentheses, I want to say sort values in axis. What axis? In axis 0. So axis 0 is for rows, axis 1 is for columns. So when you say axis 0, it means that it goes to your rows and actually sorts the values in the rows by the ascending or descending order. In order to do the ascending order, you should just say A as C ascending. Yeah, this is the suggestion. Ascending is equal to true. It means that I want it to be in ascending order. If you say ascending is equal to false, you are telling it I want it to be in a descending order. So that depends to you what you want to do. So we use sort value method, and inside of the parentheses, I define the axis that is 0, and I also define if I want to sort it as the ascending or descending. So if I just let's first check this. So these are our numbers if we want to sort them out. So if I run this, uh, okay, so I think we have a problem here for the, it is telling us that the sort values missing one required potential arguments by. So let's check that. Let's check the control, press Control I to see what are the parameters. So these are the parameters. So by string or list of string, name of the list of a string sorted by. So we can say, for example, in the sort values, I want to say, okay, I think, okay, here it's this axis is especially for the sort values when we want to sort the indexes. Actually, for the sort values, we need to, for example, we want to say in this column, sort the grade for me. So I should say here the grade 1 in the quotation. So it actually comes and sort the values for us in this column for grade 1. Sorry, I made a mistake because sort values is actually for sorting the labels. You should mention the label. That's why it's saying you need another potential argument. We need to define which columns, for example, column grade 1, and in an ascending order. So in a descending order. So we have 10, 8, 5, 30. So it should be 5, 8, 10, 30, something like that. So if I do this, it will do it exactly in the descending order for us. So it is 30, 10, 8, 5. So we are telling it ascending is false. So if I do this for ascending order and run this again, it will give us 5, 8, 10, 30. So that's how we sort the values for each column. I can do it for ascending or descending. What I wanted to do in the beginning, and I did it wrong, so it was for actually sorting the index. You can do that as well. It's data underscore sets dot sort the index, not values, but index. And inside of the parentheses for sort index, again, we should say, this time, we should say axis is equal to 0. And for example, you want to test the ascending order. So it's ascending is equal to true, for example. So if I run this, okay, again, and an error. So here we have, I think I have a typo. So typo or something. We have an expected argument sending. So yeah, it is a problem of just we can copy and paste this here. So sending is true. So this shouldn't be a problem right now. And if I run this again, yeah. So you can see that my data set in the indices, it is actually sorted from 1 to 4. If I make this false, let's see what will happen. Uh, if I make this false, what will happen is it will start from S4, S3, S2, S1. We actually sorted our indices in the descending order, not ascending order. So it will start from S4. So that's how you can play around with sort values and sort indexes. So you can use sort your values in different columns or based on different columns and features. Or sort the indices based on the axis. For example, say that axis is 0, it comes and it goes and just sorts the indices for you based on descending or ascending order that you are telling it. So that's another important thing. At the end, I want to show you one of the very useful things that for sure if in future we will use it in the beginning of our code. That is how to open a data frame in a CSV format or Excel format or something like this. For example, you have your data in Excel or CSV format and you want to open it up. We want to use Pandas package actually in order to do that. And I have an imaginary data set in the CSV format, and I created in the Microsoft Excel. And first, we need to set our console as a working directory. Let's say you see these three lines here. Just click on this and push this button that set console working directory. By pressing this, you are actually telling the spider that where my data is saved is actually where this editor is saved. If you remember where did you save your code and where did you save your code that we just wrote together, and just put the CSV file or the Excel file, the CSV file that I had that I you can download it in the resource section of this course, resource section of this session exactly. By clicking on it, it will be downloaded, and just copy it in where you are coding, in the place that you are coding. If you remember, we just copy this in a folder that we made in a test folder, and now if I press set console as a working directory, it will understand that my file is in this row, Udemy machine learning test, this folder that we built. And now I want to open it up. So let's say my data is equal to PD. So this is the line of code, PD that's read. So as if you don't have this suggestion, just press tab and you can see different types of read options that Pandas give you. You can have read CSV, you can have read Excel, read table, read SQL. So all types of all formats you can have. So it's a wide range of format that Pandas give you. Let's say mine is CSV. Okay, just double click on this. So pd.read underscore CSV, and inside of the parentheses, we should mention actually what is the name of our file. So the name of my file is power underscore data. You can actually download this CSV file and you can write the same thing with me. And do not forget to add .csv here because it doesn't understand. You should define the format here, name and the format inside of the parentheses. So that's it. Now if we run this, it goes and read it for us. Just the last thing, if you don't want to go for this process and setting the console as a working directory, just copy and paste the destination folder here that's saying that, okay, if it's, for example, in your drive D, for example, or drive C, or the name of your drive, hard drive, and then you should use colon slash and the name of the folder and the name of the file, and just copy it here, copy and paste it here. So you can do that as well. And if I run this now, you can see that the file power underscore data.csv does not exist. Maybe I pressed it twice. So if I check it now, so the name was power underscore data and that's CSV. Yeah, that's true. So if I run this again, I have a problem. So I should go and check what is wrong with this data set. So it was power underscore data. So if I just go and open, I changed the name to data set. So I should just copy the name data set here. So this is my coding. This is what I told you. This is my coding, Pandas coding. And this is the name of the data set that I want to enter. So I just entered it wrong. So the name is dataset. So I should just say, go and read data set underscore CSV. Is it right? Yeah, data underscore set dot CSV. So if I do this again and run this time, yeah, it should do that. So you can see that data is here. And if I open it up, you can see my data set. It is not clean, it is not good, but we will take care of this in the pre-processing stage. I just wanted to tell you how we can read a CSV file or Excel file with using the method of pandas. So one of the method of pandas. So that was very interesting when I first learned it. So we will use this one exactly very much in the pre-processing stage when we want to actually read our data from the external source. And we will use actually all of these methods of pandas because they are very important and interesting in the pre-processing stage. We will use all of them in a pre-processing. So I'm very excited to start the next tutorial that is actually about the statistics, and then we'll go for pre-processing, and that will be very interesting. So until then, take care and enjoy data science and machine learning. Hello and welcome to visualization tutorial. So in this tutorial, we are going to understand what is visualization and how we can do that. You know, visualization is very important part of data science and machine learning. You need it in different sections. You need it in processing stage. You need it for understanding your data. You also need it, you even need that even after developing your model, you need that to evaluate your model. So it's a very important stage. So you should learn that and use that in different stages of developing your machine learning model. So to start, there are different packages in Python that we can use them for visualization. For example, we have Pygel, we have Seaborn, we have Bokeh, we have Plotly. But the one that we want to use in this course, and it's very famous, very popular, and also it's very easy to use it, is Matplotlib uh, package. It's very complete. So you have a vast range of visualization that you can use. So to do that, let's go to our coding environments and let's see what we can do and start with some examples. So as you can see, I made an empty editor. So here I want to start. I started with topic visualization with Matplotlib. You can do that. And then I start with using NumPy, importing NumPy and Pandas that we learned before. Maybe in our code we need that, so maybe not, but let's import them. So import NumPy. We usually use NumPy in our coding, so it's very good. So it's very good that you import it at the beginning of your code each time. So import NumPy as MP and also import pandas as PD. So now that we imported pandas and NumPy, let's go with Matplotlib. Matplotlib has several sub packages, and we want to start with easy graphs. So let's start with pyplot sub package. First, let's import it just like what we did for NumPy and pandas. So in order to import that, we say import again, Matplotlib, just the name, Matplotlib. You can see the suggestion is pop out very fast. Matplotlib dot pyplot. So what we did is from the Matplotlib package or library, we used another sub package named pyplot because we want to use pyplot from Matplotlib. So from import matplotlib.pyplot as just like what we did for NumPy as pandas, and we made abbreviation for them. So let's make an abbreviation as PLT. So we imported our package, our subpackage pyplot from matplotlib package as PLT. So anytime that you want to use this subpackage from matplotlib, you should use PLT. That's it. And now let's start from a very easy example. Uh, so uh, let's go back to the PowerPoint so we understand what is the data that we want to uh, right now. Okay, so this is our data. You can see that, for example, someone give you this information, this data. It has two columns. One of them has years, and the other has the temperature index. I just download this. These are real data. Actually, I downloaded them from NASA data source, and you can see the source and credits. And I wanted the first example to be interesting for you, so we want to know how much the temperature of the Earth, the temperature index of the Earth, of our Earth change. And you hear all the time about the global warming and stuff and climate change. So let's see that visually. Let's see what is happening in our Earth and how much the temperature is changing during the past 10 years. So these are the data that you want to actually plot them, that we want to make a graph by these two columns. So if we go back to our coding environment, I just made a draft editor. So I entered the data that I just showed you here to not take the time very much. So I just copy and paste this here. And let's name this, for example, year, and name this one, for example, temp underscore index. So you can pause the video now and just enter these numbers as a list for yourself here, just inside of the brackets. You made a list for year, you make a list for temperature index, and then come back to the video. So after you entered the data for the year and temperature, we have our data ready as two lists. And now we want to actually visualize our data by plotting a line graph. So how to do that? We say we actually imported the matplotlib.pyplots as PLT. So we want to use this PLT that we imported. And so we say PLT dot. So we have different options. The line plot or line graph actually uses a plot function. So we say this plot method, and inside of the parentheses, I should mention the X and Y. I can even check the control I if there is something here, I don't know. Yeah, you can see that you should mention the arguments, and also you can tell the plot the scalar stuff, or you can make it as just remain as the default. So I should mention actually the X and Y, my horizontal and vertical axis. So my horizontal axis is actually, my X is actually year, and my vertical axis is temperature index, or Y is temperature index. So just by putting X and Y of your plot here, and by selecting this line, okay, sorry, first let's import these libraries, select all of them, and press Run button. So you can see we imported the libraries. If we go to the variable explorer to see our data, let's select these ones and press run. You can see we have now our temperatures and also our year as a list. And if we now say, okay, plot this year and temperature index for me, you say to matplotlib plt.plot x and y. And if we press enter, you can see that the graph will show up. So this graph will pop up, and this is our graph. This is a line graph of temperature index of Earth from 2010 to 2020 as a line graph. Now that we have the graph, we made the graph very easily, but it is not complete. This graph is not complete. This is not what we wanted. We should add some information. We don't know what is this vertical axis and what is this horizontal axis. And we need some information. What is the title of this graph? We just have a line graph. We don't have any information in this graph. So we need to add some information. To do that, we easily say, okay, after this line plt.plot, I should say plt, I want to say, for example, I need to add X label here. Let's say I want to add X label and Y label here and here, and I want to add a title for my graph. So I would say plt dot plot plt dot X label. So you can see it suggests to me. And inside of the X label, you should mention inside of the quotation that what is your X label. So my X label is year, yeah? And we should do the exact same thing for Y. So we say plt that Y label, and inside of the parentheses, we should say temp, for example, index. So these are our X label and Y label, and we need to add a title. Again, very straightforward, very easy. We say plt dot this time title, and inside of that, I mentioned, for example, I want one title to be global warming, something like that. Any title that you like inside of the quotation. Don't forget, because we are using string, we should put it inside of the quotation or double quotation. So another thing that I want to add here is the last thing. I want my first let's run this to find out something. So at the end, do not forget to all the time, every time that you plot, use plt.plot and you plot a graph, you draw a graph for yourself. Just do not forget to add this one, plt to show and parentheses empty. So this can help you actually to render our graph at the end of the matplotlib code. So just add this to every plot that you want to draw and plot. So that's it. And now if I run this again, if I go to my graph, you can see that this time my graph has some information in it. This time my graph has a title, my graph has Y label, my graph has X label. So we add several information in this. There's another thing. For example, we can even tell the matplotlib that change the title section for us, title location for us. For example, I don't want my title to be here. I want it to be here at the right, or I want it to be at the left, not center, something like that. And also, you can say what is the font size that you use for this title. So let's do some changes and come back. So let's say, for example, I wanted to use a dictionary, so I use this, and inside I say font size. I say my font size is equal to 12, something like that. And the other one that I want to mention is inside of the quotation, I mention horizontal alignment. Oh, sorry. Horizontal alignment. I don't know if I have a typo or not, but I should mention horizontal alignments. I think it's right. So if I now mention this horizontal alignment, you can say it's center, it's left, right, something like that. Let's say it's in center. So if I run this again and go back to my plots, you can see that I changed a little bit the font size. I made it a little bit smaller. I can change it to the bigger size or smaller size. And if I say here, for example, left side, it will come here, the right side, it will come here. So that's how you can change the alignment and the font size of your title. So that was for the start. So I just wanted to show you how you can use the PLT, the PyPlot sub package uh, in order to draw a graph, a very easy line graph for yourself. And it was very easy, very straightforward. So we use plt.plot, our x and y, and x label, y label, and title, and that's it. You made your graph. So in the next session of this tutorial, we are going after more complex examples and different types of graphs and what we can do, several tricks. So I'm very excited to start the next session of this tutorial with you. Until then, enjoy data science. Hello and welcome to this session of the Matplotlib tutorial. So in this session, we want to go deep into the visualization with using Matplotlib a little bit more than the previous example that we did in the previous tutorial. So let's say we have several mouses and we have two customers that each one of them has its own building, and each building has its own consumption of electricity. So we don't care about the units and stuff. We just want to draw this. So just focus on the numbers here. These are the numbers that like customer one is consuming during the year, during each month. And these are the numbers that customer two is consuming during the year and each month. So let's go to our coding environment and draw this. So here was our previous code. And now we want to start with the second example. So I wrote in a draft just like what we did before. You can just pause the video here and write down these for yourself as a list. So this is our mounts in the string inside of the bracket. January, February, March, April, May, June, July, August, September, October, November, and December. Just do not forget these quotations inside of the bracket. And the customer one is a list of consumption of electricity. I just made a list, and here for customer two, I just made a list. So if I select all of these and press run, you can see that now we have our customer one as a list, our customer two as a list, and our amounts that each customer is using, consuming electricity as a list. So we made three lists here. So the next step is to draw these. So let's ask Matplotlib to draw for us. My suggestion here is pause the video and do it yourself. So just like the previous example, just like what we did for previous example, you remember we just used PLT plots, year, temp I, and these things. So just plot these just like what we did before, and then we can continue. So if you did that, let's continue and do it with together. This time we want to define more things, but let's start with something simple and say, okay, PLT dot plot, and inside of the parentheses, I want to mention mounts as my X and customer one as my Y. Okay, let's go to the next line. I say, okay, PLT dot plot again, this time for customer two, we want to do this. So plt.plot, and inside of the parentheses, again, mouse is our X, and this time customer 2 is our Y. So, and the next line, as you imagine, is plt.show, like we always do. So if I run this, it's very easily give me this plot. Uh, this plot will pop up, but this plot is not very informative. So we need to give it some information. We don't even know which one of these line graphs are for customer 1 and which one is for customer 2, because we did not define that. We just tell the pyplot, okay, draw this graph for me based on mounts and customer 1, mounts and customer 2, and that's it. But we need to give some information so our visualization will be more informative. So we need to define legend, for example, in order to find out which graph is related to customer 1 and which graph is related to customer 2. We need to define X and Y labels. We need to define the title. We need to even change these colors. We don't like it to be orange and blue, or we want other colors for that. And lots of other things. So let's go deep into it and change some important things in this visualization so we can make it more informative and more informative and more beautiful. So to do this, I start with, I can even copy and paste this here and work on these lines. So let's say, for example, for plt.plot mounts and customer 1, the first thing that I want to add is the color. So before I mention this, so very easily you can write down color and you can put equal to in a string. For example, you can say I want it to be red. That's it. Very easily, very straightforward. But what are the colors that if you want to check the colors that Matplotlib has? So if you go to the website of the matplotlib.org, and in the gallery section, in the color section, you can find different types of colors that Matplotlib has. So you have a vast options for yourself in order to draw your graph. So you can have different types of colors, and just by copy and pasting these names into your quotation, that's it. It goes for that. So, for example, if you want even strange colors, like, for example, I don't know even the name of some of these colors, but yeah, you can have them by just writing these names inside of the quotation. So let's go back to our coding environment. So let's say this time I want something simple. So I want the color of my customer 1 to be red, the line graph. And then comma, and then I want to define the label for it because I want a legend. I want to know what line graph is related to customer 1 and what is related to customer 2. So you should define a label in this stage. And for labeling each graph, oh, what happened? Sorry. For labeling each graph is equal to, uh, I should say, for example, inside of the quotation, again, I should say customer 1. And you can define any name that you want to label for this graph. It has not to be equal to this, the name, actually the name of the list. It could be something different, but I want to mention this customer 1. So, and again, comma, and the other important thing here is when you want to have a marker on your graph as well. For example, imagine that you don't want a simple line, you want some markers on your line graph as well. For example, I want to say marker, my marker is equal to, and inside of the quotation, I use this. And what are the markers? What are the different markers on Matplotlib? Let's go back again to my browser. And here I can show you some of the Matplotlib markers. So you can find them in matplotlib.org in a marker section. or you can just Google it and find it out. It's not very difficult. You can just search matplotlib markers, and it will direct you to this page. So as you can see, we have different kinds of markers. For example, if you want to use circle, you should use this. This is the one that I use right now. You can use double quotation or quotation, no difference. And for example, you can use triangle, and you should use this one. And you can use square, and you should use S inside of the quotation or double quotation. So these are all the markers that you can use to make your graph more beautiful and distinguish the one line from the other. And yeah, that's it. Let's go back to our coding section. So I want my first customer marker to be like this, circle. And I want to close this. And for the customer two, even I can copy and paste this and change the parameters. So here I say, oh, do not forget the comma. And then I say the color of the customer two, I want it to be blue, for example. You should just write the name of the color that you want. You have lots of options. And the label is just change the one to two. And the marker that I want to use here is, if you remember, this was one of the markers. For example, I want to use this. That was a triangle, I think. And yeah, that's it. And I want to say, okay, I want to say my x label is months. You should define the x and y label. So I want to say my y label plt that's y label. Inside of the parentheses, I should mention, for example, electricity consumption. I don't know if I have a typo or not, but electricity consumption is my y label and my x label is months. So that's it. And also do not forget, we need to still remain two steps remain. So we should say plt dot title. First of all, we need to define the title for it. And the title is, for example, buildings consumption, something like that. I need a P here. So yeah, that's it. And I need an L here, I think. Yeah. And plt dot at the end legend. So with this one, you don't need to add something here, but if you want to change the location of your legend, you can use something here. But first, let's not put anything here. So with adding this line, you actually telling Matplotlib to go after these labels and define these labels as a legend for me. If you don't define these labels, you cannot use this line. So we first define our labels for each of the line graphs, and then we say, okay, plt.legend, and put the legend in my graph. Now, I think we are ready to go, but we will do some changes after it. So let's run this, select, and run. Wow, you can see a very beautiful graph just popped out. I can even make it bigger, so just like this. You can see that we have electricity consumption here. We have our Mouse's X label here. Now we know which one is which one is customer one. The red line is the customer one. The blue line is the customer two. And the also we have a marker on it, so it makes it very beautiful. So and we define the color of each line. We define the customer two as blue and customer one as red, if you remember. So now I think we are in a good position. You even can change the position. If you remember, you can change the position of the title, as I taught you in the previous session of this tutorial that you can use center, right, left. Also, you can use, for example, you can change the location of this legend as well. For example, you don't want it to be here, you want it to be in the center. You can say, let's do that. For example, you can say here my location inside of the parentheses of the legend. You can say loc, that is actually your location of the legend. Loc is equal to, and inside of the quotation, you should mention the exact location that you want it to be. What are the locations? So if we go again to Matplotlib website, I can show you another last thing actually that you need to know. So these are the locations that you can have. For example, if you don't mention it, so the default is the best. So the Matplotlib goes after it itself and it find the best location based on your graph. So I suggest that if you don't insist on changing the location of your title or location of the legend, just put it as default and Matplotlib do the best for you. But if you insist on changing the location, these are the locations and also the location code, you can use these codes, or you can use the names upper right, upper left, lower left, and change them. For example, if I want to say that, okay, I want it to be in lower left, okay, and just copy this. And if I go to my coding environment and just paste it here, I want to be lower left. So if I run this again, you can see my graph is now the legends are in the lower left. So because so you can change this location as in any place that you want. So let's put it as the default for right now. And just for your information, I want to say, for example, lock is upper right. It's a better place to see it. So the upper right is the location of my graph. And yeah, that's it. You for now. Now let's imagine you don't want to plot in one graph. So you want to say, okay, let's see this. You want to say, if I run this again, you want to say this graph, I want it to be in two separate graphs, not just in one. Two separate graphs, but beside each other. I want a graph here, I want a graph here, and but separated. What should you do? Sometimes you need that, believe me. So what you should do is using subplots to do this. And how it works, we should use subplots. In the subplots, let's actually find it. Let's say plt dot subplots. And inside of the parentheses, I want to mention that inside of the parentheses, this is the most important section actually. You should first enter how many rows you have. By row, it means that how many, just imagine the graphs as numbers. So for example, here we have two graphs in one row. So we have two column and one row. Yeah. So we need to define the first is the row, the second one is the column, and the third one is the graph number. How many graph? So for the first is number one, and then you can just copy and paste this line here that we did for customer one. And also the other things, you can just copy and paste the other things like PLT, X label, Y label. You don't need legend, so we should change that. Let's delete the legend here because you have just one graph and it's clear which is which. And yeah, so now we have a subplot, our first subplot for the customer one. Exactly, we should do the same for customer 2. So we should say plt.subplot, and inside of this, again, 1 as a row, 2 as a column, and this time the number of the graph is number 2. So this is the last one is actually the number of the graph. So this is the first graph, this is the second graph, number 1, number 2. And again, I should copy and paste these lines, except legend, and also show very easily. So now we made it. So now we have subplot 1, subplot 2. Let's run this to see what happens. Just I want to change something. I want to change the titles because we have same titles here. So this is the building consumption of or for customer 1, and this is the building consumption of customer 2. Okay, so uh, the other thing that I want to change here is you don't need to have two X labels. So let's delete this one, for example. So we make it more beautiful. So just one label, you can see it in a minute. If I just select this and run it, wow, you can see that we have two uh, beautiful graphs here, and that's why I deleted the second Y label, because we don't need that. We just need it here. You can see that we have the same electricity consumption label for this. So we can put it here or we can delete it. And what we did here is actually separated the line graphs and put them together just beside each other. So this is for 2. You can do it for several ones. For example, you can do it for 10 number of graphs, and you can put it together as rows and columns. The definition of rows and columns that I told you, it means that this is one row. You can have, for example, several graphs in this row, for example, 10 graphs in one row, or you can have 2 rows with 5 graphs, something like that. But here we just have 2 graphs. So we have one row with 2 columns, 2 columns. So one row for these graphs with 2 columns, 2 graphs. And this is graph 1 and this is graph 2. So the only thing that you should uh, be careful about are these numbers. So the first number, it is define the rows, how many rows you have. The second one is the columns, how many columns in each, how many graphs you have in each column. And the third one is the number of your graph. For example, this is the first graph, so number 1. This is the second graph, so number 2. That's it. So you can play around with these subplots. You can have different. You can, for example, make several lists for yourself as customer 3, customer 4, customer 5, and you can do subplots as an exercise for yourself. For example, you can make 2 rows of graphs. You can make 2 rows with 3 columns, or you can make one row with 6 columns, something like that, as an exercise, and that will be very interesting. So that's it for this tutorial. In the next tutorial, we will go after other types of graphs, not line graphs, but other types like scatter, like histograms, and that will be very, very exciting. So until then, take care and enjoy. Hello and welcome to this session of the Matplotlib tutorial. So in this session, we are going actually to plot other graphs other than line plots that we did it with together. So we learned lots of things about line plots. Now let's go ahead and draw other types of graphs. So for the start, let's draw a scatter plot with together. So to do this, we should do exactly the same procedure that we have did for the line graph. But there are some small changes. For example, I want to say instead of plt.plot that we did it before, just remember this procedure. We started with plt.plot, plt.plot customer 2, customer 1, and labels, title, legend, show. And again, we have the same strategy. We just, instead of plot, we say scatter. We say plt dot scatter, and inside of the parentheses, I need to first add my the x, that is mount, the y, that is customer 1, and uh, yeah, and also I want to add color, for example, just like what we did before. The color is, for example, again, red. Just do it with me, so you will review actually what we did before. We just changed the scatter, the plot to the scatter. And here I want to say the color is red, and also the label is equal to, inside of the quotation, customer 1. And that's it. And we can do exact same thing for the customer 2. So we can just copy and paste this line here and say, okay, let's go a little bit down and say, okay, here we have customer 2, and here our color I want to be blue, and here the label should be customer 2. Okay, so until now it was exactly like before, like we did it with plots for the line graph. Just instead of the plot, plt.plot, we use plt.scatter. And also you can mention the labels plt.x label, just like before. Inside of the x label, we should say mount, and plt.y label, and inside of the parentheses, we should use actually electricity consumption, for example, just like what we did before. Okay, so now we can go and define a title for it. Plt title. Title is actually my title. I want it to be scatter plot of uh, building consumption. And also I wanna mention another interesting thing. I wanna mention grid, plt that's grid. This can help you. I will show you what is the difference. So just write plt.grid and the empty parentheses, and plt at the end, that legend, and inside of the legend you can say, for example, I want the location to be best. If you say best, it goes for default that the best location, it defines the best location for your legend. So, and at the end, plt.show. So what we did here is actually exact same thing that we done for the line graph. We just changed the plots, plt.plot to plt scatter, and I just add another line mentioning plt grid. Let's run this. If I select all the lines that I just wrote and press F9 for running it, you can see that it will pop up. But the thing is here, okay, we have our scatter graph here. So as you can see, uh, the scatter shows actually instead of line, it shows your data with dots, with some dots. And we define each dot, each blue dot for the customer 1. I don't know why it doesn't, the grid and also the legend doesn't appear. So let's delete this location. And also, yeah, plt.grid is also active. So if I just run this again, oops, I don't know what happened here. So Okay, so this is the problem. We have an error here. So it is saying that the module matplotlib plot has no attribute x label. So that is the problem. I just uh, had a typo here, so I should correct this. X label is like this, not. So that was a typo. So just if you have a problem with your graph, just check the console for the error. So maybe you have an error because it's it shows you something, but it's not complete. So just check the error section. So maybe you have an error or typo or something. So if I now select all the lines and run this, okay, you can see that now we have a very beautiful scatter plot that I have my legend, I have the grid. So this is the difference. Usually when I use the scatter plot, I use the grid as well in order to find out because I want to find out, for example, what is the exact amount of the electricity consumption for this point in February. So it can give you exactly, okay, this is 16. Because it's a little bit hard to track the dots in the scatter plot. So it's not bad if you add the grid as well. So you should just add plt.grid and empty parentheses. And here we have our X and Y label. Here we have our the title of our graph, and here we have our best location for our legend. And yeah, that's it. We did it. We draw a very beautiful scatter plot. I just close this one, and this is for a scatter plot. Let's draw another plot. Let's go for histogram. I don't know how much you're familiar with histogram, but we are going after plotting the histogram as well, and I will show you what are the histograms exactly. Let's check, uh, let's write a code and check the help, and we will go section by section with each other. It's a little bit tricky, so we should define some parameters. It's not like scatter and PLT, but it's not difficult. It's very easy and straightforward. So if I just say PLT dot hist instead of plot or scatter, this time I use hist. That is the initial of the histogram. So inside of the parentheses, I should define some parameters. What parameters? I can just check the help. If you just forget it, just check the help. Just click on the hist and then press Control I. And you can see that here we should define some parameters. What are the parameters? We have x that is actually the graph that you want to build in your histogram, and also the number of beans. So what we should do here, we should, for example, have different number of beans to see what are the difference. I want to explain it for you after I draw the histogram graph. So that will help you to understand it better. So let's say I want to draw a histogram for my customer one, that we just draw a scatter and line graph for it. So let's go back to the variable explorer, and here in the parentheses of hist, I mention customer one. Customer one. So here it's not like the scatter and line graph, the plot. Uh, you shouldn't have go for x and y. You should just mention one vector that you have that is customer one, that is actually your y. I will tell you why. And the next things that you should define is the bins. So bins is equal to, for example, here, let's say 20. And let's say my color, I want it to be, this time I will say something different. So color is equal to green. I will tell you what beans mean in this stuff. Let's first plot it. And again, I want to go after plt.x label to define my x and y label, this time with no typo. And inside of it, I want to mention, okay, my x label is the mount. and my y label plt that's y label, oops, again typo, and inside of it I want to mention the electricity consumption, and here I want to mention plt dot title. Okay, I want to have a title name histogram, something like that, and plt dot show. Look, this is the preliminary code for a histogram. So let's check what will happen if we run this. Okay, so this is our histogram plot that pop up. So actually we have some bars here, and we have X, Y, our labels, and the title. So what does it mean when we say bean is 20? Let's change the 20. Let's change the number of beans from 20. Let's run it again. Just remember how it was when we run it like this. This was the graph, okay? Just with this width, we run it. And if I change this, for example, to 40 and run it again, you can see this time number of beans doesn't change anything here for us. But what does it mean exactly? So here in the histogram plots, it shows us the distribution of your data. Uh, we can play with other parameters as an exercise to make changes as we wish. But before we go further, let's take a look at another plot that is look like similar to histogram, but they have some differences. Let's first ask Matplotlib to draw a bar chart for us. Let's take a look at the help, and then we'll go after what are the differences between the histogram and between the bar chart. So if I ask the Matplotlib to draw a bar chart for me, I say plt.bar instead of histogram, I say bar. And this time I mention amounts and customer one, sorry. And also the color is, for example, I don't want to define a color. Let's say, yeah, let's say the color is blue. You can use initial as well. You don't have to write down the whole name of the blue or red. Just use the initial of the color. And before the color, I want to define another thing that is width. Actually, with the widths, yeah. No, I think it's like this. The width is equal to, for example, 0.8. So if I say plt dot show, if I run this, let's check this out. If I run this, this is the histogram that we just built, and I don't know why it went. Okay, if I just delete my console, I want to remove all the previous information. I will go and run my import my libraries and then import my data, and then come back here and draw the bar charts for myself. And if I check this out, you can see a very good bar chart for me that shows each mouse has how much has the each mouse has the consumption. So you can see the bar chart here. So the difference between bar chart and the histogram here, you can understand that now. If I say, okay, this is my bar chart, you can see in the X axis, you have the mounts. But in the histogram, in the x-axis, you don't have the mounces. You just have the probability or the number of occurrence of each of your data, something like that. So if I close this and run this again, you can see that this is my histogram with actually just cost for customer one, and that's how the number of beans work. So if you just make it bigger, you're just making your bars thinner, and if you just make it smaller and just run it again, you can see that you are actually making your the widths of your bars thicker and bigger. So this number of beans actually are good for separating your data. So it actually shows you a distribution of your data, the distribution of the consumption actually. That's what you can understand from this is the consumption between, for example, 7.5 and 8 is more than the consumption between 5 and 6. You can see that most of the consumption during the months are between uh, 7.5 and 8. Actually, this month is not correct here, so I should delete this. So let me delete the X label because the X label is not mouse. It's not actually showing mouse. So I think you understand the difference between histogram and bar chart. In a bar chart, it is exactly like scatter and plots, the line graph, and we do it just. I can just make this bigger or smaller, and if I run this, you can see that I have something like this that shows the bar chart for each mouse. But for the histogram, the thing is, if I run this, it gives me actually the distribution of the data in all the year. And the distribution of the data, for example, if it's normal distribution or if it's uniform distribution, you can find it out with the histogram. And yeah, that's the main difference between these two graphs, histogram and bar chart. I wanted to mention this. And I think it's enough for this session. For the next session, we will even go after some of the more important bar charts and some of the details of bar charts, how we can do some changes in that, and how we can put different bar charts with together, not simple like this. And yeah, until then, take care and enjoy using data science. Hello and welcome to this session of Matplotlib tutorial. So if you remember in previous session, we talked about the differences between the histogram plot. We actually uh, plotted the histogram plot, and also we draw very simple bar graph, and we actually compared histogram with the bar chart. So here in this session, we want to talk more about the bar charts because they're very important and you need them sometimes in order to compare your data and to understand your data better. And to do that, let's run this bar chart that we did it in previous session again. This was for customer one. If I run this, you can see I have such a bar chart. It's not very informative. It's just for start. So here in the x-axis we have the mouses. In the y-axis we have electricity consumption. We can add this in just a second. But what I want to tell you is if you want, you can change the widths. For example, if I change the width to 1.5 and run this again, you can see that we have such a bar chart that is just very close to each other that you cannot actually specify and distinguish between each mouse. So that's not a good bar chart. The bar chart is when you can separate each column, each bar of it from each other. So to do that, even you should use the default for the width, that is 0.8, or you can define it as a way to separate the bars not just very close to each other that you cannot find the difference between the bars. So let's go and change this to the 0.8. I just wanted to tell you how you can change the width. And the next thing that I want to show you is how we can actually draw not just one customer one. I want to draw the bar chart for customer two, and I want to compare these two together. So how we can actually put these two customers beside each other, bar chart for each one. The thing is, let's just go ahead and draw the bar chart just like what we did for scatter or the PLT. I can even copy and paste from the scatter, for example. I can copy and paste this here to not take our time. So here I can say, instead of scatter, I can say bar. And here, instead of scatter, I can say bar. And here I don't want the grid, so I delete the grid section. And the other thing, so I need to define is plt.bar mouse customer one. Yeah, that's true. And the other thing is the bar width that I need to define, or it goes, for example, with the default. We can go with the default as the start. Uh, and also, I want to say, okay, what other things do we need? We need X label, Y label, title. That is not a scatter. Title is bar chart. We can change this as well. And yeah, that's it. Let's run this to see what will happen. Let's run this, and you can see we have this bar chart. So this is not what we wanted actually. You can see that each bar chart is actually printed on the other bar chart. So for customer one is red, for customer two is blue, but in some mounts, the customer two actually covered the customer one, and we cannot even see the amount of consumption for customer one. So this is not a good way to show my bar chart. So I want to change this. What should I do? I should go after a trick. So I'll tell you how to do this. Just focus on what I'm doing and you can code it with me. So let's do this trick here. First, we start with defining the bar width. Let's say, let's define some parameter. Let's say my bar width is equal to zero point 0.4. Okay, this is my bar width. And the other parameter that I want to define is I want to define the mounts as the numbers, not the name of the mounts as January, February, March. I want to define them as numbers. So what I'm doing here, I'm saying, okay, mounts underscore B to say, to make it different from the mounts that we defined before here. I want to put number for each mounts. So I use NumPy array. So I say MP, if you remember, what we did with NumPy array was MP dot, and I use arrange method, and inside of the parentheses I have 12 mounts, so I use 12. So with this I'm actually making a 12 number of array here. So if I run this to a line, you can see that now I have an array with 12 number for myself. And also I have a bar width that is 0.4. This is two parameters that I wanted to define. Now let's go ahead and again define our bar chart. Let's say plt dot bar, just like what we did before. And inside of the parentheses, I'm mentioning that, okay, I want to say mouse underscore b. These are the number of mouses. I want to put them as the x-axis. And the y-axis here is, for example, customer one. And the bar width is actually the parameter that we define, 0.4. So I should say bar underscore width as my bar width. And also the color, for example, I want to say the color is here blue. Okay. And the last thing that I want to define is the label for this color is customer one. Okay, so that's for customer one. So what we did here, it's just like before, just I replaced the mounts with mounts B that we defined the numbers, 12 numbers instead of the name of the mounts, and also the bar width that we defined here as parameter. Now I want to define the bar of the second plot. So the bar of the second plot should start not covering that bar. Actually, it should start where the first bar ends. So we need to add a bar width to that section. So how should we do that? We say plt dot bar, this time for customer two. I say again mouse underscore b. I want to add the bar width to this. Okay, so now you understand why I changed my mounts from string January, February, March to numbers. So I can add this bar width to the number. So if I add the mounts underscore b that I just created for 12 numbers from starting from 1 to uh, from 0 to 11 or 1 to 12. So here I just add the bar width to it, so it can just push the second bar into the next line. So yeah, that's the only trick. So that's the trick that I just wanted to mention in this section. Let's go ahead. The rest of it is exactly like what we did before. We should just say customer 2 as our y, and here again we should say, for example, define the bar width is just like before. We don't want to change that, and the color here is equal to, this time, for example, let's say red, and the label is equal to customer 2. Okay, so this is what we have done. So the only trick was here that we just pushed the mounts, we changed the mounts from the string to numbers. We give the number to each mount. January, for example, is number 1, February is number 2, and so on. And we just add the bar width that we defined as a parameter to this x-axis. Okay, so this is what we have done. So now if we go ahead and just add the labels and also the X label, Y label, and we can just copy and paste it from here. Okay, because it's same, no difference. It's mounts, electricity consumption, bar chart, and we can add legend or not. Let's keep the legend. And if I just select all of these lines that I just coded and run it, now you can see that we have a beautiful bar chart, not just like before, but this time we actually did that and we actually put the charts along with together. Now we can understand that how much is, for example, for customer one is consuming, how much is customer two consuming in the different mounts, in first mount, second mount, third mounts, and so on. So what we did here actually was changing the bar widths, changing the x-axis, sorry. We changed the x-axis, but we don't want numbers to be on our horizontal axis. So we don't like that. We want our string come back to our axis. You don't like to be 1, 2, 3, 4. You like it to be January, February, March. What you should do, I want to introduce to you another interesting method of the pie plots. that you can use to change this. So to do that, I'm adding just two lines of code here. After I can say, for example, here I can say plt dot x. Okay, so we use the xtext. So this method can help us to change the labels, that we mentioned it by numbers. This time we can change it just like what it was to the strings, to the name of the mounts. So inside of the parentheses here, I should mention that, okay, mounts underscore b that I used plus the bar width and divided by 12 because we have 12 numbers. So after this, I should mention the exact strings that I want to replace instead of these 12 numbers. So I just copy and paste from here that I had the mounts. So I just copy it and go back here and paste it inside of these parentheses. Okay, now we have our 12 mounts with the names. And yeah, that's it. And I can just close the parenthesis. Yeah, I close it. So yeah, that's it. Inside of these parentheses, I just mentioned all the names of the mounts. And now I can, for example, run this code again. I can add this, for example, here and run this code again. And now you can see we did that. We actually changed the numbers to January, February, March until December. So now we have a very informative, complete chart, bar chart that we wanted. And this time the bars are not on each other, they actually are beside each other in each month, and we can see the value of each customer. So that was very interesting. I think that was a trick that first I learned it that was very interesting for me. So you can use that anytime that you have several columns and you want to draw all of them inside of each beside of each other. So what you can do is as an exercise, you can go ahead and add another customers for yourself, the list, like a list, and draw them in the same bar chart and compare the numbers to each other. That would be a very interesting exercise. So what you should do, for example, for customer three, if you want to add another customer and you want to do that. So for this third customer, the thing is, the only thing that will change is instead of mounts b plus bar widths, you should add mounts b plus 2 time of bar widths. Okay, so it's very easy. The rest of it is just like this, but you should just double this one for the third customer and so on. For the fourth customer, you should triple it and so on. So that's it for today's tutorial. For the next session, we will go after the last graph that we want to discuss it. It's a box plot, a very interesting plot, and we can use it in different sections like pre-processing. So until then, take care and enjoy data science. Hello and welcome to this session of Matplotlib tutorial. So in this session, as our last graph, as our last plot, we want to actually draw a box plot. So box plot is very important plot for us, especially in outlier detection, that we will go deep into it in our pre-processing section of this course. So if you don't understand some parts of this section, uh, don't worry at all, because we will go deep into the box plot section and we will understand what each section of the box plot mean and how we can use that in future sections in the pre-processing stage of this course. But for now, we just want to plot the graph and see how we can plot that graph. what is inside that graph and what's going on in that and these things and stuff, it's not our concern right now. We just want to visualize it. So for visualizing box plots, first of all, let's say uh, I wanna visualize a very simple box plot, plt dot box plot, and inside of the parentheses, for example, just for customer one, I want to check what is the box plot, customer one, and I want to say the notch is equal to true. I will tell you what notch means in a second. And I want to say word is, for example, false. Okay, so what notch and vert mean? Actually, the notch is equal to true will give us a notched shape and form of box plot, instead of simple and usual rectangular box plot. So let me run this, and I will tell you the difference. We will change that in a second. And also, in the vert is equal to false or true. That is the vert is equal to true is the default. That is the vertical box plot. While vert equal to false will give us a horizontal box plot. So it depends. Let's test all of them. So if I run this, you can see that I have a horizontal box plot. That's why I defined a vert as false. It means that I want it horizontally, not vertically. Okay, and also it is in notch shape because I put the true for notch, so it is not in a simple rectangular format. It's in a notch form of the box plot. So this is notch form. So if I change this, let's see, for example, I want to change this to false. And now if I run this, you can see that I have a simple rectangular form and shape of the box. So, and also if I change this to true, that is the default, you don't have to do that, but if I change this to true and do this is exactly the format that usually and typically used in a box plot. So we have our box plot in a vertical format, and it's not in a notch format, it's in a simple rectangular format, and you can see it for customer one. What are these things? Just I want to tell you the names because in the next stage we need that. But how we can evaluate the box plots and what's going on inside of it, I will tell you. Don't worry about that. We will go after it in the pre-processing stage of this course, and we will cover it completely fully. So don't worry about that. For now, we just want to know how we can visualize it. So this is how we visualize a box plot, but you may ask, okay, I want another box plot here for customer two. Why? How can I do that? And I also want to change some colors, for example, here. Just remember some names here because we need them in the next stage. This is the box. This is the median. This is the whisker, and these are the caps. So again, this is the box, median, whisker, and these are the caps. So in the next stage, we need them. So if I want to have some details, have some informative box plot, and also want to have customer two beside of customer one, what I should do is I should use plt dot box plot again, but this time inside of the parentheses, first, instead of customer one, I should have a list of customer one, two, three, any type of data that I want. So I'll have customer one and customer two, just separate them with a comma, customer two. So I just put customer one and customer two in a list. That's the first stage. The second stage is to define a patch artist. So if I say patch artist is equal to true, What does it mean? Actually, in order to put some color in our box plots, the customer one and customer two, we need to first put the patch artist equal to true so it can understand that. So it understand that the boxes are patches actually. So we did this patch artist is equal to true. So the pyplot can understand that our boxes are patches. Then we should use box prop or whisker props or these things. So the next thing I want to show you is here I can say, okay, comma, and then I will put it in the next line because I don't want to have a very long line of code. So here I should say props, box props is equal to dict. And inside of the parentheses, I should mention the face color. The face color, you remember the box was the middle section, the middle actually rectangular that we had. That was the box. So box props is equal to dict face colors. Face colors, I mean the actually face color of the box should be equal to, for example, let's say we want to have it in red, okay? And also the color itself, it means that the the outline is color is equal to, let's say again, red. I don't want too many colors. So then I would say, again, to the next line, I should put comma, go to the next line, and I say, okay, let's say my whisker props is equal to, so this was box props. You remember the whisker, which part was whisker? So the whisker props is equal to, again, I use dict, and inside of the parentheses, I say the color. You can define any color that you like. For example, here I want to say green, okay? And then again, comma, go to the next line. And then the caps, you remember where the cap part was? I want to say, okay, my cap props is equal to, again, dict. I want to say the color is equal to, inside of the quotation, I will write blue. Okay, I can say only B, but it's optional to write the full name. And also the last thing that I want to mention is the median. So we had four sections. We had box, we had whiskers, we had caps, we had median. If you don't remember it, let me run this again to show you. So here we are saying that, okay, this is our box. I want to change the color of this to red for me and also the outline of it. This is our whiskers. These are our whiskers. So I want to change this color to green and I want to change the color of the caps to blue. So the last thing that I want to define is the median, this section. So I want to change the median, for example, to yellow, this line that is orange right now. So I want to say the median the median props is equal to dict and color is equal to, inside of the quotation, I'm saying yellow. Okay, just write the name of the color that you like. So we had median props, we have cap props, whisker props, and box props. That's it. And we define the patch artist as true, so we can define the actually color of each section, and we define the two customers as a list. That's it. That's all we need to define. And at the end, we should say plt.show, and that's it. That's the end of our code. I hope I I don't have any typo in my code, so I can go ahead and run it. I have something here that invalid syntax it mentioned, so I think I have a typo here. So meet props is I don't know what is the problem here. So I should have get an error if I run this. So I should say this is median props, this is cap prop. So oh, this is the problem. I forgot to put a comma here. So that's it. It just disappeared. So this is the coding. It's sometimes a little bit uh, taking your time to find out what is the problem, but it will tell you exactly what is the line after your problem, so you can go ahead and find that problem in that line. So if I select this section and just run my code, you can see that we have a very beautiful two box plot here in one graph. And you can see this is customer one, this is customer two. As we defined here, uh, the boxes are in red, the median are in yellow, the caps are in blue, and the whiskers are in green. Exactly, we define each section of the box plot as we liked. So that's it. We will go deep into the box plot as I mentioned, that what are these means and how we can use the box plot to understand our data better in future stage. Don't worry about that at all. In this stage, we just learn how we can visualize it. In the next stage, we will understand how we can use it and what are the applications. So don't worry about that, and do keep on the practicing and on the visualization. This was the last visualization. This was the last graph actually that we wanted to draw with each other. So keep on the practicing and take care until the next tutorial. Enjoy using data science.
Hello and welcome back to the course. So if you remember in the previous section, previous tutorial, we talked about how we can create datetime column for ourselves, for our data sets. Now in this tutorial, we are going after knowing how we can set this column that we just generated and set it as index for our data set. So to do that, because I want to create an imaginary data for myself, let's say we don't have a data set and we want to create one for ourselves, I need to use NumPy. So I should import NumPy as MP just like always. So let's do that. Import NumPy as MP, and in the next line we should actually create our, as we learned in a NumPy basic tutorial, we want to generate some random integers, for example, in 8,760 rows and 2 columns. So if you want to do it yourself, you can pause the video and just do it yourself. It's very easy, just like what we did is in basics, NumPy basics. Okay, let's do it together. So let's name this data data underscore set, and this is equal to MP. I'm using the NumPy library, and I'm using the random randint method. So I'm saying random dot randint method, and inside of the parentheses we need to actually mention some parameters. The starting point that you want, the starting point, it means the numbers should be between what period. So when I'm saying 1, for example, and 1000, it means that all the random integers that will be generated should be between 1 and 1000. Okay, let's do that. And let's say I want it to be in 8,760 rows and 2 columns, something like that. So this line of code actually created a data set for me with 8,760 rows and 2 columns, all numbers between 1 and 1000. If I select these 2 lines of codes and press run, you can see that if I check my variable explorer, actually dataset is created here. So if I open this, you can see that I have actually 8,760 number of samples in 2 columns, all numbers between 1 and 1,000. So I just created my data set, but it's not very clear. We don't have index, we don't have date time, and we need to actually make it a little bit look like what we need. So the next step that is actually very important is it's changing this because the type of this, if you see the variable explorer, the type of this data set is array. We don't want this. We want it to be data set because we want to data frame because we want to use pandas. We need to have our data set in the data frame type, in data frame format, not array format. So if you remember from the pandas basic, it is very easy. So let me rename this to data underscore set, for example, underscore p, or maybe we can say data frame. This is equal to pd. I'm using the pandas data frame method. So data frame, this one that's suggested to me. And inside of this, I'm using the name of the array that I want to change it to data frame format. So I just copy and paste it here. And if I run this line of code, oops, oh, okay, I need to first import the pandas. So I need to import the pandas first. And then if I run this again, you can see that my data frame, this time actually the new data set that we created, the type of it here is in data frame, okay? It's the same thing if I open it, but this time it is in the data frame format, and you have also the index as well. And now the next step is we don't want the index to be like this. We want to change this to the date time format, not like this. So to do that, I'm using the method of the set index of the Pandas library. So it is very easy. And we need to have a date time before we do that. So if you remember from the previous session, we have already made our date time here. So if I just select this last one, for example, date 3, because it is for hourly resolution, hourly frequency, and it is for 8,760, it is exactly what we want. So if I run this, you can see my date 3 is here now, right now. So this is my date 3 that we created with together in the previous tutorial. So I want to put this time, date time that we created with together as the index of my new data set, that is dataset df, okay? So to do that, I'm saying dataset underscore set df, this one, and I'm using the method of set index dot set underscore index, this one. And inside of this, I should mention the date time that we have already created. So this is date 3. So you can very easily type here date 3. And then we need to say, okay, in place equal to true, because we need to implement our changes into the data set data underscore set underscore df. Okay, so if you don't do this in the next step, you cannot see your changes in your data set. So if I select this line and press run, now if I check my data underscore set underscore df in my variable explorer, if I just open this again, you can see that we easily change our index to date time format. So that's it, we have done it. It was very easy, just with simple steps. So with this simple line of code, we actually change our index to date time. because we need this in our future tutorials. That's why I'm telling you this. You may say, okay, what if we import our data, read our data actually from a CSV file? Okay, let's do that together. You can, to do that, I just made an imaginary data set for price of product X, for example, in a stock market. So download it using the resource button of this video. And put it in the same location as your code is saved. The code that you're just coding, you saved it somewhere. So just download the data set and put it in the same location as your code is. And then let's import it as we learned in Pandas basic tutorial. But before that, don't forget to set the console as a working directory. So you can do this very easily by this option, clicking on this and setting the console as working directory. And then we can use, for example, let's say our data frame new data set is df. So df is equal to, just like, as you know, is pd dot read CSV, read underscore CSV, the second one. And inside of the parentheses, you should just mention the name, that is data underscore set dot CSV. It should be something like this. So if you don't want to go just like this or setting your console or stuff, you can just copy and paste the location. You can just put it anywhere and copy and paste the location of your data set, of this data set here, and it's working. So if I select this line and press run, it brings me the df, the data frame, in the variable explorer. If I just open this, we are dealing with such a thing. So we have a date, we have a price of the product X, and the things that here is important is this date time column that we have here is not indexed. It's just a separated column, just like this prices. So we have index from 0 and so on. So we need to change the location. We need to change the actually the role of this date time to the index. Okay, we need to change this. So to do that, just like what we did before, it's not like setting index. It's not like what exactly we have done in the previous step. But it is very easy. Actually, when you are reading your CSV, you need to add the index column as well. So the name of the date, if we open this again, the name here is the date. Just remember this with the capital D-A-T-E, okay? So here, when I'm importing, just copy and paste this line in another line. And you need to add another thing here. Just press comma, and then the next thing that I need to add here is the index column. So I can go after this index call. So I don't want it to be the default. I want it to specify it myself. So I'm saying the index column, and inside of the quotation, I'm mentioning the name of the column that I want Pandas to make it as my index. So the name, if you remember, was DAT with capital letter, and that's it. The other thing that is important, I think, is parsing the dates. So parse underscore dates. So we can just easily put it as true. Okay, I will show you why we need this parse date, but first of all, let's do this together. So now, if you remember, the df was like this. So we have our date, but it's not as index. If I run this line of code, this one, and if I check my df again, this time you can see that I easily change the date as my index. So it is here. So we don't have separated column. Date is not a separated column, is not a column anymore, is index for our data set. So we have done this, and just the things that remained, with this parse state, we actually changed the type of the index to datetime format. What do I mean? So if I check the information of this data set, you know how to do that, df.info and empty parentheses. So if I just run this and check my console, you can see that look at here, datetime index. So the index is mentioned as a datetime. Okay. So now let's do another thing. Let's say, for example, copy and paste this line in another line. And let's name this, for example, df2, okay? I don't want to make confusion here. So let's name this df2 and delete this parse state. With this line, you still making the date as your index, and it's fine. And if you check, you don't see any difference. But the difference is the datetime is not, the index is not in a datetime format anymore. What do I mean? If I run this, you can see that we have a df2 that is exactly same as before, but if I check my df2 info this time, and run this line of code, you can see that the index is not datetime anymore. Just look at the upper one. This one, the df information. Here the index is datetime index, but here for df2 that we deleted the parse state parameter. Here the index is not datetime anymore. And it's a simple index. So what we need to do if you want to have your index as a datetime format, not a simple index, you need to actually add this parse state parameter at the end and change it to true. So with this, you actually change the format of your index to datetime. So that's it. It was very important. So do not forget to add that parse state at the end. And yeah, we have already finished our tutorial here. So in the next tutorial, we are going after a very important concept of resampling method. And what is resampling? I will show you what is resampling and how you can do that in the next tutorial. Until then, keep exercising and enjoy time series analysis. Hello and welcome back to time series analysis course. In this tutorial, we want to go after Pandas datetime. So this is the first section of that, and how we can use Pandas library for our time series analysis. Pandas is very important for us. You know the basics right now, but in this section, we are going after how we can use this library for our time series analysis. So the first tutorial is about creating datetime column with pandas. Sometimes you have a data set that miss the column for datetime and you want to generate that column yourself. So to do that, we use the Pandas library. So the first step is actually importing the Pandas library. So import Pandas as PD like always. And the second step is using the date range method of Pandas. So I'm using the PD that I just imported, and I'm using the method of date underscore range. Range. And here I inside of the parentheses I have several options. So let's let's press Ctrl I in order to see the help for that. As you can see in the help, we have several parameters like start, end, periods, and frequency. So these are four important parameters for us. When you mention the start and periods and frequency, usually you don't need to specify the ends because it's clear how it ends. So for example, let's start with this date, January 1st, 2021, And then here I mentioned the period. The period that is equal to 12, and the frequency that is equal to monthly. So this actually saying that, okay, I want to start from January 2021. I want to have 12 months with the 12 period with the frequently of monthly. It means that I need 12 data actually starting from January 2021. It goes to February and until December. So it should generate 12 data points for me based on this line of code. So if I just run this line of code, oops, I forgot to, first let's run this one. And now that Pandas is imported, now we run this again. Now in the console, you can see that our datetime index is created. To evaluate this better, I just copy this into a variable named dates, let's say date 1, because we're going to create different dates. So date 1 is equal to just copy and paste this line of code here. And if I run this again and check my variable explorer, you can see that date 1 is created. You can see the size, as I mentioned, is 12, and the type, as we mentioned, is datetime index. So if I open this, you can see that it's greatly created our index, so our datetime column. It's not index. So we have 12 points starting from January 2021, and it ends to December 2021. So the next thing that I want to mention here is actually if we check the variable explorer, you can see that the variable datetime format is 12. We can change this size very easily by changing the frequency, for example, and changing the period. So if I copy this line of code to the next line, just copy and paste it here and change this variable name to date 2. And this time I don't want the period of 12 and the frequency of m. I want to triple the frequency because we can change the frequency to 2 months, 3 months. For example, here, let's go after 3 months. So if I press 3 here, and we shouldn't forget to change the period. This time is not 12. This time the period should be 4. So if I run this line of code, as you can imagine, this time the size of the date 1 divided by the 3, because the frequency this time is 3m, and the date 2 is actually consists of the 4 dates starting from January, and then it goes to the 4th month, 7th month, 10 months, and finished. Sorry, I didn't bring it here. So these are the dates that you should see in your variable explorer as well. Okay, so this is how we can do that. Now let's make another one. This time, for example, you may say, I want to make a datetime column, this time hour with hourly resolution. By resolution, I mean the frequency. So this time the frequency is hourly instead of, for example, monthly or daily. This time you want to generate the hourly resolution datetime. So you can pause the video here and do it just like what I did in the previous datetime that we generated together. And then if you come back, you can check it with, we can check it with together. So let's name it dates 3, and the date 3 is equal to again pd.dateRange dates underscore range, and inside of the parentheses I go after I want actually January 1st. Again, I can just copy this because I want to start from January 1st. And this time the period is, as you guess, the period is not 4, is not 12, because it's hourly resolution and we have 8,760 hours during 1 year. So we need to specify 8760. And the frequency is what? Is equal to hourly. So we just show this with h. And if I run this, it will give me day 3, and if I open it, you can see that here it perfectly generated our columns starting from January 1st, hour 0, then 1, 2, 3, it's hourly resolution, until the end of the year, that is 31st of December in 23 hours. So this is perfectly created by Pandas for us, and you can easily add this to your data sets, make it as index. I will show you how in the next session. Perfect. We created our datetime, and now you understand how you can make a datetime column with Pandas. We can go to the next tutorial and learn how to make this datetime column useful for ourselves, or how we can create this datetime column as index for our data set. So that's very important for us, and we sure need it during our course. So that's it for today's tutorial. Until the next session, keep exercising and enjoy using time series. Hello and welcome back. So in this tutorial, we want to understand what is resampling and how we can do that. So sometimes we need to change the resolution, the frequency of our data sets, that we put the datetime as its index. We learned how to generate datetime column. We learned how to set that datetime column as index. Now we want to understand, we want to know how we can change this frequency, change the resolution of this datetime that we have already set it as index. Therefore, we have to use resampling method of Pandas in order to do that. I will show you how. First of all, let's write one line of code. So let's say, for example, resampling _df. This is the data frame that we want to resample, and we want to do that from the, if you remember, the df that we just imported, and we set the date column as its index. We want to do that for this data frame. So let's say df dot, and I want to use the resample method, so I just write resample, this method. So oops, I forgot the E. And inside of the parentheses, what should I add inside of the parentheses? What are the parameters? So if I check the control I, if I check the help, you can see that there are some parameters that you need to mention, but the most important one, and the actually necessary one, the essential one, is the rule here, the first one. So we must specify the rule, and it is actually telling Pandas resample method how we want to do the resampling and with which frequency. For example, let's say we have hourly data, and now we want to change the resolution, the frequency, to daily. Okay, if you remember, the df was hourly. So if we, for example, if this is our df that we set the index for it, as you can check here, the frequency, the resolution is in hourly, and we want to change this into daily. So that's why we are using resampling method. And the rule here is actually telling the resample method what is the resolution now and what is the future resolution that you want to have. So If we want to, for example, this df is hourly and we want to change it to daily, so we need to set a rule as D. So this means that I don't want the resolution to be hourly, I want it to be daily. So that's it. The other thing that we need to specify is the other thing that we need to specify is that we need to mention that what a statistical method should be used. So do I want to use the average of each 24 hours, for example, and change it to 1 day, or a median of that 24 hours, or the maximum or minimum of that 24 hours, and put it as the representative of 1 day, or what? So you need to specify that statistical method as well. For example, let's say I want the average of 24 hours and make it today. So I say mean dot mean and empty parentheses, and that's it. So if I check this now, if I run this code now and check my variable explorer, you can see that the rs_df is actually created for me, and now we have daily resolution here. So the thing is, now that we understand the concept behind resampling, you can do the same for any type of data sets with any kinds of resolution. For example, if your data set is daily and you want to resample it to yearly, you can use, for example, just let's copy this and put it here. Just you can change this D to A instead of D. You can use A, and you may ask, so how we should know what are these A and D and H that I'm using are coming from? So you don't have to memorize all this. You can recall some of the important ones, but you don't have to memorize them because you have already you have them here. I will add this link for you, so you can just use the link. I will add it for you so you can use that. But here in the Pandas time series date functionality, you can find this offsets. You can find this. Actually, for example, you can say this is D, that calendar day frequency. So for example, there are lots of them here. For example, even business quarter end frequency, you can use that. Or for example, for the year, you can use A or Y. For the hourly frequency, you can use H. For the minutely frequency, you can use T or min. Even you can go after second, millisecond, microsecond, and nanosecond. So you have lots of options, and Pandas give you lots of options in order to change your frequency and change your resolution in order to have the daytime frequency that you wish. So very easily you can just open this link and find out what resolution you want. You don't have to memorize all of this. And if I just close this one, and that's it. Okay, so now you understand what is the resampling method and how you can do that. It can help you sometimes. For our future sections, maybe we use this also. So that's it for today's tutorial. Until the next section, keep exercising and enjoy time series. Hello and welcome back to Time Series Analysis Hands-on Python course. So in this session, we officially start our section 4, that is about statistical model for time series forecasting. And I believe that interesting thing happened from now on, and it will be so exciting. So we want to start with our first statistical model that is named ARIMA, and it is very famous. And let's start from the definition of ARIMA. ARIMA is actually the abbreviation of autoregressive integrated moving average. So the formal definition of ARIMA is a statistical model that could be used for time series prediction of future values using past values and lagged forecast error. So if we break down the terms of ARIMA, that is autoregressive integrated moving average, you can see that it consists of three main sections. The first section is autoregressive, the second section is integrated, and the third section is moving average. So it is very important to understand these three sections. That's why from the next slide we will go after all of these sections and to understand what they mean and what are their definitions and why we need them. So the first term is autoregressive. So autoregressive, I just brought a definition of autoregressive model, autoregression model from this paper, journal paper. And in that paper, it mentioned that in an autoregression model, we forecast the variable of interest using a linear combination of past values of the variable. It's a very good definition of autoregression. So as you can see also in this formula, that is formula of autoregression model, you can see that the forecast variable of y in time t, time step t, is equal to actually it is related to the y in different time step in the past, for example t-1, t-2, and until t-minus p. So this p is very important for us. So before we go after what is p, gamma here is the autoregression coefficient, and epsilon is actually the noise in time t. So as you can see here in formula, y in time step t is equal to gamma 1 in time y in time step t-1, and so on until we go to gamma p yt minus p. So this p actually define how much we want to go back, we want to backshift in order to forecast the next value in time step t. So this is an autoregressive model that we discussed. This formula is autoregressive model of order p. So this order p is important for us and is a very important parameter that we use in our models in future. So the next thing that you should know is actually the first input. As I mentioned, it is very important, and it is our first input parameter that should be defined by us. So remember this p. So p is the order of autoregression model or autoregressive for us. The next part is actually the moving average part, is the other important part of the ARIMA method. That is, the definition is also, I just brought this from the same journal paper. So here it defines the moving average model as the moving average model uses past forecast errors in regression-like model. So the same as autoregressive, this time we use the forecast errors in order to forecast the yt. So y in step t is equal to c, that is a constant number, plus epsilon in time t, phi1, that is the moving average coefficient multiplied to epsilon t minus 1, and so on until we reach to epsilon t minus q. So q is another important parameter that you should remember. So this formula is actually a moving average model of order q. So q is the second parameter, second input parameter that should be defined for our ARIMA model. So until now we discussed the autoregression model, we discussed that of the order p, so you know what is p. We discussed the moving average and with the order of q, so you know that the q is the order of moving average model. And the next thing, or the last parts of the ARIMA model, last parameter that is very important, is the order of integration, the order of differencing. So what is integration and why we need differencing? So differencing method is actually used when we want to change the non-stationary data to the stationary format. So what is non-stationary? The non-stationary data, just remember that the time series with trend or with seasonality are non-stationary. So as you can see, for example, here we have ascending trend in this time series. It's very clear that it is ascending. So the trend is clear here. It may have some seasonality that if you zoom in, you can find it out, but we're not looking for that. In the first place, if you find a trend, it means that your data is non-stationary and it needed to be stationary in order to be the input for your ARIMA model. So the stationary format is a time series with no trend. As you can see here, there is no trend or seasonality. This is what we call the stationary. You may see a poor seasonality here, but it's not very clear. So again, if we review it together, if our time series has trend or seasonality, very clear ones, our data is non-stationary and we need to change it to a stationary format that has no trend or seasonality in order to be fed to our ARIMA model. And the way that we can do that is a differencing method, and the number of differences that is needed to change our non-stationary data to a stationary format is called D. So D is another parameter that should be defined for our model as well. So if we review it together, our autoregressive integrated moving average or ARIMA model is actually consists of three main model. The first one is autoregressive, and the order of that is P. The second one is moving average model, and the order of that is Q. And the third one is the integration of these two that we need to do the differencing, and the last parameter is D, that is the order of that differencing. So these three parameters are the main parameters that you need them for your ARIMA model, and they are very important. And you need to memorize them very well. That's autoregression order is P, integration or differencing order is D, and moving average order is Q. But you may ask, okay, how we can find that out? How we can find these parameter? So in order to find this P, D, and Q, you have two ways. The first way that is not, I don't suggest this way very much. It's not a very easy way, is using the autocorrelation function or ACF plots or PACF partial autocorrelation function or PACF plots. And the easier way that is my favorite is actually the grid search. So I will show you what are these methods and how you can use them, but again, I suggest the second method. So in order to go after the first method, we need to understand what is ACF and PACF. Let me review this for you about the correlation. So you remember that from the basic of data science, the correlation between y and x, variable y and variable x, we called, for example, here we call this y and x are positively correlated with each other. What does it mean? It means that with increasing the x, y will be increased as well. On the other hand, we have the negative correlation between y and x. So that means with increasing the x, for example, y is decreasing. With increasing one of them, the other variable decrease. So they are correlated, but this time negatively. And the last one is x and y are not correlated to each other. And the correlation is actually showed with the number of the amounts for correlation is something between -1 and 1. So 1 shows that they are highly correlated, strongly correlated with each other. And -1 means that they are negatively correlated or strongly they are negatively correlated. So this is a very quick review on correlation. I hope you remember that, because we need this for the definition of the autocorrelation function. So what is autocorrelation function, or ACF? So now imagine that there is just one variable. In the previous slide, I show you the correlation between y and x, two variables. Now imagine we have just one variable, and we want to find out the correlation between different time steps. For example, in time step t and t minus 1. So, for example, imagine that for our one variable in time step t and t minus 1, we have something like this. And if we fit our if we fit a line to this, the correlation will be, for example, 0.9. It's a very good correlation between t and t minus 1. The variable in time step t and that variable again in time step t minus 1. And if we draw this correlation into something like this, this is another plot that shows the autocorrelation amount, that is 0.9. And the shift number here, what is shift number? The shift number is the back shift that we go through the past, if you remember. So this is t and t minus 1. As you guess, we shifted one time to the past. So the back shift here is 1. So for first back shift, the correlation is 0.9. Now imagine that we want to, this time, we want to draw a correlation between t and t minus 2. So we have something like this, okay? So t and t minus 2, and we fit a line here, and this time the correlation is not 0.9, it's 0.4. So it drops. So if we draw it here in our autocorrelation and shift number plots, it will be something like this. After shift 2, our autocorrelation will be 0.24. And then we continue this until for limited number of lags. For example, imagine 30 or 40 number of lags, it depends. And that creates our ACF plot that will be something like this. Okay, what's a partial autocorrelation function? So just like ACF, but it's a little bit more difficult, but I will try my best to explain it for you in the easiest way. So the partial autocorrelation function, a very simple explanation of that is plotting the residual errors that is in the residual errors that is the error that was not explained by linear model between step t and t minus 1. So therefore, if we draw these residuals, in a separated graph for t and t minus 1, it looks like something like this. The residual the residual errors of t and t minus 1, it would be something like this. So if we fit a line here, for example, the correlation will be something. And then in the next step, we go after, so this was between t and t minus 1, and we fit a line, and we repeat the same process this time for residuals of t and t minus 1 and t minus 2. So the next graph will be residual errors of t minus 1 and t minus 2. So then we fit another line into this, and we continue this process. Until we reach the limits that we defined, just like ACF. And then our partial autocorrelation function will be something like this after limited number of shifts that we have: t minus 1, t minus 1, t minus 2, t minus 2, t minus 3, and so on. So it will be something like this. At the end, we have a graph like this, and this was actually a brief introduction to ACF and PACF, just for you to understand the concept. And for sure, the math behind it is a little bit more complicated than this. And there are lots of references out there if you like to continue reading about this with more details. But the good news is practically in Python, there are libraries that's plotting these graphs for you and make your life easier. So you don't need to worry about this. I just wanted to explain the concept for you so you understand what is the concept behind ACF and PACF plots when you hear them. So, but the question remained that, okay, now we understand what is ACF and PACF and how we can draw these plots and what is the concept behind them. But the question is how we can interpret ACF and PACF plots. It is not always easy to find the order of, for example, autoregressive P or moving average Q from the ACF and PACF graphs. And that's why I always suggest using the next method that I want to explain after this slide. But typically, there are some rule of thumbs for interpreting these graphs. And keep in mind that we need to consider both plots with together. Now I give you one example. Imagine you have stationary data, and if not, we need to make it a stationary with differencing method. Then we expect gradual reduction and decrease in ACF plots just like this. Okay, so when you draw these two plots and you just put them beside together and you see a gradual decrease in ACF plots, when you see this gradual decrease, and then in parallel, the PACF plot has a sharp drop after P lags. For example, what we understand here is P is equal to 2. And why is that? Because we have a gradual decrease in ACF plots, and the sharp reduction, the sharp drop is actually happening after first and in the second one. So in the first one, in the second one, we have a sharp drop. So it means that P is actually somehow equal to 2. The opposite of this will give us the moving average order. And if we see gradual reduction for both, that means ARMA process should be considered with both gradual reduction. Okay, as I said, this is not a perfect way, and we need to go to the next method that is actually my favorite method. So the next method is the grid search. In a grid search, we use grid search in order to find the best, or let's say optimum values for P, D, and Q. We simply search through different combinations of these parameters to find the best combination. But the question is, based on what criterion? There are different criteria that could be used, such as Key Information Criterion or AIC, Bayesian Information Criterion or BIC, or Hannakin Information Criterion or HQIC. You don't need to remember these names because me myself, I actually don't remember them sometimes, but just remember the AIC, BIC, and HQIC are the three main criterion that could be used as the main criteria for finding the best combination of P, D, and Q. So it's like this: your model goes through different combination of P, D, and Q, and at the end it suggests the best combination based on minimum, for example, AIC or BIC or whatever criterion that you define for your model. So that's the optimum P, D, and Q, and it shows you the results. So that's it. I will show you how you can do that in Python environments in the next tutorial. Now that we understand how to do the parameter selection, we are actually ready to start developing our model, because the main part of the ARIMA model is actually finding the P, D, and Q, and the rest is not very difficult. That's it. I will see you in our very exciting next tutorial in order to develop our first forecasting model using ARIMA. And until then, keep exercising and enjoy time series analysis. Hello and welcome back to the course. So in this session, we are going to develop our first forecasting model with ARIMA. You know the concept of ARIMA now, and we are ready to go to develop our first model. So just like before, we start with importing some libraries that are important. Let's start importing them. We may need them during the developing the model. So I start with the most important one, that is in Pandas. So import Pandas as PD, and then next line I import Numpy as MP. Then the third line I import Matplotlib. I maybe use it for the visualization. Matplotlib, that's pyplot as PLT. So I select these three lines and run it. That's okay. So now our basic libraries are imported. The next step now is time to import our data set. As we discussed in the time series with Pandas section, we need to set date and time as our index and also define the frequency. So we can define the frequency just like what we did in the time series with Pandas section, or we can do it like here separately. That's what I'm going to do. So what I'm going to do is define a data frame like this. df is like pd dot read underscore CSV, and inside of the parentheses just download the data set named temp underscore data. That's just by clicking on a resource button, and you can download it and put it in the same location of your code. So for example, this ARIMA code is saved in your drive DE, any drive that you are using, and then just copy and paste this data set that you're just downloading from the resource button of this video, and put it in the same location, and then set the console as working directory. And now the only thing you need to do is just telling the name of the data set, that is temp underscore data .csv, don't forget that, to pandas. And the important thing here is, as I said, I want to set the dates as my index. So I say index underscore column is equal to date. And also, if you remember, in order to make the date time column as index and make it as an index type, so we have an index date time type, we need to parse the date. So parse underscore dates is equal to true. So if I run this right now, it should, yeah, it imported. If I check the variable explorer, now we can see my df is look like this, and date is actually my, is not a separated column, is my index. I don't have any other indexes. So date is my index, and these are my this is my data set. These are my features. And I will tell you how to work with this data set. But before continuing and progressing, we need to actually define the frequency. Here I'm saying df dot index dot frequency is equal to d. I need to do this because I want to see the decomposition of my data. You may say, what is decomposition? I will show you what is that, but this is the requirements of that. So you need to make sure that your frequency is defined before going to that part. So this is very important. And also the other thing is dropping the missing values. It is very important to not having the missing values. So we simply use dropNav command to remove the rows containing missing values. So I say df dot dropNav, and inside of the parentheses, do not forget to in place it. Sorry. In place equals to true, and that's it. And the next part is actually okay. So first of all, let's run these two lines. Now it's fine. Now our data set is actually, we defined the frequency here, you can see in the console, and also we dropped the missing values. Actually, we don't have any missing values, but don't forget to go after this line of code for any project that you are going after, because it is very important. And if you have the missing values, it may occur some errors in your model. So the next step before we go further is actually changing, because if I open this data set, you can see that this data set contains several features, because I want to use this data set for not this model, for future models as well. But for ARIMA, I just need this one feature, the temperature. So we want to actually forecast the future temperature, and for that reason, I just need this column, this feature, and my index that is datetime. So to do that, I am very easily say that, okay, my df is not containing all the features, it's just the temperature column. So I say pd dot data frame, and inside of the parentheses, I'm mentioning the df, and inside of the brackets, I'm just mentioning the temp column. So this is saying that the meaning of this line is, go to data frame, go to my data frame that I already showed you, and extract the temperature column and put it in a data frame format and save it again in a df. So if I run this time, if I check my df, you can see the size changed. So I just have one feature, one dimension. So if I open this, you can see that it's true. I just have one dimension, and this is not a dimension. This is actually datetime index. So you shouldn't consider this as a dimension. And as you can see here, the type is data frame, and the size is 524 rows and one column, or one dimension. Okay, so that's it. We can have a glance on the data frame that we just created and pre-processed. So let's say df.plot to see how it looks. So if I run this, okay, you can see that this is actually the data that we want to work with. So this is the historical value of me during the time, and we need to actually go after the next values in order to predict into the future. So with the ARIMA model. So let's see how ARIMA can take care of this. The next step in our pre-processing, because the pre-processing is not finished yet, so there's one other step that we need to do that is actually splitting our data set into train and test set to evaluate our model at the end. So let's say we keep the last 14 days as our test set, and if subtract 14 from 424, you can say that we have 524, we can say that we have 510. So our training sets will be like this. Train will be equal to df dot ilook, and inside of the brackets, I'm saying that all of the from the beginning until 510, 510, and the first column, and we just have one column, so just you can mention it, and the test should be like this, that df.ilog, this time not from the beginning, from 510 until the end, and that's it, and 0. So we split our data set to train and test from the starting point. So let me open this and we check it together again. So this is our data set. So from the beginning to 510, something like this. For example, the last 14 days, something like here, will be our training set. We train our model with all these data, and then we check our model, we test our model, we check the performance of our model with the last 14 days. So that's it. This is the training test splitting. Perfect. Let's check our we checked our train and test set. Now, before we start finding the parameters of our EMA model, there's one important steps that I promised you I will explain for you, and that's the decomposition of our data. I want to show you what is the decomposition and how you can decompose your data and check that out. And that's very easy and very interesting, and it can give you very useful information. So if you remember from installing packages, we install the stats model, and from that stats model library, I want to import one of its sub packages named seasonal decompose. So I'm saying from stats models, from stats model.tsa.seasonal import seasonal decompose, seasonal underscore decompose. Okay, so this is saying that go to the seasonal subpackage, go to TSA subpackage, go to stats model library, and import the seasonal decompose method for me. And then I create a variable named decomp, for example, decomp underscore results, and I use this seasonal decompose that I just imported, seasonal underscore decompose, and then inside of the parentheses I need to mention the data frame that I have, so it's df, as you know, and that's it, because I want to see the seasonal decomposition. I want to plot it, so I'm saying that, okay, decomp underscore results that we just created dot plot. So I want to plot it for me. So if I run these 3 lines of code with together, I hope we don't have typos, so we don't have any error here. Okay, that's fine. So it should immediately open up this beautiful graph for you, and I will show you what is this graph. We have 4 graphs here in the decomposition graph. So this is, first of all, this is what we call decomposition of your data. So this is the decomposition graph of your data, and we need to we need this decomposition for evaluation of our data. And I will show you what are these 4 graphs. The first graph is actually a simple plot of the actual or observed values. So this is your data. This is what I showed you here with this df.plot. So it's simply your data. And the second graph shows the trend of the data. This one shows the trend of the data. For example, here it goes ascending, descending, then ascending. It may be easy here to just looking at the data and find out the trend, but sometimes it's not that easy. So this trends graph will show you what is the exact trend of your data. And the third graph shows the seasonality, and the last one, so this is the seasonality, so you can even zoom in if you want to this graph, and see what's going on inside of it and find out the exact seasonality that the composition graph will show you. Even if you don't have a strong seasonality, it shows you some seasonality here. It doesn't mean that it is strong, but it means that it finds a pattern there. And you cannot translate this, you cannot interpret this that you have a strong seasonality, but it just gives you the pattern that it finds, and you can just find out the lengths of that seasonality easily here. For example, that's 24 hours, that's 48 hours, that's 3 days seasonality. You can find that out, and it is important sometimes. And the last one is a residual graph. This one that it named resid, it's actually a residual graph. The residual graph shows the error that's what will be generated by putting the seasonality graph on the observed values. So if you use this seasonality on the observed values, it will give you this error. It actually shows the difference between these two graphs. In case you want to add the seasonality and the residual plot, so you want to see, for example, this is the seasonality, this is the residual graph. If you want to add it here and see it, it's not very difficult. Let me just close this, and with one line of code, just like this, decomp underscore result that we just created with each other, and then add the seasonal dot plot here as well. So if I run these two lines with together, now you can see that we have our seasonality graph inside of the residuals as well. So that's it. So you can get very useful information from this decomposition graph. It is very important for us. Sometimes, for example, the trend, you can find out the exact trend. Sometimes you can find the exact lengths of the seasonality. That is important. And this is just a part of pre-processing of your data. I suggest that every time that you are developing a statistical model, just go after the decomposition of your data and to find out what's going on inside of your data set, what is the seasonality and trend, what is the residual of your data. And that gives you very useful information. Okay, it's enough for this tutorial. In the next tutorial, we will go after finding the important parameters P, D, and Q, and that will be very, very exciting because it is the most important part of developing our ARIMA model. Okay, until then, keep exercising and enjoy time series. Hello and welcome back to the course. So in the previous session, we pre-processed our data and we also checked out the decomposition of our data. Now it's time to find the important parameters P, D, and Q. And if you remember from the conceptual session of the ARIMA, I showed you what are P, D, and Q, so you are familiar with these terms. Now we want to find them. One of the conventional methods, as we discussed it before, is ACF or PACF plots. So we really don't want to use that method because it is time consuming and a little bit complicated. And sometimes you may select wrong parameters based on that. But just to make you familiar with it, we try to use that method as well, okay? Let's start by first importing the PACF and ACF plots from the stats model library. So it's not very difficult. As I told you, Python can handle this for you and these libraries can handle this for you. So you can say from stats models, this time from the graphics, and from the graphics I want TSA plots, so I mentioned .TSA plots. Oops. And I want to import plots ACF for my autocorrelation function plot, and also plot underscore PACF for my partial autocorrelation plot, autocorrelation function plot. So I am importing ACF and PACF plots from TSA plots, from graphics. Okay, here we need to add another dot, and from the stats model library. So if I select this line and import it, that's fine. So it's imported. Now the next step after importing the library is actually plotting these plots that we imported. So we use the, for example, plot underscore ACF. So I just copy it and paste it here. And inside of the parentheses, I'm saying, okay, what is the data that I want to plot my ACF and PACF plot for? So if you remember, we have already splitted our data sets to train and test. So let's, for example, give the train to it. And the lags here is 50. This lags actually is the number of backshift that you want to consider. If you remember from the previous sessions, in the conceptual parts, I showed you what is the backshift and these lags. So these are, it should be limited to, for example, 30, 40, or maximum 50. I just put 50 here, for example. So do not go, for example, for numbers 100 or something like that. It should be limited to these numbers. So between 30 and 50 is fine, I think. So the other one is the PACF plot. So if I just copy this line, because it's the exact same thing, but here instead of ACF, I have PACF. And then if I run these two lines together, oops, okay, train is not defined. I think we haven't run these two lines in our previous section, so we need to run that as well. Now we have our train and test set. Yes, we haven't run that. So this is our training set, this is our test set. Now I think we can do this. Okay. So this is our partial and our autocorrelation, or we can say our ACF or PACF plots. And as I said, reading and evaluation of these plots are not very easy, and I will show you easier ways soon. But just for your information, and as we discussed it in the conceptual and the methodology part, you can see that we have a gradual decrease in the ACF plots, and we have a sharp reduction, sharp drop in the PACF plot. So it can give us the AR order, or a P, if you remember. So when this happens, so this is the first backshift, this is the second backshift, and this happened at the third backshift. So we may consider this as for example, we may say that, okay, the P is equal to 2 or 3, so it may happen in a tree, but here it doesn't, we don't have a sharp drop in the second one, we have it in a third one, so P may be between 2 and 3, so something like that, the order of P. And that's when we want to use AR, not ARMA or ARIMA. So that's not a very good idea as well, but we can say P is something like 2 or 3. Let's go after the, so now you can see how we can draw, we can plot the ACF and PACF plots, and somehow you can translate, you can actually interpret these graphs, but I don't suggest that. So let's go after the important one, the important procedure, in order to find out the exact numbers for our parameters, and that's the grid search. So to do that, this is the actually the easier way. So we can test what we found from these graphs there as well and find out if it's correct or not. Let's see. First, we import the related library that is AutoArima package from PMD Arima library. So I'm saying from PMD Arima import auto_arima. So I select this line, I run it, now the AutoArima is imported and ready. Then we call the package that we just imported, and first let's check out the help for that. So I say auto_arima, and inside of the parentheses, let's say I don't know what to put, so I press Control Enter and Control I, I'm sorry, to see what are the parameters that I should put here. Okay, as you can see from the help section, you can see that we need to actually the first parameter that there are lots of parameters here, but the important ones are this y, that is actually your data, the feature that you want to give your AutoArima, and the starting point, the d, the start of q, the maximum of q, and maximum of d, and maximum of q and p. So these are important ones that you need to define. For now, I just put a y, that is my data, and my data here is df, if you remember. And the other thing that I want to check, because I want to check the trace of different combinations of p, d, and q, I just say trace equal to true. But the important thing about this start p, start q, maximum p, and maximum q, q, and also d, is when you have limited time and you don't want the grid search to go after lots of different combinations of p, d, and q, and you want to just limit them to some possible combinations. For example, you can say, okay, the start p is, for example, 3, just to start from the 3. Do not consider, for example, 0, 1, or 2. You can just limit the choices of p, d, and q very easily here by setting them up here as starting p, starting q, maximum p, maximum q, and also for d as well. So, but here I just want to see all the possible combination in order to have my results. So I don't give those parameters to that, but feel free to test that after this video yourself to see if you can manage the number of p, d, and q yourself by limiting them to those numbers. So that's it. My AutoArima is actually ready. If I just select these two lines of code here and run it, now you can see in my console it goes perfect. It just the total fit time is even less than 2 seconds. So it depends on your computer and the number of data that you have. Sometimes, for example, you are dealing with a big data and it takes lots of time. So do not confuse this with this 2 seconds. So it may take even more than 2 hours for you to get this result. But here we don't have, our data set is not very big. So we are dealing with 500 samples. And also it depends on the configuration of your system. If your system is strong, it can be it can act faster. If it's not, it will take more time. So here for me, the total fit time was 1.9 seconds. And the best model here, you can see different combination have been tested. You can see here, different combination. And the criteria that I use is AIC. Just for your information here, you can also define what criteria you want to use as one of your parameters. So if you don't define that, it goes for default. That is actually AIC. So I didn't change that. You can see that here the information criteria in a help. It is AIC as a default. So you can change it to BIC or HQIC, but I don't want to change that. So AIC is fine for me. And it goes after different combination with different AICs. You can see that this is 2,846. This is 2,900 and different types of AIC. And the minimum AIC is actually the final result for me. This is 112. So I think this is the 112. So this is the combination, and this should be the minimum AIC between all these AICs, 2,844. And so the model that is suggested to me is ARIMA, and the parameters are 1 as P, 1 as D, and 2 as Q. So if you remember, we discussed it in the ACF and PACF plots, and we interpret that, okay, the possible P could be 2 or 3, but it's not true. If you check this, you can see that we even check the P for 2, and the AIC is not very good. So that's why I'm saying that ACF and PACF plots are not good options in order to find best combination of PD and Q, and grid search is the better option. So we find the PD and Q, and that's the very important part. And in the next tutorial, it was very easy, right? Very easy and easier for sure than the ACF and PACF plots. It's just 2 lines of code, and you give the data frame to it, and it gives you it spit out the PD and Q for you. So that's it. In the next tutorial, we will go after developing our ARIMA model. That's not very difficult when we have PD and Q in our hands. And until then, keep exercising and enjoy time series. Hello and welcome back. So in this tutorial, we're going to develop our ARIMA model. So let's put a comment here, developing ARIMA model. Okay, so the first thing that we should do is importing ARIMA from the stats model library. So I'm saying from stats models, just like before, .tsa .arima underscore model. I want to import ARIMA itself. So from the ARIMA underscore model subpackage, TSA subpackage in the stats model library, I'm importing the ARIMA model or ARIMA method. Then we create our model by giving our training data and the orders that we found in the previous session, if you remember. So I'm saying, for example, ARIMA model or A underscore model is equal to the ARIMA that we just imported. And inside of the parentheses, we have our training set. If you remember, we splitted our data set to train and test. So now it's time to train our model with the training set. And the order is actually equal to, this is very important. This is the important part. You can just copy and paste it from here, or just put it 1, 1, 2. So it means that the order of the autoregression is 1, the order of the differencing is 1, so it needs 1 time differencing, and the order of the moving average is 2. This is the best or optimum combination of our parameters. And then we fit the model very easily. Then we say, for example, the predictor is equal to A underscore model that we developed dot fit. Okay, very easily. And at the end, because we want to check the result summary, we do this. We are saying, okay, oops. We are saying predictor dot summary in order to see the summary results, summary of the results. So if I select all these 4 lines with together and press run, oops, it gives me an error that a underscore model is not defined. Okay, so the thing is here we need to okay, let's go line by line. So the first, okay, so here is the problem. I have the typo here. I mentioned a underscore model. Here the model is with capital M, here is with lowercase, so I should change this to M. So now it's fine. It was a typo. I changed this. It was a underscore model. That's fine now because it didn't understand the a underscore model with M lowercase. So if I select these 4 lines and press run again, now you can see that our model immediately created. You can see also the result summary of the ARIMA model. You can even check out the different criteria here, like AIC, BIC, HQIC that we discussed, of using these parameters 1, 1, 2. This is a different criteria. And lots of other good and useful information like logarithmic likelihood, or if you need some other information, you can find them here. Statistical information of your model actually. Now it's time to proceed, and our model is ready. Let's go after prediction and model evaluation. So we simply use predict method to predict the future values, but let's see what parameters we need to put inside. So let's say the predicted underscore results is equal to predictor. If you remember, this was our predictor. Okay, so it's fine. We don't have typo here. And predictor dot predict method. And inside of the predict method, I should the first thing that I need to define is the starting point. So the start point is equal to length of my training set, and the end point is equal to length of my training set plus length of my test set plus, oh sorry, minus 1. And the other thing, you can just put the numbers as well here. For example, starting point from this, the ending point to this, because I don't want to make a calculation, and it's easier to just say, okay, the length of the training set will be my starting point, because the length of the training set, for example, here is 510. So it means that start from 510 because our test set is actually starting from 510, and we want to predict through the test set and compare our result with the test set. So I need to start from the 510, that is the length of my training set, and it should end to length of my training set plus length of my test set, that is 14, minus 1. So that gives, you can just directly give the number to it, or in order to not having the calculation or confusion like this and miscalculation, you can just put the length of the train as your starting point, the length of the train plus the length of the test minus 1 as your ending point. And there is another thing that is important, that is the type. What is this type? First, let's say type is equal to levels. Okay, so the thing is, we have two options for type. First is linear, and it is a default of the predict method. And it actually gives us the predictions on the difference data. That's for sure, we don't want that. And the other is level, that give us the predictions on the original data. So let's set this to level. So do not forget to change the type from linear, that is the default, and it gives us the predictions on the difference level, to levels that give us the predictions on the original level. That's very important. And that's it. This is all the parameters that we need to set. And now it's time for magic and prediction. Let's see how ARIMA works for us. So we just need to select this line of code and press run. Now you can see in our variable explorer, the predicted results will appear here. These are our predicted values, and we can easily compare this, and these are our test values. We can easily compare this with the test value. So in order to do that, in order to compare these two together, I'm using matplotlib that we just imported as the basic library at the starting point of this section. So let's do that together. It is not very difficult because now you are familiar with the basic of matplotlib. So let's say plt dot plots, and inside of the parentheses I have test, and the color, for example, for my test set is let's say red, and the label is let's say the label is actual or observed, any name that you like, observed temperature. And the next one is, I can just copy this line and paste it here. And instead of test, I should have predicted results. This one, I can just copy this in order to not having typo. I can just copy it and paste it instead of test. So this time predicted result, the color, for example, should be blue, green, anything you like. Let's say blue. And the label will be predicted temp. So it will be predicted temperature. And the next line is just the label. So plt dot x label, and the x label will be day here because our frequency is day, and plt dot y label, and inside of the parentheses I'm using temperature, so temp. And do not forget to put the legend for me, legend, oops, I have a typo, legend, and empty parentheses, and then plt show in order to render my graph. So if I select all these lines and press run, you can see that this is the graph that shows me what's going on inside of the prediction results. So this is the predicted temperature, this blue line, and this is the actual values for us. So I believe this is not a bad result, as we are just using autoregressive and moving average terms without showing our test values. So it mainly uses the average. So if we check the average of the predicted, you may say this is not a good prediction, but I'm saying it's not very bad. It's not perfect, but it's not very bad based on what we gave to our model. So the ARIMA model is actually based on the average method, moving average, and also autoregression. So it's not a very complicated model. And the thing is, I want to show you something here to prove what I'm saying. If we check the average value, let's just minimize this one. And let's check the average value of the test set. So let's say test that's mean and empty parentheses. So if I run this, you can see in the console that the average value is 17.4. Okay, just remember this number. And now let's go and check the average of the predicted results. So I'm saying predicted results dot mean. And if I run this, you can see that the average is 16.7. So the difference of the test average data and also the predicted results average is even less than 1. So that's why I'm saying that based on the ability of the ARIMA model, it was not a bad prediction. And the averages are very near to each other. This is the best that we can get from the ARIMA. But in the next tutorial, we will go after Serimax to see if we can improve the accuracy of the result of this prediction. But before doing that, we should check at least one metric here to compare the results of our future models easier with this model. So the metric that I want to show you here is that we want to calculate here is the root mean square error. So in order to calculate that, I first import Mass Library, and then from the Scikit-Learn dot metrics, I import mean underscore squared underscore error, and the RMSE is equal to math dot sqrt, and inside of the parentheses I just use this mean square error method, and another parentheses, and inside of that I say test as my observed or actual values, and predicted underscore results, as my predicted values. So let's review this tree alignment together. I import the Mass Library in order to have the SQRT, because in the definition of the root mean square error, it is actually the radical or SQRT of the mean square error. That's root mean square error. And the mean square error is here, I just imported from the Scikit-Learn metrics. And here I can easily import this and use this mean square error, and inside of the parentheses I just should give the observed value, that is my test set, and also the predicted values, that is my predicted results, and that's it. So if I select these 3 lines of code and press run, you can see that in the variable explorer RMSE appear, and it's about 5.6. So just remember or write down this number, 5.64. And in the next tutorial, we are going after Serimax model to see if we can improve this RMSE, this error, or not, with using the seasonality, with adding seasonality and also exogenous variables. That's it for today's tutorial. Until the next tutorial, keep exercising and enjoy time series analysis. Hello and welcome back to the course. So in this tutorial, we are going after Serimax method, and to understand the concept and the methodology behind this model. So the Serimax method is actually the seasonal autoregressive integrated moving average. So if you remember, the autoregressive integrated moving average is exactly same as ARIMA. So what we added here is this seasonal part. But the thing is, the x at the end of this x at the end of the word Serimax actually shows what we that we can use exogenous variables as well in this model. So the difference between the Serimax method and ARIMA method is actually, the first is seasonality and second is exogenous variable. But what are exogenous variables? The exogenous variables are independent variables or predictors that sometimes help us for better prediction accuracy. And yeah, and the next thing is the Serimax method. Actually, if you remember in the ARIMA method, there were three parameters, PD and Q, that we discussed it lots. We discussed it lots of the time. We discussed it that we need to find out PD and Q as the input of our ARIMA model. But in Serima, not only we need PD and Q, but we need capital letters of PD and Q and also S. So what are these? Let's say the P is a non-seasonal autoregressive order, D is non-seasonal differencing order, and Q is non-seasonal moving average order that we have already had them in our ARIMA methods. And in Serima, we also have P, D, and Q capital letters and S. P is seasonal autoregressive order, D is seasonal differencing order, Q is seasonal moving average order. So these are all the same, but these are non-seasonal, just like ARIMA, but these are seasonal orders. And also the S here is seasonal length. So in case we want to use Serima model instead of ARIMA model, we need to specify, we need to define not only these three, we need to define all these fours as well. So there are 7 main parameters that needed to be defined. And this S, all these PDQ capital will be defined through the same process of the grid search, if you remember, that we have done it for ARIMA. And this seasonal length could be defined, it should be defined by us, and it could be defined by evaluation of the decomposition of the data. And if you remember, I told you that this decomposition can help us very much in future. For example, finding the seasonality or trend. This is where we can find the seasonality, length of seasonality from that graph, from that decomposition graph. So it's not very difficult to find these as well, and we will go through them all in the development of Serima model. So I hope you understand the concept behind the Serimax method, but in order to understand it further, we need to go and develop our real projects in a Python environment, so you can be more familiar with these terms. Okay. See you in the next tutorial. It will be very, very exciting. Until then, keep exercising and enjoy time series. Hello and welcome back to the course. So in this tutorial, we're going after developing the Serimax model and to compare the result of this model with the ARIMA model. So we need to use the exact same data set that we use for ARIMA and forecast temperature through the test set and evaluate that and compare the results with the ARIMA model. So just like the first couple of lines are exactly like ARIMA, what we did for ARIMA. So you can just copy and paste it here. I try to write this down here. So I start with importing the basic libraries like Pandas as PD, Numpy as NP, and import matplotlib.pyplot as PLT. So let me run these 3 ones. Oops, I have Okay, I forgot the L here, sorry, a typo, so let me run that again. Now my basic libraries are imported. Let's proceed with importing our data set. It's just like we did for ARIMA, and set the frequency and drop the missing values after that. Very easy, 3 line of code, very straightforward. So let's say df again here is pd dot read underscore csv, and inside of the parentheses I'm adding the name of my data set, temp underscore data dot, sorry, the data is like this, I think, dot csv. This is the same data set that we use for ARIMA, so just you can keep the data set in the location of the Serimax code as well, so you can just import it from here. And then index underscore column is equal to date, and the next thing is parse underscore date is equal to true. So let me select this, import it. Okay, I have a syntax problem again. This here we should add an equal, so you may have some typos like me. Okay, so here we have a problem again, read CSV, get an unexpected keyword. Okay, parse date, I think we have a problem here, parse underscore dates, it's s at the end. Okay, I have lots of typo here, so this time I hope it works. So yeah, it worked, thanks God. So this is our data set, just like before, and then we need to set the frequency. So let's say df dot index dot frequency is equal to d, and let's say in the next line we want to drop the missing values, df drop na, and inside of that in place equal to true. So you can just copy and paste it from the ARIMA code, no problem, because it's the exact same thing. So I just run these two as well. So now it's ready for us. This time I don't delete the other features because I want to use them. And now we want to develop a Serimax model, and as we described, it can deal with independent, or let's call it exogenous variables, as we discussed it in previous tutorial. We need all the columns, but before we proceed, let's check out the correlation between the predictors or the other features, as we call it, exogenous variables, and the target variable. So in order to do that, I want to use the Seaborn heat map. So I import Seaborn library as np, as let's say sn, not np, sn, and then I use this sn dot the heat map method of the Seaborn library. And inside of this, I should just mention the name of my data frame, that is df dot correlation, because I want to see the correlation in empty parentheses. So that's it. So if I select these two lines of codes and press run, it will immediately open this beautiful graph for me that shows the heat map plots between different features that I have. As you can see, there is no strong correlation between the exogenous variables here and our target variable and exogenous variable. So our target variable is actually the temperature. So here is the temperature, and you can see that here, for example, although this is a little bit dark, but it's minus 0.2, so it's not very much with pressure. With wind speed, with relative humidity, it's not very strong. So But let's hope that even this weak correlation can help us in the prediction. But keep in mind that using independent variables that has better correlation with the target variable can help us more, and using exogenous variables with no correlation at all not only cause more computational time, but also sometimes it has negative impact. So in this example, in this project that we are developing with together, I'm using these exogenous variable, but sometimes really you don't have to do that because it just increases the computational time for you. And as I said, it may also have negative impact, not only positive one. So let's hope that this even poor correlation can help us and proceed to the next level. Okay, let's continue just like before with finding the parameters for our Serimax model. But before that, before going to that part, I want to define my train and test set just like our email model. So I'm saying that train is equal to df dot ilog. Just you can copy and paste it here from the ORIMA. So it's all the way down to 510, and this time again I want just the first column for my training set, because the first column is the temperature. Let's check that out so we don't have problem with that. So yeah, the first column is the temperature, so this is 0. So I want just this one to train my model. And also for the test, I can copy and paste this here. And let's name this test and df.ilog. This time I say from 510 to the end, and again column 0. So this is how we splitted our train and test set. But this is not the end. This time we also need to define train and test set for the predictors, for the exogenous variables. We can call them even independent variables. They have lots of names. So this time we have another section in order to split the exogenous variable train and test set as well. So let's call it exo because of the name exogenous. And from the df, I want to separate that exogenous variable from my data frame. So ilog. First, I want to separate them. So I want all the rows, and it start from the first until the fourth. Let's check that out with together. So it start. This is 0. This is 1. So we start from the 1 relative humidity. And then we go after the wind speed, that is 2. We go after pressure, that is 3. But we need to mention 4 because it stops at 3. If I mention 3, it stops at 2. So you know the basics of the Python and how it works. So that's it. And the other line of code is actually separating these exogenous variables that we separated from our data frame. Now we want to separate it itself to train and test. So let's say exo underscore train is equal to exo dot ilog, and inside of the brackets I'm using all the way to 510, and I want all the columns, so you don't need to mention that even. So and the other one is exo underscore test, and here again from the exo dot ilog, I want this time from 510 until the end. So from with this, I separate the exogenous variable that is separated from my data frame into training and test set. So let's select these 3 lines of code and press run. And now you can see in the variable explorer, I have my exogenous variables that has with the size of 3 and with 524 number of samples, number of rows. and the test set with 14, and the train set with 510 number of rows. So this is it. This is the pre-processing stage. In the next tutorial, we are going after finding the parameters. That is very important through AutoArima method, and that will be very interesting because we are not just have 3 parameters. This time we have 7 parameters as we discussed, and it will be very exciting to find that out. Until the next tutorial, keep exercising. Hello and welcome back to the course. In this tutorial, we're going to find out the parameters that we need for our SERIMAX model. And to do that, we are again using AutoArima method. So let's import the library, and I want to import from the PMD Arima, just like what we did for Arima method. I want to import auto underscore Arima, and okay, this part is the most important part of developing the SERIMAX model. So this time in AutoArima, we first define our target variable. So let's say our AutoArima, let's say for example, so we start from AutoArima, and inside of this I mentioned the df, that is my data frame. And the next thing that I want to define is our exogenous variable. So this is the difference between this method, and one of the difference between this method and the Arima method. So let's say exogenous, I hope I don't have a typo issue here. So exogenous is equal to exo. If you remember, we separated the exogenous variables here to exo, and then we will have the M that is actually of the seasonality lengths. Here, for example, the M. Okay, so to find out the M, because it's not easy to find out the M by looking at your data set. So we need to find it out by visualizing our data. And if you remember, I told you about the decomposition and how it can help us here. So let's leave this alone, leave this line of code alone, and go to the next line and visualize the decomposition of our data in order to find out that parameter that we need for AutoArima. So to do that, you know what to do. We start from importing the seasonal decompose from stats model library. So from stats models .tsa seasonal, I import seasonal decompose, seasonal underscore decompose. And if I select this and run it, yeah, we imported the package that we want. And now the decompose result, just like what we did for Arima. So decomp results is equal to seasonal underscore decompose that we just imported, this one. And inside of the parentheses, again, we need to define our data frame, the df. And the other thing is, okay, so do not forget to mention, because our data frame consists of different features this time. We didn't separate just one feature, temperature. So do not forget to mention that what feature of your data frame you need to decompose. So the one that we want is temperature. So inside of the quotation, I mentioned the temp. The last line is showing the plot to us. So decomp underscore results, and here dot I add dot plot and empty parentheses. So if I run these two lines of code, okay, it will appear. And if I make it a little bit bigger, this is the seasonality that we discussed with each other. So in order to find out the M parameter, we need to actually zoom in a little bit to find out what is the seasonality order here. So let me zoom in a little bit here. So it is somehow the seasonality. For example, here it start. Okay, let's zoom in more to one of them to find out what is the exact date. So for example, here it starts from 30th of May, and it ends at the 6th of June. So it is actually 7 days. So somehow 7 day, yeah, from 30, 31, 1, 2, 3, 4, 5, 6, 7, yeah. So we may say that the length of the seasonality, the length that we want is 7. So let's add this. So we close this one. So we did all these 3 lines in order to find out this parameter. So M is equal to 7, and the trace, because I want to see the different combinations, so the trace is equal to true. If you want to see that, don't forget to add this one. And the last thing that I wanted to show me, because I want to at least have one difference thing for the seasonality. I want to mention that the D is equal to 1, and at the end I want to show me the summary, show the summary to me. So summary and empty parentheses. So if I select these 4 lines of code, so in order to not be confused, let me just cut these parts that we have done for the decomposition and put it here, and then we have our decomposition. So this M equal to 7, remember that it came from this decomposition. So if I select these 2 lines of code and press run, it should goes after that. Y should be 1D array. Okay. The problem is I forgot to add because as I said here as well in the decomposition, this time our data frame is not just the temperature, it has also other dimensions, it has other like humidity and stuff. So in order to separate that, we need to just separate it by mentioning that, okay, my Y is just temperature, because our exogenous variable, we have already mentioned them here as exo, so you don't need to mention them as your data. So your data is actually your temperature, nothing has been changed. So that's it. I think we shouldn't have any problem. Again, if I run these 2 lines of code, here in the console, you can see that it goes after trying different combinations for PDQ and capital PDQ, and also the seasonality lengths that we defined. And you may wonder that's why it takes much more time than before, the ARIMA method. And that's because we actually in the Serimax we have other features, so we are actually increasing the number of our data, so it may take more than ARIMA, but yeah, it's finished. If you remember, the ARIMA finished in 2 seconds. Now the Serimax finished in 34 seconds. So in larger data sets, Serimax needs more computational time, because in case you have exogenous variable, in case you don't have that, it may take just like ARIMA at the time, but in case you have exogenous variables, it may take more time. So in 35 seconds, somehow 35 seconds, it gave me the method that I should use. So these are the parameters that I should use. And it is 2 for P, 0 for D, and 2 for Q as non-seasonal. 0 for P as the seasonal, 1 for D as a seasonal, 1 for Q as a seasonal, with 7 as our seasonality lengths. So that's it. You are familiar with these information from the ARIMA method that we explained it, and this is the Cerimax result summary that you can find out some statistical parameters here for yourself. And we found out our our parameters, our important parameters, and now it's time to develop our Cerimax model. In the next tutorial, I will show you how our Cerimax model perform on forecasting the test sets. Until then, keep exercising and enjoy time series. Hello and welcome back. So in this tutorial, we are going after developing our Cerimax model. It will be very, very interesting because we want to compare the result of Cerimax model with the result of ARIMA. So it will be very exciting. Are you ready for that? Okay, let's go. The first thing, just like what we did for ARIMA, is just importing the libraries. So I want to use the stats model library and import the Cerimax model. So I'm saying that from stats models dot tsa dot stats state space. It's a little bit long. So state space dot Cerimax imports Cerimax. Okay, so from stats models dot tsa dot state space dot Cerimax import Cerimax. Let's hope I don't have typo. So if I run this, yeah, it's imported. And the next thing is then we easily create our model based on our train set and exo train that we created them in our pre-processing stage. And the non-seasonal and seasonal orders that we have already got them via the grid search. So I easily say that my model is equal to Cerimax that I just imported, and inside of the parentheses, the first thing that we should define is our data, not with exogenous variable, just the temperature itself. So train, and then we should define the exo train that we separated here from our exogenous variable, the training set for the exogenous variable. So that should be exog is equal to exo underscore train, and the order, the non-seasonal order. So order is equal to what is the order? Let's check that out. So these are the orders that the optimum orders. The first three are the seasonal. The second three parameters are not. Sorry, the first three are non-seasonal. The second part are seasonal orders. So the first we want the non-seasonal. So it's 202. So let's say here we have 2 for P, 0 for D, and 2 for Q. And the other one is actually our seasonal order. So we should say seasonal underscore order is equal to, okay, this is our seasonal order, 0117. So let's say 0117. And that's it. So this is our non-seasonal order. This is our seasonal order, 0117. Seasonal, non-seasonal is 202. You can just copy and paste it from here. It's easier. And this is our exogenous variable, our training set. And that's it. This is all the things that we should define for our SariMax model. And if I just select these two lines of code, and I've already imported the SariMax, so just this line of code and press run, oops, you can see that the train is not defined. So I need to define the training set. I just forgot that again. I think we had the same problem in ARIMA model as well. So if I just define my train and test it, I forgot to run these two lines of code. So do not forget to do that yourself. And then if I again press run for this, now you can see that my model, my SariMax model, is created. Now I need to fit the data on it. So let's say model is equal to, again, the model dot fit. So I want to fit it, and then, well, let's not make confusion. Let's say this model is model.fit. So I run this. Now the model is fitted, and the last step, don't forget, the last step is actually doing the prediction. Now our model is created and fitted, and we need to actually predict using the predict method. So there is a slight difference here between this prediction, using this predict method in ARIMA, and I will tell you why, because we have exogenous variables. So let's say the predicted or the prediction, just call it any name that you like. Prediction is equal to, this is the name of the model that I use. So model, okay, let's just make these two models just like each other. So if I just do this, okay, and now let's do the prediction model dot predict, and inside of the parentheses I need to, just like before, the length of the training set, and it end at the length of the train set plus the length of the test set minus 1. And there's another thing that, as I said, there's a slight difference here that we shouldn't forget to add exo test that we have already created it. And if you recall at the beginning, we have created our exo test here. So we need to add that here. So exog is equal to exo underscore test that we have created in our pre-processing stage. And again, we have discussed this, that why we need to define the type as levels, because we don't want the prediction on the difference data. We want it on original data, so we need to specify it as levels, not linear. And that's it. The only difference was this exo that you need to add, the exo test in the prediction. And then if I select this line and do this, now you can see that we have our predictions here. So I'm very excited to see that how our SariMax model worked, and if it could improve the performance of the ARIMA or not. Let's check that out. Let's check if the exogenous variable or seasonality that we added can really help us in this project or not. So to do that, first we want to visualize this. So just like what we did for the SariMax, I want to use the matplotlib in order to visualize my prediction with the test set. So plt.plot, and inside of the parentheses I'm using test, then color is equal to, for example, let's say red, just like before. So you can even copy and paste it from the ARIMA. And the label is equal to actual temp. And another one that is PLT, and we can just copy and paste it from here and just changed it. So let's say PLT plot here, instead of test, we should use prediction, just like this. This is the same thing. It should be same thing here. Yeah, it is. And the color should be, for example, blue, and the label should be predicted. Let's say predicted temp. And that's it. We just need to add the labels. So plt dot xlabel. So the xlabel is actually our day, and the y label is our temperature. And at the end, plt.legend, and oops, and also don't forget to add the plt.show in order to render your graph. So that's it. If I don't have typo, if I select these lines of codes and run it, it should give me the prediction. Perfect. So if I make it a little bit bigger, so we can see the X and Y, this is our actual values, and this is our prediction. You see, it's not a line anymore. It's not an average line anymore. It can not perfectly, but I think it's good that it can understand that when temperature goes up, when it goes down, when it goes up, when it goes down. So it's not perfect, but I think we have, in a glance, we can understand that we improved the results of the ARIMA method with Serimax. But even it's clear that we have the Serimax performance is better than ARIMA, we need to calculate one of the metrics that we calculated for ARIMA. If you remember, we calculated the root mean square error, and here we want to do that as well. So again, we import, just like what we did for, you can just copy and paste it from ARIMA code here. So we import math from Scikit-Learn dot metrics. I import mean square error, mean underscore squared underscore error, and the RMSE is equal to math.sqrt. SQRT means radical, the SQRT of the mean square error. So this mean square error that I just imported, I need to put it here. And okay, so I just need to mention the test and the prediction. So this is, let's just copy and paste it here to not having problem. Okay, so this should be our actual values. This should be our predicted values. This is mean square error that I import from the Scikit-Learn metrics library, and the SQRT of this value will give me the root mean square error that I just calculated for the ARIMA. If you remember, if I recall it correctly, it was about 5.6 for the ARIMA, if I'm not wrong. So if I select these three and press enter, it will give me the RMSE as 4.6. So we actually made our results better. It's very good. So it was 5.6, now it's 4.6. So it means that we decreased the error about 1. So it is somehow about, if we can just calculate this. 5.6 minus 4.6, it's about 1. So if we divide this 1 to 5.6 again, and if we calculate this, this is about 17 and multiplied by 100, so it will give you the percentage that you improved the accuracy. So with using the Variance model, we actually improve the accuracy, we decrease the error to about 18%, and that's not bad, it's good. Although the Variance is not perfect, but it is acting good in order to understand the trend and seasonality in some levels. So that's it. We developed a very good Variance model in order to forecast the future temperature. And it was very exciting for me. I hope you enjoyed that as well. In the next tutorials, we are going after the more exciting models, that is deep learning, and it's my favorite, and it will be very, very interesting. So until then, keep exercising and enjoy time series. Hello and welcome to Deep Learning section. A very, very exciting section is waiting for us, so let's not waste time and go straight into it. The total aim of deep learning is to mimic the human brain, and since neurons are the fundamental and basic units of the brain, deep learning wants to recreate those neurons. So to understand the basics of the deep learning, we need to go a little bit deep into the biological aspects of the neurons. So let's do that in the next slide. So this is the shape of the neuron, and it consists of several important parts. Let's start from the neuron itself, that has the cell body and also dendrites. So dendrites are responsible for receiving messages from other cells. So dendrites are actually receivers. They receive messages or signals from other cells. The other important part is actually axons. Axon passes messages from the cell body to other neurons. So they are responsible for transferring. So dendrites are somehow receiver, cell body is the brain of the neuron, and the axon is responsible for transferring those signals. We have also synaptic terminals, that we call them also terminals as well, that are responsible for passing the signal to other neurons in the last stage. So remember these four main parts, or maybe I should say these three main parts that we need them. Dendrites are the receivers, axon is the transformer actually, and the terminals are the actually responsible, they're responsible for passing the signal to the other ones. So now imagine that we have 100 billion neurons in our brain, which is why the brain has such a wonderful learning ability. So if we go to the next slide, so this part, if we bring what we said until now to computer and machine formats to understand it better, we have something like this. So imagine your brain is receiving signals by hearing, by seeing, or other senses that you have, by touching, by smelling, and then these signals will be transferred via the dendrites and then to the cell, and then transferred to by axons and terminals to other neurons. And at the end, the outputs, that is actually the action that your brain that your brain take, and it's the order from your brain. So this is exactly what we talked. This is somehow what we talked about in how neurons work. They receive the signals by dendrites. They pass it to the brain of the neuron, and they pass it via axon, the evaluated signal via axon, and through this synaptic terminals to the other neurons. So this is somehow computer format, but not like this. If we go to the next slide, you can see that This is exactly what we want in a computer format. So we have the exact same concept here in deep learning and dealing with machines. So we use our variables as input layer. So this is our input layer. So our variables x1, x2, x3 through xi. These are our data. These are our input variables that are actually our data. Then it goes through several numbers of neurons as the hidden layer, and then the outputs will be specified. That is why. This is the concept, but it is not that easy. Now we actually need to understand how this network learns. This is the most critical part. So let's add some weights to the axons to give the ability to the neurons to decide which signal is important and which is not. This will provide the ability for our network to decide which signal should actually pass and which not. So these weights, W1, W2, 3, Wi. So then weights go through the neurons, and in the neurons we simply add up the inputs multiplied by weights, and adding the bias that is a constant value, this bias that is a constant value to adjust the outputs and to actually fit the data with the model for accurate outputs, and then multiply the results of that, multiplying the whole result, the total result, to the activation function to decide finally that the signal should pass or not. But what is this activation function? This is very important and it takes time, so we will discuss it in the next tutorial. Until then, keep exercising and enjoy time series. Hello and welcome back. Okay, so as we discussed in previous tutorial, activation function is actually a function that decides which signal should pass and which not. So let's take a look at some of the important ones. Let's just start with the simplest one, threshold function. This function actually is a type of Boolean function, and in this function a threshold will be defined, and then if y is greater than that threshold, it will be activated, and if not, the y will be 0. So as you can see here, for example here the threshold is 0, so if the x is more than 0, it's positive, it's 1. If it's negative, it's 0. And we are dealing actually with a linear function here. Now let's make it a little bit complicated by adding a nonlinearity to it. Okay, so let's go after sigmoid function. That is another function, important and famous activation function that has nonlinearity as well. Unlike threshold function that was Boolean, this time we are dealing with analog activation. One important point is the tendency of sigmoid function to bring the y value to either end side of the curve, as you can see here. And I mean, if we'll look at the middle part that has a sharp tip with a very small changes in x, we have a jump up or down in y value. This makes sigmoid function good, for example, for classification. The advantage of this function, unlike the linear function, is limiting the outputs between 0 and 1. Before going to the next slide, this is the formula of the sigmoid function. Just remember it. You don't have to memorize all these formulas, but it's not bad to remember the formula. Some of the most important ones, for example, sigmoid is not a very complicated formula, 1 divided by 1 plus e in the power of minus x. And The other important function that is similar to this sigmoid function is the hyperbolic tangent function. So this is very similar to sigmoid function, but this time the range of the output is between -1 and 1 instead of 0 and 1. Even the formula is similar. As you can see here, the formula of this hyperbolic tangent function is 2 divided by 1 plus e in the power of -2x minus 1. And we can reformulate it to sigmoid very easily like this. So here the activation function is equal to 2 multiplied by sigmoid 2x minus 1. So we can easily reformulate the hyperbolic tangent function formula to a sigmoid function. And that means they are very similar to each other. But there is also another difference, more than what we discussed, that this is the difference in the range. There's another difference also that hyperbolic tangent has with sigmoid, and that is the gradient. The slope of change in the middle part is stronger in hyperbolic tangent compared to sigmoid, and it's very clear and vivid here. The other activation that we want to discuss it here is the ReLU function. So ReLU is actually one of the most famous functions that broadly used, especially in time series analysis, and it is the last function that we want to discuss here. So this function, as it is shown in the graph, it gives output x if x is positive, and otherwise it gives 0. So in the first glance, ReLU seems to be a linear function, but it is not. Just if you look at it closely, you can see that it is not a straight line, and it bends here in x-axis. The advantage of ReLU is preventing to activate a portion of the neurons, and with this, the function actually helps us to prevent to have a dense network of neurons, and computation. It is computationally cheaper, and yeah, this is a very good advantage of a ReLU function. And this is also the formula as we discussed it. For the positive x, it's x. For the negative x, it's 0. So these are all 4 functions that I wanted to show you. Very important ones. And the question still remains that which function should we use? And the answer is it depends. It depends on several things, actually. For example, you are developing a classification model. Is it for a regression model? So the type of your model is very important. Also, the type of your training data is important. Do you have a huge number of samples and you need to spend less timing on training? So as you see, you need to consider these things and then select the proper function. For example, ReLU is a type of function that you can use it anytime, and it makes your training process faster, as we discussed. Or sigmoid could be a good function for classification based on the characteristic that we discussed, and so on. So it depends on these situation and these characteristic, the characteristic of your data, the type of your model, and so on, that you should select the proper activation function based on those characteristics. That's it. I hope you understood the concept, basic concept actually, of the activation functions. And in the next tutorial, we are actually progressing in what we discussed in neural network and how it learns. That's it for today's tutorial. Until the next tutorial, keep exercising and enjoy time series. Hello and welcome back to the course. Now that you understand what is activation function, let's proceed in our neural network to understand how neural network actually works. This is what we discussed before. We have our input layer as our data. We have our hidden layer that are neurons, and we have our output layer, and we have some weights here. But this is the simplest form. This is not a practical and realistic form. Let's imagine that now we have several neurons, or sometimes we call it nodes, in hidden layer. We have something like this. So we have input layer here, hidden layer here, and output layer here. Now we have several nodes in our hidden layer. Then each node in the input layer will be connected to the nodes in the hidden layers, just like this. And each node in the hidden layer will be connected to the output, just like this. And but the important thing that we should consider is the weights are sometimes 0, and each node in the hidden layer just consider and evaluate some of the input nodes and give weights to them, not all of them. So it's not like this. The real format, the real shape of these connections is something like this. Okay, so the first format was this, and in a realistic format, because some of the weights are 0 and we don't have weights for all of these connections, so the realistic format is something like this. And now we created our neural network. So this is a practical format of the neural network that we created and a schematic of it. But how this network learned to predict for us? Let's go into that part. Very important and interesting. Let's review it again and start with one of the inputs, just as an example. Let's go for input 4, this one. So we have 3 connections to hidden layer and 3 weights. Okay, these 3 connections and these 3 weights. So then it will give us the output as a prediction result that is y. This one. This is the output of the prediction result. We have also the actual values, and we are giving it to our model for training purpose. So we have our actual values as well, and we call that y prime. So this is the predicted value that comes from this input. It spit out the predicted value for us, that is y, and we have our actual values that for the training purpose, that is y prime. Now the next step is actually model tries to make a difference between this y prime and y and create a cost function for us. So the cost function is actually the difference of predicted value and actual value in the power of 2. So as you can guess, the model tries to minimize this cost function in order to minimize the difference between the actual value and the predicted value. So in the next step, the results of the cost function will be a feedback to neural network, and then updating the weights, or let's say adjusting them based on those feedbacks. Okay, so let's review it together again. We selected the X4. We have 3 weights here. It goes through hidden layer. It spit out a predicted value for us, that is y. And we have our actual values, the value that is y prime. The difference between this y and y prime will create our cost function. Based on this cost function that we want to minimize it, it gives a feedback to our neural nets in order to adjust the weights in a proper way to minimize this cost function. Okay, so it's not very complicated. It's very straightforward. So the final aim is actually minimizing the overall cost function that you can see here. What is overall cost function? Because this that we discussed with together, this process is just for one row. Okay, so this is happened for all the rows, all the samples that you have in your data set, and it goes until the end of your data set. So at the end, the final aim will minimizing the overall cost function of all these rows. Okay, something like this, the sigma, the summation of all these cost functions. This purpose of going back and updating the weights is called backpropagation. But how we can minimize this cost function, this is another question that we will answer that in our next tutorial. But before closing this tutorial and going to next one to find out how we can minimize this cost function and how neural network acts in this regard, I want to suggest an article for you if you are interested in finding more details about backpropagation in neural network and the theory of the backpropagation neural network. You can find it out in this paper, in this research by Robert Nilsson. I hope I pronounced the name correctly. That is published in 1992. And you can find some details there, and you will be more familiar with the backpropagation process, because I just tried to explain it for you in the easiest manner and just tell you the concept of the backpropagation, so you will understand the concept behind how neural networks is learning. So in the next tutorial, we're going after understanding how neural network optimize the cost function, how neural network actually minimize the cost function. And until then, keep exercising and enjoy time series. Hello and welcome back to the course. So until now, we understood how neural net works by calculating the cost function. Now we want to know how the network reached to that local minimum cost. To understand that, we need to first understand the basic of gradient descent method. So imagine these are some of the costs based on the predictions that network had, and this is the curve. And it should be like this, the curve, because we are dealing with a function with a power of 2, as you can see here. So the curve should be like this, and these are the points that has been predicted based on that. As we cannot test all of the possible weights and predictions to find the minimum cost function in order to avoid the curse of dimensionality, we actually use gradient descent method. Gradient is simple words like, in simple words, we can say the gradient is how much the output will change in case of changing the input a bit. So just keep this sentence in your mind, that the word gradient in a simple word, it means how much the output will change in case of changing the input a bit. So in this slide, I want to show you how gradient descent works. And actually the gradient descent is one of the famous optimization algorithms based on convex function, and it is actually a minimization algorithm that tries to minimize the given function. The starting points could be a random around the top. Then gradient descent starts at that point, and one step after another it goes downward in the steepest section until its coverage, something like this, for example. And but the selection of the proper learning rate here is very important, and based on the learning rate that it converges, the selection of that proper learning rate is important. Why? Because if we select the high learning rates, it goes like this, like a zigzag form, and we don't have a proper convergence. We have divergence instead of convergence. And if we select the learning rates very low, very small value, it finally finds the local minimum, but it takes lots of time and it's time consuming. So just make sure that the learning rate is in an optimum form. So we should have something like this. This is the optimal how optimal learning of the gradient descent, learning rate of gradient descent looks. It is not very high, it is not very low, and it takes proper amounts of time in order to converge. Now I want to discuss also two types of gradient descent. The first is when we feed the whole rows to the network and in backpropagation revise the weights. If you remember, we discussed that in the neural network how it learns in the previous tutorial, that we give the network one row by one row as an input, and we calculate at the end the cost function of those rows by that formula sigma, the summation of the difference between predicted and actual values in the power of 2. But there are two ways in order to give the rows into the network. If we fit the whole rows to the network and in a backpropagation revise the weights, this is what we call batch gradient descent. And the other one is the stochastic gradient descent, that unlike the batch gradient descent, it uses rows by rows as inputs and then adjusts the weights with each row as an input. So they have their own advantages and disadvantages. For example, if we consider the batch gradient descent, it has redundant computation, it has high computational time, and it cannot deal with non-convex cost function. And if we choose stochastic gradient descent, we go after row by row adjustments, we have low computational time, and it can find the local global optimum. So what does it mean, global optimum, if you are not familiar with the terms of optimization? For example, here we have this minimum and we have this minimum. So this is local optimum point or local minimum point, but this is the global one. So if you use the batch gradient descent, it may stop here and it may give you this as the minimum point. But if you use a stochastic gradient descent, it has a possibility to find the global ones for you, the correct one for you. So these are the differences between batch and stochastic. For sure, the stochastic gradient descent is cheaper computationally and it can find the global optimum. So we choose the stochastic gradient descent, or we can call it SGD as well. So let's review what we discussed until now with together, and it is very important. Let's review that. So in order to review this part, let's start from the input layer. So we give our data as our input layer. So the observations that we have, including the features that we have in our data sets, is included in this input layer. Then we give this to the hidden layer that is actually consists of our neurons. Then based on the weights that are randomly initialized, neurons will be activated, and the output prediction will be created, and it will be compared with the actual values that we have in our training set to calculate the error. Okay, and then the backpropagation happens, and to update the weights, to adjust the weights. Actually, the network update the weights that are responsible for error in each iteration. This is very important to consider. Then this process will be repeated forward, backward, and in order to have the minimum error here. If you remember, we talked about optimization, how we can find the minimum cost function, and that's the end of the points. So this is the simplest neural network that we call it also feed-forward neural network as well. We start from input, hidden, output, calculate the error, it goes back, adjust the weights, and it goes forward again, back, forward, and at the end we have the minimum error, and that's it. That's the result of our prediction. I hope you understand the concept of the artificial neural network or feed-forward neural network, the very simplest form of the neural network until now. In the next tutorials, we are going after complex ones like recurrent neural network, and that will be very, very interesting. So until then, keep exercising and enjoy time series. Hello and welcome back to the course. So in this tutorial, we want to talk about recurrent neural network. Is another type of neural network that is useful to know it, especially for time series analysis. And from now on, when I want to mention recurrent neural network, I may say RNN. So it's the abbreviation of recurrent neural network. So imagine our discussion about neural network was like this. So we have input layer, hidden layer, and output layer. Very simple, right? Now imagine there are other nodes as well in each layer, but in the sake of simplicity, I just showed them like this. Now let's change the position just to better understand the RNN, because usually or typically they show the RNN like this, and I just changed the position. Okay, now we are adding a loop here, so we have a loop in the hidden layer as well. This loop is actually shows that the hidden layer will give feedback to itself. Okay, if you remember, I said we have several nodes as inputs or hidden layer, and I just showed it just like this for the sake of simplicity. So if we make it a little bit more realistic, we are talking about something like this. So if this is the feed-forward neural network, the left side, this will be the recurrent neural network or RNN, and you can see the feedback loop in each node in each node of the hidden layer. Unlike the feed-forward neural nets that has no memory of, and it only considers the current input. In the recurrent neural nets, the information goes through a feedback loop, as you can see here. And this gives the ability to RNN to not only consider the current inputs, but also has memory to remember the inputs received in the previous steps. This is simply clear in the network that you are looking at here. In feed-forward neural nets, the input goes in the straight line, as you can see, from the input to the output, and never goes back, goes to one node twice, as you can see here. But in RNN, we have this ability of remembering. Maybe in next slide, this will be more clear for you. So here you can see that we have. So let me say it like this. I think until now you understood slightly a difference between ANN and RNN, but there is still one other thing that remained to be discussed, and how RNN backpropagates. And we call this backpropagation through time, or BPTT. So the abbreviation is BPTT. Let's go back to our first representation of RNN and enroll it to see what's going on. So this is the first representation that I showed you, and if I enrolled it to a more realistic format, it will be something like this. And now you can see that in each time step, not only we have outputs, these outputs, blue ones, there is also a feedback to the other node. So this is the feedback to the other node. This is the output. So again, here in each time step, not only we have our output, there is also a feedback to the other node. This one, output, other node, output, other node, and until the end. That is actually what I was trying to say previously about how recurrent neural network can remember and artificial neural network cannot. So the BPTT is happening actually through all time steps, as you can see, that all of them have influence on each other, and the error of each time step is actually related to its previous time step. So the error should be backpropagated from the last time step to the starting point and update the weights, adjust the weight. You may say, wow, this will take lots of time, and that's correct. In case your time horizon is very large, the model could be expensive accordingly. But what are the problems and challenges of RNN? That's what we discuss in the next tutorial. I hope you understand now the concept of the RNN, but in the next tutorial we're going after the challenges and problems of RNN and what is the substitution for that, and what is the solution actually for that one as well. Until the next tutorial, keep exercising and enjoy time series. Hello and welcome back to the course. So until now you understand the concepts behind the recurrent neural network, RNN. And as we promised in this tutorial, we are going after finding out the challenges of the recurrent neural network, the challenges of using recurrent neural network actually. And the challenges of RNN may not be clear on the paper, but in practical, using RNN for some applications creates some inaccuracies. Let me give you a very simple example. For example, let's say I am a mechanic. You want to use a recurrent neural network for natural language processing in order to predict the last word in the text. I'm a mechanic. I usually fix cars. So this car, you expect your machine to predict this one. Or let me tell you another example. I'm born in London, so I speak. So you expect your machine to predict English for you. These are very two simple examples for you. Now imagine the gap between these two sentences are too much. I mean, we have, for example, I born in London as your first sentence, and you have lots of other sentences in between, and then you have I speak English. So the thing is, unlike what we see on the paper, RNN backpropagates through the whole time steps. Practically, when we increase the gap, RNN is not capable to predict well. So generally, when we want this output here, the blue one, based on this input in the starting point, RNN fails to predict accurately. There is a solution for this problem, but I will tell you what it is in a minute. But before that, I want to show you some references to good references about if you want to understand with more details that why RNN fails in this kind of situation. These two papers are actually the proof of what I said about RNN that can fail when you have the long-term dependencies. The first one is published in 1990. It was published in 1991, and the other one by Yushio Bengio and et al. Published in 1994 about long-term dependencies and the problem of the recurrent neural network. So if you're interested in finding out the mathematical proof behind what I said, you can go to these two papers and find about that. Okay, let's go back to what we discussed, and now I want to suggest a solution for that. So the solution for the problem of the RNN is actually one other types of RNN that we call long short-term memory, or LSTM. You may heard the term LSTM very much. So LSTM is actually a type of RNN that solves the problem of RNN for the long-term dependency that we discussed, long-term dependency issue. And we mentioned that as one of the main challenges of using RNN for time series forecasting. But what is LSTM? So just keep in mind that the concept might be a little bit mathematical concept from now on, and it may seem a little bit complicated, but in practical, when we develop our model in Python, you are not dealing with these things. And this is just a quick review on how LSTM actually works. So first, let's take a look at the RNN again, and also inside of one of the cells. So this is the RNN, and if we take a look at one of the cells, for example, this one, we have something like this. This is inside of the RNN cell. We only have a hyperbolic tangent function that we are familiar with from the previous sections. We discussed that. It's very simple, right? But to solve the issue of RNN that we discussed before, the challenge that we discussed, we actually need some more layers, some other layers as well. Okay, now let's check out the inside of the LSTM. So we are dealing with such a thing. So the concept behind that is exact same as RNN, as you can see, but I just magnified this cell because there are lots of things here. So I magnified it for you so you can see the different layers in it. So the only difference between this LSTM and the simple RNN is inside of the cell, but the concept behind the whole process is the same. So, okay, as I said, the concept is the same, and LSTM is actually a complex version of the RNN, and it is actually a type of RNN with more layers inside of the cell. But let's take a look at inside the cell and review it together. So that's why I magnify one of the cells to evaluate it. In the first place, it seems a little bit complicated, but don't worry, we go through that step by step, and I'm here for that. So first, let's remove the other cells to make it a little bit simpler for you to concentrate on the cell. I just want to remove these two and concentrate on this cell, just this cell. Let's do that. And okay, now let's start from the first layer. Okay, so the first layer is this layer that we call it forget layer. This is the step 1. So as you can guess, the first layer is responsible for making decision about letting information pass or not pass. So that's why we call this layer forget layer. So a sigmoid function here, as you can see, is responsible to do that. And the 0 means we completely forget about this information, and the 1 means we keep the information. This layer is very important for us. For example, you have a very huge data set and you have some information in the beginning, at the beginning of the time, and at the beginning of the time that at the end you don't need them. So you don't need them anymore, and vice versa. So that's when this layer shows its importance. And the second layer as you can see, so you can see also the formulation here. I don't go to, because the basic of the formulation is same as what we discussed in the feed-forward neural network in previous sessions. And it's not very complicated. I just multiplied the activation function that we have here to the weights, to the inputs, and also the bias. We don't have anything special here. So the other layer that we want to discuss is the second layer, and this is the updates layer actually. The second layer is responsible for updating the new values. It is actually responsible for updating new values that I mentioned it as IT here, and creating new vectors of values for us. And here I call it G hat, as you can see here. And this is it. And you can see the formulation also here. The only difference is the activation function that used in the first one is the sigmoid, and in the second one is the hyperbolic tangent. And in the third step, we actually want to add, we actually want to update the cell state. This is our cell state it's like a belt that connects all of the cells, all of the modules with together. In order to update this one, because we're doing all of these things, we are having all of these layers in order to update these cell states before going to the next cell. So the cell state, for example, here before updating is gt-1 in the step of t-1. But after multiplying it by this forget layer and this second layer, adding this second layer to it, it will be gt. So very easily, we just multiply the forget layer to it, and also add, it is clear in the formulation as well, also add what we had in the second layer to the cell state, and at the end, we have our GT updated. And that's it. We successfully updated our cell state. And there's just one thing before sending it to another cell, and that's before going to the next cell. There's actually another layer in the LSTM layers that is responsible actually for first deciding what part of the cell, what part I'm talking about this layer, what part of the cell goes as output. Using a sigmoid function, as you can see here, and also regenerating the values between -1 and 1 using a hyperbolic tangent function, as you can see here. And at the end, the YT will be created here in the last stage that is now ready to go as the input to the next cell. So we just to review it, we had 4 main steps. The first step is forget layer in the red part. The second step is the updating new values and creating new vector. The third step is actually updating the cell states. That is very important. And the last section, the last step actually is regenerating the values, deciding which portion should be is the inputs of the next cell, and also regenerating the values between -1 and 1. This was the very quick review of what I said in just 1 minute. So I know that this seems a little bit complicated in the first place, but the good news is when we go to developing our a model in Python environment, it's not like this. So this is just for you to understand the concept, and I hope you at least understand the basic concepts of the behind the long short-term memory method. And that's it. So you can practice it with yourself several times, what I said, and it is not that difficult. In the first place, it is a little bit difficult, but if you listen to what I said over and over, you can understand it very well, and it's not that difficult. So we are ready to go to the developing our first model for our time series analysis, and I'm very excited about that. Until then, keep exercising and enjoy time series analysis. Hello and welcome back to this session. Okay, today we want to start to develop our first LSTM model, and it will be very, very exciting. So are you ready? Let's start. We want to start with importing the basic libraries that we may need during developing our model. So those libraries, as you may guess, are NumPy, Pandas, and Matplotlib. So let's import them. Import NumPy as MP, just like always. Import Pandas as PD, and import matplotlib.pyplot as PLT. Oops. Just like always. So I select these lines and press run, and I imported now these libraries to my Python environments. Okay, the next step is actually importing the data sets into our Python environments and check that out. But this time it's not as complicated as before to just set the dates and these things as index, so you don't need those steps. The only step is actually importing the data set itself and continue with that. So we need to use Pandas Library in order to import our data set. So we say vf is equal to pd dot read underscore csv, as you know. And inside of this, you need to just download the dataset that you can just download it with pressing the resource button of this session of this tutorial, and just copy and paste it in the place that you save this code that you are, this editor, this code that you are just writing it with me. And then, just like always, you can just press on this and set the console as the working directory. Okay, so you don't need to address the whole location, or if you don't do this, you just need to address the whole location, copy and paste the whole location here, and that will be fine as well. So here I just mentioned, because I just set the console as my working directory, I just need this to mention the name. The name is Solar data set, and don't forget this CSV, the format. And if we just select this line and press enter, you can see that in the variable explorer you can see now our data set, and the type is data frame, it's pandas, and the size is actually 8760. It's a whole year in hourly resolution, and the dimension of 2. So let's open that up to check that out. So the first dimension is actually our date. That the second dimension is solar irradiance number. So in this for this model, the LSTM single variant, I decided to work with the solar radiation. You may not know anything about that, but you know how the sun works. It comes up and then it goes down at the night. So this is just about that. We have solar, we don't have solar radiation at night. You can see this is in the night, and we have some solar radiation during the daytime. This is the sun. And then sun goes down again in the night, and we don't have solar radiation. So you don't need to understand the concept of this, but it's very clear and easy, as you all understood this in your high school, so or even elementary school. And we just want to work with this data set, and that's the important part for us. So what is this solar radiation and how it works is not important. So we have one column of dates, we have one column of solar here, and that's it for us. This is our data set, and as I said, and you saw it here in the size, we have data for the whole year, 8,760 hours of the year 2019, for example. And this is our data set. And the next important thing is dropping the missing value is very important in the pre-processing stage. Every time that you want to develop your LSTM model in a pre-processing stage, please do not forget to drop your missing values or replace them or deal with those missing values, because it's very important, and in the next steps you will receive error in case you don't do that. So here we do it just like a very simple line of code. We say df drop now. I don't want any missing values. I don't want to replace them. I just say drop the whole rows if you find any missing values, and in place true because I want to implement it in my data set. So if I select this and press run, you can see that the size of my data set is not changing because I've already cleaned this data set. So this data set is not changing when I do this, but I just mention this line of code here for you. Maybe you use this code for your data set, and your data set has the missing values, so I don't want you to get the error. So do not forget this line of code. Here we don't have missing values and we can continue, but if maybe in your data set you have some missing values and you need to deal with them. And the next step is actually just like what we did for statistical model. Here also we need to actually split our data set into training and test set. So we can very easily do that with, say, okay, training underscore set is equal to df dot, I want to use the iloc method. And inside of the brackets, I mention, okay, from the beginning until, let's first split the training set, for example, from the start to the end of the data set, but not the 48 hours. And then the last 48 hours will be our test set, just 2 days. We want to just check the 2 days and predict the 2 days. So our training set will be from the start to 8,712. Let me check that, so if it's right or not. So if we open our data set, it's here. So if we go to the last 2 days, I want to split these last 2 days, the 31st of August, December, and here this one, 30th of December. And okay, so here we have this is the starting point of the test set. So we were right, yeah. From the starting point until 8,712 here, and I don't want the dates column. As I said, we don't need the dates column for LSTM. The dates column is not important for us, so we just forget about it and we pick this column, the solar column. We just want to select this. So 0, 1. So here I need to mention 1 to 2. So it just forget about the second column. It just give me the first, not the first, it's the second column, but it start from 0. So this is the first, second column. So 1 to 2, it just give me the second column for me, and it forget about the date. And for the test set, we have the same thing, just copy and paste it here and change the name to test set. And here we again use the unlike method. And here, instead of saying, okay, from the beginning to 8,712, we say from 8,712, just cut it here, until the end of the data set, and that's it. And again, we need the last column. So if I just select these two lines, before doing that, let's make them arrays, because we want to work with the arrays, and that's the data frame format. So you just need to add the values at the end of each one of these. So that value, that's values, and that's it. And when I select these two lines and press enter, you can see that in the variable explorer now they appear. This is our training set. It's an array. We don't have the dates column anymore. And it's the whole year except the last 2 days. And here, as you can see in the size, it's fine. It's 48 hours. It's actually 2 days. This is our test set with a size of 48 hours and 2 days. Okay, all is fine. And we actually did the first pre-processing stage. The only part that remained for the pre-processing here is doing the scaling thing. So I want to scale the data set, the training and test set that I have to, I want to scale them between 0 and 1. So you may ask yourself why we need to do that, because we only have one variable here and we don't have any predictors or independent variables. So we don't need to actually normalize our data. But the thing is, I don't know if I mentioned this before, but this is very important. Anytime that you want to develop your neural network, any type of neural network, you may need this scaling step even when you are dealing with just one variable, okay? So the thing is, sometimes the difference between the values in your data set, even in just one variable, is too high that makes confusion for your neural network. Here is not like that. Here we have, for example, 0, and the maximum, for example, here is 0.2 in maximum. But in some data sets, you may deal with such a thing, and you may use this code, and you may get confused, and you may get not good results. So try to do it just like a habit. Do it just like anytime that you develop your neural network in a pre-processing stage, even when you are dealing with one variable, try to write some lines of codes for scaling your data. Okay, so let's do that. So we want to do it. Do this from use a min-max scaler from Scikit-Learn pre-processing subpackage. So I'm saying from Scikit-Learn dot pre-processing import min-max scaler. Okay, so I want to use this min-max scaler. You can just copy it here and say, okay, my scaler here name, the name is SC, for example. You can put any name that you like, and put this min-max scaler that we just imported. And inside of that, you just need to mention the feature range. So the feature range here, feature underscore range here is equal to, what I want is 0 and 1. You can put any range that you like. Usually 0 and 1 is fine. And then I need to actually fit this SC that I just created into my data in order to scale my data set. So what I need to do is actually saying, okay, training, let's name them training and test set scale. So training underscore sets underscore scaled. This is a better name. And this is equal to SC that I just created dot fit underscore transform, because I want to transform my data, fit underscore transform, and inside of that I use training set because I want to transform this training set with this SC that I created with min-max scaler between 0 and 1, and just copy it in a variable named training set scale. The exact same thing, we can do that, you can just copy and paste this line of code here and say, okay, training set scale, then we go after testing set scale. So let's say test set scale, and here instead of training we should say test. I think all is fine, and if we just select these 4 lines of codes and press run, you can see that in our variable explorer, training set scale and test set scale will appear. Now, if I just open one of them, for example, training set scale, you can see that this time the values are between 0 and 1. You can just open again the training set, and you can see the difference. Here it's the maximum is 0.16, something like that, but here the maximum is 0.88. That is actually between 0 and 1. Here it's between 0 and 0.2, something like that. So we did it. We scale our data set. Now it's ready in order to be used in the next step. So the pre-processing stage is a stop here. But there is another step before we go to our developing our neural network, LSTM, and that will be very, very important and crucial part of this tutorial. Because it takes time, we can do it in the next tutorial. I need to explain something in the presentation for you, and then we will go back to this environment and we continue developing our model. Until the next tutorial, keep exercising and enjoy time series. Hello and welcome back to the course. In this tutorial, as I mentioned before, we need to understand a concept before continue our model. And that concept is actually a term that is look back period or window. And it may seem in the first a little bit complicated, but it's not. It's very easy, so I explained it for you. So anytime that you want to develop your model, you cannot tell the neural network or the LSTM model in order to go back to all of your data sets and then predict the next value, because that makes some errors for you. So we need to actually make something different in order to improve our model and make the accuracy of our model better. And that's the look back period and the window size of that period. It means that we go back to our data set, for example, n number of time steps, and then predict the next time steps. And that's how we train our model. So imagine that, for example, we break down our data just like this to train our model. It's like having 4 features instead of 1. For example, let's say T1, T2, T3, T4, and then we are saying that we have these steps, and then the next should be, so as I mentioned, this T1, T2, T3, T4, it's just like we are adding another features to our data sets, and we are saying, okay, based on this T1, T2, T3, T4 steps, predict my T5 step, predict T5 step for me. And then we proceed to the next. The next will be like this. So we use that T5, actually not us, the network used that T5, and the rest, not the T1, but T2, T3, T4, and that T5 that is predicted in order to predict the next value that is T6. So imagine that this will continue until the end of your dataset. Imagine that your lookback period is 4. So it means that you are, first of all, your dataset is multiplied by 4. Okay, just like this, because you are adding other features to your data set. And second of all, you're looking back in each time of your training process. Your model look backs to the previous 4 steps in order to predict the next one. This is the training process. Just remember this. So it goes, for example, it starts from the beginning of your data set. It goes, okay, if I have T1, T2, T4, T3, T4, I should have T5 at the end. If I have T2, T3, T4, T5, I should have T6 at the end. So that's how your model is going to be trained. And okay, what about this size? What window size should we select? Because this is a parameter that we should actually give our model. We should say, oh, we should create this for our model in order to understand this. And I will show you how you can create it in the Python environments. But before that, let's just a little bit talk about what this window size, how much we should go back in order to predict the next one. What is this window size, and what is the size of that? This is mostly depend on your data set and the type of data that you are using. But just if I want, just to give you a hint, you need to consider at least one seasonality in your lookback period. This is one of the hints that I can give you in order to select that lookback period. Let me explain this with an example, with this example that we have. So our example is actually solar radiation and hours. So we have this data set. I showed you this data set. So imagine that you are dealing with this one, and as you can see, and we explained before, there is a clear seasonality here in each 24 hours. So in each 24 hours, it goes up, the sun will come up, and then it goes down, and we don't have the sun anymore. There is no solar radiation. And then the next day, the next day, the next day. And this will happen every day. So every day means every 24 hours. So therefore, the look back period, if you select the look back period 24, that's fine. But you may say, what about 48? What about 72? Okay, those look back period works as well. In fact, as much as you increase this window size, you may get better results. Not always, but most of the time as well. But there is one important thing here, and that's computational time. The larger your lookback period is, more expensive your model is as well. And it makes sense because if you remember in a previous slide, I mentioned that with creating for example, if you set your lookback period 4, it means that you are adding 4 features to your data set. Actually, you are creating your data set, you are multiplying your data set by number 4 in the size. So consequently, it has a higher computational time. So it is very important, this window size, it is very important to how to set that. You should, based on your data set, at least consider one seasonality, and then set that for your lookback period. Try not to use very big window size, because it creates your model very, very huge and very heavy and computationally very expensive. That's it. It's for the lookback period and window size. In the Python environment, you may understand this even better, but this is just for your information to have a little bit background about what is lookback period before we go to the code. Until the next tutorial, keep exercising and enjoy time series. Hello and welcome back. Okay, now that you understand the concept behind the lookback period, the last thing in our pre-processing stage that we need to do before going to develop our LSTM model is actually this stage and creating our window. And how to do that, I will go through it line by line, so don't worry, it's not very difficult. Let's start by creating two empty lists. So let's say I want X train is the first list, and Y train, because I'm going to use the for loop, so I need to create a list in order to append those data here. So first of all, I create two empty lists, and then I select my window size. As I said, for example, here my window size is equal to 24. As I said here, because we have 24-hour seasonalities every day, at least I need to look back for 24 hours in order to predict the next one. So 24 is fine for me, and it's not creating my data set very huge. Okay, so it's here we set our window size, and the next step, I want to create a for loop. So I say for I in range of, okay, so here inside of the parentheses, I can mention the numbers. I can just say, okay, for I in the range of 24 until the size of my training set or training set scale. So it's 8,712. So 8,712. But I want to make it like this because I don't want to create it like this, because maybe you use this code for another data set and it makes some confusion for you. So you just need to change this for yourself, and everything will be automatic here. So let's say here I use this W as my first starting point of this range, and I use the length of my training set, the length of my, for example, let's say training set scale, just copy it here as the second one. So it is exactly the previous one, so 24 until the length of training set is 8,712, and that's it. So the next step here in our for loop here is I want to actually create my X train and Y train here, and the X train and Y train in the range that I defined. So what should I do? The first thing is X train. So let's say the X train dot append. I will show you first. Let me write that down, then I will tell you what happens here. So X train dot append, and inside of the parentheses I'm saying, okay, training set, training underscore set underscore scaled, and inside of the brackets I'm using I minus WS until I, and then I'm saying, okay, 0 to 1. Okay, let's go through that to find out what happened here. So first of all, I'm using the append method in order to anything that is happening here, just append it to this X train list that I created here. So this is here. And then inside of the parentheses, I'm saying, okay, go to training set scale and start to extract these numbers for me. What are these numbers? The first is I minus WS. So let's say I is it starts from I is in the range of 24 or WS window size, and it starts from 24. Okay, so this is 24 and this is 24, and this I starts from 24. So the first point here is 24. 24 minus 24 will be 0. So it will be 0 until 24. So if I just let me write it like this. So this will be something like this. The first step will be I minus 24, that will be I will be 24. So this will be 0, and the I will be 24 itself, so it will be 24. So it means that my first batch, as I mentioned, we want to just split our data set, break it down to different batches of 24, 24, 24, and 24. So I want to say, okay, this is my training set scale. Get the first 24 hours in order to predict the next value for me. Then get the next 24 hours, starting from this, in order to predict the next value for me, and so on. So for this, I created this line that means exactly the same thing. It is saying, okay, go to the training set scaled, get the first, start from the 0 and go to the 24s until the 24s and this is your feature. Your feature is actually here is 0. So I mentioned 0 to 1. In order to make a dimension for it. And that's it. The next step, the next I will be 25, okay? So 25, it will be I minus 25 minus 24, that will be 1. And 20 until 25, okay? So look at here. So it goes to the this one this time starts from here instead of here. From here until 25, until not here but here. So it goes one down. So it creates, the next time it will be from here until 26 to here. Okay, I hope you understand it. We get different batches. We are extracting different batches here, and in order to create in order to predict the next one. So this line of code is exactly telling the same thing, saying that okay, start from the window size and then goes to one by one until the end of the training set scale length in order to create those batches for me, and that's it. So let me delete this one. I hope you understand this. If you go back to what I said again in the video and try to listen to me again, you will understand it. It's very, very easy. So I will do somehow the same thing for the Y train, but this time I just have this. I say Y underscore train, as you can guess. I use dot append, and inside of the parentheses, this time I'm saying training set scale. This, go to training set scale, and in the training set scale, give me I and 0. I just have 1 here, so I and 0. This 0 and 0, 1 here, you may be a little bit confused what's going on, but here it's a little bit confusing. But in the next section that we are going actually after multivariance LST model, this will help us very much. Here we just have one variable, so you can just mention 0 for both of them, and that's it. And at the end, you just need to, what you need to do is creating this list, converting this list to NumPy array, because these are lists. If I just run this, it will give me 2 lists. Okay, let's run that. So this is my X train and Y train, but the format, the type is list. I need to make them NumPy arrays. So I easily do that by this line of code. X train, comma, Y train is equal to np.array. And inside of the parentheses, for example, I want my X train, that is a list, and also np.array. I want my Y train to be also NumPy array. Okay, so I just changed this from the list type to NumPy array. So if I select this and run it, you can now see my X train and Y train type is changed to array. Array of float 64. So that's what we wanted. But before we proceed, let's just open them up. For example, X train, that is very important for us. This is what we created. So as you can see here, we have 3 dimensions here. This is the first dimension, second dimension, and third dimensions. So if we go to the third dimension, this is what we created for ourselves. This is when I said, okay, your look back period or your window size is actually you're multiplying your data sets because you are adding features to it. You're multiplying your data set by the number of window size that you set. So here we set our window size to 24. So we have 24 features here. So this is what we have done here in this line of code that I explained. We started from 0, 2, 3, 4 until the 24th in order to predict the next value. So this is our first batch. The next batch start from second and until the end. The second batch, the third batch, and so on. Okay. The third batch in order to predict this, this batch in order to predict this, and so on until the end of your data set. So you can see that we have lots of data here, and it makes our data set very huge. So be careful about setting your look back period, because it actually create your model computationally expensive. So that's it. We created our X-train and Y-train, and everything is ready for our model. In the next tutorial, I will show you how to develop your LSTM model. This is our first LSTM model, and that will be very, very interesting and very easy as well. We will go through it line by line, and everything is ready for that. So until the next tutorial, keep exercising and enjoy time series. Hello and welcome back. Okay, now that our pre-processing is done, we are ready to start developing our LSTM model. So first, let's just put some titles here. For example, here, let's say pre-processing. It's not a very complicated pre-processing, but we have done a good job here for creating our windows in loopback period. It was the most important part, actually. Now we are going after developing LSTM model. And okay, let's start by importing our libraries that we needed. So we want to actually use the Keras library with the backend of TensorFlow, and it's very strong and can help us very much. So for the first subpackage of Keras that I want to import is the sequential subpackage. So I want to use let's say sequential method from the models of the Keras library. So let's say from Keras.models, I want to import sequential. So sequential, I hope I don't have typo. Let's continue, then we will understand if we have typo or not when we run it. So the other thing that I want to import is from Keras that's layers. I want to import LSTM itself, and from Keras that layers, the other thing that I want to import is from Keras that layers. I want to import also dense. And the next thing that we need to import is the dropouts. I want to use this. I will tell you why. So from Keras the layers again, I want to import dropouts as well. Dropouts, sorry, not this. So let's first import these libraries. So we don't have, if you don't have any typo, it should import them very easily. So just select run, and then that's it. Okay, we imported our library. So we imported the sequential from the models of Keras. We imported the LSTM method, the dense method, and dropout method from the layers subpackage of the Keras library. And now we are ready to develop our model, and I will show you how you can do that. So the first thing that we need to do is actually putting the sequential that we just imported into a variable name. Just you can do it, for example, like this: model underscore. Let's say. You can name it, for example, P. Model underscore P is equal to sequential that we just imported, and empty parentheses. Okay, so this is the first line. Very easy, very straightforward. The next thing is using this model P that we just created in order to actually create our layers. So we need to actually create our hidden layers. To do that, I'm using this model P that I created, model underscore P, and then adding our first layer to it. And I'm using the LSTM that I imported from the Keras layers. Okay, so the first layer is the LSTM layer, LSTM, And inside of the parentheses of the LSTM, you need to actually, if you are familiar with the neural network generally, you have done it before, for example, for artificial neural network, this will be very straightforward for you. So it's exact same thing, we just use the LSTM method. But if not, don't worry, we're going through it line by line, and I will explain every parameter that you need to set for it. And so the first thing that you need, just like our neural network, to define for your layer is the number of neurons, number of nodes. If you remember, I explained for you why we need to have neurons and nodes in our neural network, and how they can help us in order to learn. So you know the concept behind that. We need to define the number of neurons in each layer that we have. For example, in this layer, I want to imagine that I have 16 number of neurons. So let's say units is equal to 60. You can set any number that you like, but these numbers, these parameters, these hyperparameters, they need to be optimized. They need to be optimized in a way. You need to have a grid search in order to find the best value for them. So for example, let's say I have tried several number of units, and 60 is a good number that it doesn't make my model very computationally heavy, and also it gives me good results. Okay, so accept this number from me. And the next thing is I want to put the return sequence, return underscore sequence sequences as true. And the next thing, I hope I don't have any typo, but let's do that first. Okay, return sequences is equal to true. I think it's true. And then the last thing that we need to define, and it's just for this layer, is the input shape. So what is the input shape? Because if you remember, the first layer of the hidden, the first layer in a hidden layers is responsible to receive the input values. If you remember, just imagine the neural network in your head. So the input layer will be connected to first layer of the hidden layer. So we need to define the input shape in the first layer of our LSTM. So the input shape will be equal to very easily, I say you can just put the numbers here, but I don't want to make confusion for myself, and I just want to say x train dot shape, and take the x train dot shape 1. So it goes to the x train, this one in a variable explorer. As you can see, it has these dimensions. In this dimension, this dimension, and this dimension. So we are saying, okay, not 0, go to the 1 and take the shape of this. So it's 24. You can just put the number here, or just say that, okay, extrain that shape 1, and any other data set that you use for this code, it will work, and you don't need to change everything. Okay, so so this is it. And the last one is actually, it's the dimension, the last dimension of your X train, that is 1. That is actually the dimension of your input, the number of features that you have in your inputs. If you remember, I told you that we are dealing with a single variance model. It means that we just have one variable, and that means that we have just one feature, and we don't have any predictors or independent variables. So the number that we need to enter here is 1. So this is very important. So let's review it together. We added the first layer to our model P that we want to create. And inside of the parentheses, I use the LSTM layer. And inside of that parentheses, I use the number of nodes or number of neurons, that's 60. Return sequence equal to true, because it's the LSTM model and I want to return it to the next layer. And then the input shape should be the exact thing that we used for the X train 1 and also the number of features that we have as the input data. So this is it. This was actually the most important part. And the other thing is you're actually going to create your next layer, but before that I want to use this dropouts that I just imported here. Because we may have some overfitting in our data. We may have some, just for your information, if you don't know what overfitting is, the basic thing is you're training your model too much that it is not able to predict your test set very well. So the training set is very heavy that the test set is not adequate enough. So the thing is, the thing that you can do in the neural network in order to control this overfitting is just actually dropping some of the neurons randomly. So to do that, I'm using this dropout method. And for example, let's say we just drop 20% of our neurons, or 30%, or any, not very much, but keep it between 10% to 20%. So I'm saying model underscore p again .add. I use the add method, and then inside of that I use this dropout method, dropout. And inside of the parentheses, you just need to mention the portion that you need to drop randomly. So for example, here let's drop 20% of it randomly, and that's it. You finish that part. And then we go to the next layer, and it's exactly like what we did before. So let's just copy and paste this, and it has a very small difference here, and that's the input shape. So we don't have input shape anymore because we don't have input in this layer anymore. So you just need to delete this one. And because you need the input just for your first layer, hidden layer, and the next layers are connected to the hidden layer themselves. So there is no input here. So you just need to delete that one. And that's it. Let's check the parentheses. It's fine. And you just copy and paste this dropouts because we want to drop another 20% of the neurons here as well. Just put it here. Very easily, just copy and paste it. And let's create another layer just like this here as well. You can just copy and paste it. You don't need to type that again. So just copy and paste it here, and that's it. We created a neural network with 3 hidden layers and 1 input layer. We have our input layer, we have our first hidden layer, second hidden layer, and third hidden layer. And then the last hidden layer is actually we need to have another hidden layer, this time without return sequence. So it is going, there is no return here because the output of that layer should go to the output straight, really, not another layer. So in order to have this, I just copy and paste this one as well here. So this is fourth layer for us, but this time the difference is we don't have hidden layer return sequence here because there is no return, and the output of this layer is going straightly to the output node. So that's it. Now we have 4 hidden layers, 1 input layer, and in order to create our output layer, I'm using this dense method that I just imported here. I just want to have 1 output. So let's say model underscore p dot add again, just like before, and this time instead of LSTM I'm using dense. So let's say dense, and inside of the parentheses just you need to mention the number of neurons units is equal to 1 because we just want 1 prediction, 1 output each time. So again, if we want to review what we have done here, we created our first layer of hidden layer that gets the input layer, receive the input nodes, and then the second layer of hidden layer, third layer, just like before. The fourth layer is a little bit different because we don't have return sequences, and it just have the number of units, and it goes to the straightly to the output, and the output I use the dense method that I just imported, and the number of units this time is not 60, it's just 1 because we just have one node for our output. That's it. These are all layers. The next thing is very easy. We need just to compile our model. So we say model underscore p dot compile. Oops, compile. And inside of the parentheses, you need to set two parameters. The first thing is the optimizer. If you remember, we talked about this optimizer. It is very important. We talked about it, how it works in the concept tutorial. If you don't recall that, just go back to the concept tutorial of deep learning and review that again. And it can help you understand what is the optimizer and why we need to set that. So here the optimizer is equal to, let's say we want to use the Atom optimizer. If you remember, even in the concept, I think I mentioned why we use Atom optimizer, because it is good for time series. So it's one of the optimizer that works for time series analysis. So we set the Atom as the optimizer. And the last thing is the loss. So the loss needs to be calculated based on mean squared error. The loss, so this mean squared error, this loss actually will be calculated based on mean square error in each training iteration of our model. And this is our compile section. And then the last part is actually fitting our model. So this is all about your model. You develop the structure of your model, and now it's time to fit your data with this model. So to do that, I need to fit it very easily, just saying model underscore p dot fit, and then inside of the parentheses I need to mention what are my X train and Y train. So let's say X train and Y train that we created with together here, if you remember. So we have them in our variable explorer, so our model doesn't have any problem to understand them. So this is X train, this is Y train. We give it to our model, the model that the structure we have we created the structure with together. And the next thing that you need to define is the number of epochs that you have. So epochs is equal to, let's say 30. This epochs means that the number of iterations that your model goes through the training process in order to understand and goes back. If you remember in the concepts, I explained that it's like this. It goes through the hidden layers, it spit out the one prediction, and it's compare it with the actual value. And then the error will be calculated. It goes back, propagate through the neurons again in order to revise the weights for us. So this process is actually, each time it goes to the end and it comes back, we call it epoch. So the number of epochs is very important, because sometimes if this number is very low, you don't train your model very well. If it's very high, you will have a problem of overfitting. So it's very important. Just try to play around with this number sometimes in order to understand what number is good. I will show you a method just after running this model to find out the best number for this. So it's very easy, just a couple of lines of code that we do it together in order to find out that if this number was good or not. So the last thing that we need to define here in the fit section, we need to actually define the batch size. And the batch size here is 32. I explained what is batch size for you in the concept section. If you don't remember it, just go back to that section and review that part again. So this 32 I think is a good number. You can go for 64, any batch number. If you set this as 1, your model takes lots of time, but you may have get better results, but it takes, the cost is actually high because the computational cost is high. So that's it. That's all the parameters that we needed to set. And I think our model is now, if we don't have any typo here, it should work. And if I just select these lines, because I already imported, yes, I've already imported the Keras layers and models, sequential, LSTM, dense, and dropout methods. And now I just need to select all these lines of code and just press run. And if I don't have any typo, it should go well. Okay, so it goes. I don't think we don't have any problem. It should start the process in the epochs, and you should see it in your console as well, just like this. So yeah, it is going to actually, the first epoch is going to be finished, the second epoch. And as you can see here in the console, first of all, it gives you the seconds that it finished the epoch. For example, the first epoch took 19 seconds, the second epoch 5 seconds, 5 seconds, so it's very fast. And the loss here is actually the mean square error that we just defined. So you can even see the loss, that the loss is dropping very fast from the first epoch. It shows that your model is learning even after the first epoch. The drop of the loss is very sharp, so it is learning through this process. 81, 0052, 0034, so it is dropping. So it means that the error is going to be smaller and smaller. So this is a good sign. This is a good sign that shows our model is learning. But as I told you, it doesn't guarantee that if this loss number is very small, it doesn't guarantee that your model predict very well, because you may train it very good and it may learn very good, but in a training process, but in the test, because you overfeed it, you may not receive a very good accuracy. So, but it's a good sign in a start that you see that the loss is dropping, and it means that you will have a very smooth and good training process. And okay, so I think I don't want to pause this video in order to come back, because it's already getting finished. We are in a 21st epoch. Until this finish, let's just save our model. I want to show you how you can save your model, because every time that you open your model, it's a pain in the neck in order to run this model over and over, because sometimes when you have higher epochs and higher huge data set, it takes lots of time for you. So you don't want to do that every time that you want to run your model. You need to save this model for yourself. So to do that, it's very easy. Just with one line of code, you can save your model. And I can say, okay, model _ p. I want to save this, and the name, just mention the name. For example, let's say LSTM multi univariate. This is univariate. So this is, just mention the name, and it just save this model for you in the same folder that you save your coding. So the next thing, okay, so as you can see here, the model is now finished. Now the 30th epoch has been finished, and you have a very small loss here, so it means that your model trained good. And before testing our model and finishing this tutorial, I just want to show you, because I told you that this number, this epoch number, you can find out if it's good or not. So without going through the grid search analysis and optimization and stuff, it's very easy. Just you can just plot this loss You can see the losses here in the console. So if you plot it for yourself, for example, you have 100 number of epochs, and it's not easy to go through all these numbers to find out what is the trend of this reduction. So you can easily draw this for yourself, plot this for yourself to understand this. To do that, you need to we need to have just 3 or 4 lines of code, so it's not very difficult. I use the matplotlib, so let's say plc.plot, and inside of the parentheses we have range. Okay, so I want to have a range, so this time inside of the parentheses I have the length of I hope I don't have any typo here. I have a length of my model underscore p, with a capital P, and then that's history, because I want to check the history, and then that history I want the loss. Just mention the loss here, this one. So I'm actually saying that goes to the history, take out the loss, and this history is in the history section of my model P, and extract the loss and calculate the length of that for me. Okay, so the next thing is actually having this again. So this time not the length of it, just you can copy and paste it. Let's do it. I don't want the parentheses, so just copy it here very easily, and that's it. So I'm saying in the range of this, and so this is my x. Okay, so this is my x, I want it as the x, and also this is my y. My y is actually the loss that you can see here in my console, and I'm saying, okay, go extract the loss in my history of model P, and then put it as y for me. And that's it. That's the only thing that you need to do, and just if you want, you can just add x labels and y labels. So x label is let's say epoch number, and the y label, let's say plc dots y label. So y label is loss, okay, and at the end, just like always, plc that show in order to render over plots. And that's it. So I just define the x and y for myself, for not myself, for the PLT matplotlib, and my y is actually the loss here. I'm saying go to the history, extract it for me, and my x is actually the number of the lengths of these losses. For example, if it's 100 epoch, this will be 100. If it's 30, this will be 30. So let's select all these lines and press run. And okay, so it's fine. This is our plot that we discussed. So as you can see here, we have loss in our y, and we have epoch numbers here. So we have a very sharp drop in the start of the first and second epochs, and after that it's not very much reduction, but it's fine. It's fine until here. So from this plot, I understand that even if I reduce my epoch numbers from 30 to 20 or even 15, the training process, the amount of learning that my model have will not change. So this means that even 15 is fine for me, even 20 is fine for me. It doesn't need to go for 30 because it's not changing very much. From 50 to 30, the amounts of loss is not changing very much. So it's very, very tiny. So it depends on you. So if your graph is like this, you can easily find out what epoch number is fine for you. But if you have something like this, for example, it is, you can see that if you increase the epoch number, the amount of loss will decrease more and more. You need to actually do that. But again, be careful about the overfitting, and increasing this doesn't mean that increasing number of epochs doesn't mean that you're always getting better results in your prediction. Yes, in your training you always get lower loss, but in your prediction you may have different results. So that's it. I just want to show you how you can have this plot, this convergence plot, and you can evaluate it, assess it for yourself. And then you can save this model very easily. And just before closing this, you save that, and anytime you want to load that, you just have 2 lines of code, because I want to use the load model from Keras models. So I'm saying from Keras dot models import load underscore model, and then the last thing that you need to do is just loading that model. So let's say, for example, your model P is equal to this load model that we just imported dot this load model, and inside of the parentheses you need to mention the exact name that you mentioned here. You saved it, so just copy and paste it to not make any typo or problem. So this is it. This is how you can save your model very easily with this line. And anytime that you come back to your model and you want to you want to skip this process of training, you can just load it here with these 2 lines of code. So the only thing that you need to do is just selecting these lines, running them, and then instead of selecting these lines and running, and it takes lots of time, you can just select these 2 lines and load your model from the saved model that you have here. And that's it. This is we finished the training part. We understood line by line what happens here, and congratulations, you actually developed your first model. But still, the most important part, the aim of our developing this model is remained, and that's the prediction part. We developed our model, but now we want to understand how it predicts, how we should do the prediction, and that's very important, very, very important, and it needs your concentration. So we will start that together in the next tutorial, and until then, keep exercising and enjoy time series. Hello and welcome back to the course. So before we start, we actually continue our code from the previous tutorial. We have a very quick tutorial here because I want to show you the concepts behind what we want to do now for prediction or testing our model. It is very important and it needs your concentration here in the code as well. So just try to focus. And so the thing here is, if you remember from the training part, we actually break down our model, our data set into different batches of look back period. For example, if look back period is 24, we have different batches of 24 in order to give to our model in order to training with that. But for the testing, we have the same structure as well. We need to have the same structure as well because our model trained such a way that it needs 24 if your look back period is 24. So imagine our look back period is 24. So our model trained with different 24 batches. So it needs, in order to test that, you need to create such a structure in order to generate those kinds of 24 batches in order to test your model. What I'm saying is like this. Imagine again you have 4 time steps. For example, you set your look back period as 4. Okay, so T1, T2, T3, T4 is your first batch. that you want to give to your model in order to test it. So you trained your model such a way that we explained it before. Now you want to test it. The first batch that you are giving to your model in your test set should be like this: T1, T2, T3, T4. We give this to our trained model, and it spit out the T5 for us. So T5 will be the first prediction. Then we need to update this. The next step, because we need to do another predictions. The next step is updating, that is actually removing this T1 from here and then adding this T5 that the model is predicted to our data. So we add this here in order to create our next batch. And then we give this to our model in order to predict the T6. And that's it. So this will continue until the end of the lengths that you want to test. For example, you want to test 2 days into the future. You want to test your model with 2 days into the future, or to predict actually with your model in 2 days into the future, 48 hours. So you need to do this 48 times. So again, let's review that and then go to the code. There you will understand it there with more details. So here we have T1, T2, T3, T4. We give it to our model. It gives us, imagine that our lookback period is 4, or we have 4 steps. We take out these 4 steps. We give it to our model. It predicts for us T5. Then we remove this T1. And then we have T2, T3, T4, and then use this T5 as our next data as our next batch, data in our batch, in order to give it to our model, in order to predict the T6. And this will continue until the end of the length of the period that we want to predict into the future. And that's it. This is all we need to do. And we need to make this structure in our code as well. Okay, in the next tutorial, I will show you how. Until then, keep exercising. Hello and welcome back. Now everything is ready to test our model, but you need to remember that I need your complete focus on this section, because it could be a little bit complicated if you don't focus. So try to concentrate. So we will go through that line by line, so don't worry, it's not that difficult if you focus very carefully. And I want to mention this, that just before we start, just like what we did for the training part, we need to have a same structure here as well in the test sets, and create another structure in order to test our model with different batches. So as I explained in the concept part, the previous tutorial, we need to actually create our test sets, something like what we did for the training part here, but this time a little bit different. So let's start that. I will show you how you can do that. So the first thing that you need to do is creating an empty list, just like what we did for the training part. Here you need to have an empty list of predictions. So let's say predictions, prediction tests, for example. The name of this list is prediction test, and empty list. Okay, so the first thing is I want to name this, let's say for example batch 1. Okay, so let's say batch 1, or any other name that you like. Okay, so I want to say batch 1 is training from the training set scale. Okay, go to the training set scaled and extract the last, here for example 24, because the window size is 24. The last 24 hours for me, and just copy it here. So to do that, very easily here in a bracket, I'm saying, okay, minus WS minus, it means that start from the end, not from the beginning, minus through the end. So it means that if this is 24, so it is minus 24 and colon. So this means that go and extract the last 24 hours for me here in the training set scale. Let's open that. So this is our training set scale. With this line, we are actually saying get this 24 hours, this ones, okay, from here, for example. This 24 hours, extract this for me and copy it in the batch one, okay? That's it. This is our first line. The second line is, let's say, for example, batch underscore, I want to name it, for example, C as current, okay? Batch C is equal to the batch one that we just created here, dot reshape, and I want to reshape it just like this. I want to say, okay, instead of the parentheses, I'm mentioning 1, WS, and 1. So this one, because this batch one, I need to reshape that. It's not good like this. And in order to reshape it, I'm just using the, reshape method. I'm just using the reshape method, and inside of the parentheses, I want to mention the lookback period size as one of the dimension, one as we have just one dimension here, and one as the first dimension. So try to reshape the batch one that we created here and put it in the name of batch, let's say batch new, okay, something like that. And then that's it. This is, and then we need to create another for loop, just like what we did for the training set. So this is the most important part. Try to focus. So I'm saying for I in the range of, okay, what is inside of the parentheses? It's the lengths that you want to predict into the future. It's not related to this look back period. For example, let's say you want to predict 48 hours, because if you remember, our test set is 48 hours, okay? This is our test set and it's 48 hours. So actually you need to predict 48 hours into the future. So here you just mention the lengths of the of your prediction, the lengths that you want to predict into the future. Here, because our test set is 48, we mention it 48, okay? Okay, let's go inside of the loop. Here I'm mentioning, okay, the batch new that I created here. Okay, this is not this one. Okay, let's say let's put another name here. For example, let's say the prediction, the first prediction. Okay, first prediction. Just, we don't need to confuse the names together. So the first prediction is actually giving this batch that we created, because we want to start from somewhere. We want to give this last 24 hours to our model in order to predict the next value for us. So I need to give this batch new and use the predict method just like before in order to predict the first value. So I'm using my model P that we developed with together, if you remember, this model P, and then using the predict method, and inside of the parentheses, I'm mentioning this batch new that we created, that we reshape it with together, and that's it. So this is the first step. And just in order to make it in a good shape, I just use this one. I will show you why. So if I run just this line, it will give me one value. Let's do that. Let's just copy until here. Let's just do this. Okay, it has finished. So if you check the first spread here, you can see that we have a number here. Okay, what does this number means? This number means that, okay, if I, let me open the training set scale here too. So this means that if I give the last 24 hours to my model, these numbers, it will spit out this number for me. Okay, so what is the next step? Just guess. So try to remove the first value here. For example, let's say we are starting from here to here, okay? Try to remove this one, okay, this number, and start this time from here, but we have 23 hours. Let's add this number at the end of this and then give it as the next patch to our model and try to predict the next value. You understand what I'm saying? So this is what we are doing until we get 48 of these predictions. And that's it. That's the finishing of what we want to do. So as you guessed, the next step here is actually creating such a structure. To do that, first I want to append this first batch, this first prediction, not batch, this first prediction that I have done into my prediction list. So to do that, I'm saying this prediction list, just copy and paste it here, dot append, again I'm using the append method, and inside of that I'm adding this first prediction here. Okay, that's it. So this first prediction goes as the first value of my prediction test. Okay, I want to complete this. So the next thing is what I said. Go to the next value, try to add this first prediction at the end of that batch and give it as another batch to our model in order to predict the next one. So to do that, I'm using one line of code that could be a little bit complicated, but it's not. So let's say this time this time I should use the name of this batch new. So let's say the batch new is equal to, because I want to update this batch, okay? I want to update it and go to the next value and add the prediction to the end of it. So I want to say batch new is equal to np.append. And inside of the parentheses, here is very important. I'm using this batch new here, copy and paste it. I'm using this batch new and I'm saying, okay, all from this dimension, one from this dimension, all from this dimension again. I will show you what I mean. Let's continue and finish this. Okay, then I have two brackets here, and inside of that, I'm saying the current prediction that is actually this one, the first prediction that we have. And then we have the axis, that is 1. Okay, what I'm saying here is very easy. I'm saying, okay, try to append, as I said. Okay, let me open this up. You will understand it better here. And this is the first spread. Again, what I'm saying here is, I'm saying that try to take out the last 24 hours and predict this one. In the next step, I'm saying I don't want this first value. Try to start from here and then add this at the end of this. And then we have another 24 hours in order to predict the next value. And then so on, so on, so on. It comes from here, for example, and then to the end, and then the next value added at the end, and then give it as the next 24 batch to our model in order to predict the next value. This will continue, and I'm writing this as this line, just like this line. This line of code is saying the same thing. It is mentioning that, okay, from batch new, I want this. I want from this dimension, I want all of it. From this dimension, I want all of it. From this dimension, go ones down. So I don't want the first value, okay? This is starting from 1. It means that I don't want the first value start from the next one. And then try to add this prediction that I have done here, try to append it in the axis of 1, in the axis of vertically, try to add this one to this one in the axis of 1, it means vertically, and then copy it in the batch new. I hope you understand. Let's review it again together. So first of all, we did the first prediction here. And then we want to go to the next one, try to forget the first value. So we have 23 this time. And then adding this prediction value to the end of that will create 24 value for us, in the append it in the axis of 1, and then copy it in a batch new for us. And that's it. That's the end of the story. At the end, when we are doing this, we are actually updating this batch new for ourselves, and we are appending it to the prediction test as well. So that's it. That's the structure that we needed in order to test our univariate model. I hope it wasn't difficult. If you think it's difficult, just go back to this video and try to listen to what I'm saying again and again in order to understand it. But I think it's now clear for you. So the next thing is actually we want to create this list because it's a prediction. First, let's do that. It creates a list for us. If I don't have any typo, it shouldn't give me any error. Okay, it's done. So we created our prediction test. Congratulations. And if I open it, it's something like this. But here it's a list. I don't want a list, and I want it to be an array. So in order to do that, what I'm saying is prediction. Okay, let's just copy and paste this. Prediction test is equal to np.array, as you know, and inside of the parentheses, again, prediction test. So if I run this, now our prediction test, if you can see that, if you see the type is the array of floats 32. So this is actually our predictions. You may see the difference between this and our real values, but this is the scaled value. You need to transform, actually inverse transform these values to the original format. Do not forget to do that. And to do that, it's just one line of code. I'm saying predictions. Let's say predictions is equal to the SC that we created together. If you remember, in the pre-processing, we had SC. But this time, instead of the transform, I'm saying sc.inverse underscore transform. Okay, very easy. Okay, I think I have typo, transform. Inverse underscore transform, and inside of the parentheses, you just need to mention this prediction test because we want to bring back these predictions into an original format, into the original format of the predictions. So with this line of code, we actually bring them back. So if we run this, you can see in our variable explorer, we have our predictions as well. So this time, the predictions are in the real format. Now it's time to check what our model have done and if it's okay or not. To do that, using the matplotlib in order to plot the actual values and the predicted values. So it's very easy, plt that's plot. And inside of the parentheses, I have my test set as my real value, test underscore set. And the color, for example, as always, I like it to be red for the real values. And the next thing is the label. I want to have a label, and label is the actual values. And the other thing is plt.plot. And inside of the parentheses, we have predictions. and this prediction. Let's copy and paste it to not have typo. And then the color that's for prediction, I usually set it as blue. You can use any color that you like. And the label, that is actually our predicted values. Let's say predicted values. Okay. And then you need to define a title, for example, plc.title is, let's say, for example, our title is LSTM univariate forecast. And then we have our X labels, plt.xlabel, and the X label, let's say it's a time, so let's say time, hour, and then we have our Y label, and for Y label we have solar irradiance, for example, let's say. And then that's it. And we need to just add a legend here. So legend. And at the end, just like always, plc.show to render our graphs. And that's it. So if you don't have any typo, let's select these lines and press run. Yeah, that's it. And very beautiful graph will be plotted for us, this plot. And you can see this is our predicted values, and these are our actual values. You can see that it's a good prediction. Actually, our model understands exactly when to goes up and goes down. A little bit problem with the pick that could be solved with changing the parameters. For example, changing the number of epochs, changing the batch size. These parameters, these changing even the number of units, the number of neurons. You can easily increase this accuracy, for example, to understand the picks better as well. So try to do that as an exercise for yourself. And I think we have done a very, not we, actually, the model has done a very good prediction forecast into the future based on our test set. And in order to understand that, in order to calculate the metrics as well, in order to understand the performance better, just let's, for example, for instance, let's calculate the root mean square error and the R square for our model. So to do that, I import math because I want to use the SQRT for the root mean square error, and from Scikit-Learn that metrics, I import mean square error, and here I want to calculate the RMSE. So let's say RMSE is equal to math dot SQRT, because it's the SQRT of the mean square error. Then I easily use the mean square error that I just imported here in order to calculate the error between my real values, that is my test set, and my predictions, that is here. I can just copy it here. And that's it. Let's do that for the R square as well. So R squared, first let's import the library. So import from, again, Scikit-Learn, I'm using Scikit-Learn.metrics. You can use any metrics of the Scikit-Learn that you like in order to test the model. Just do that as an exercise for yourself. For example, mean absolute percentage error and other types of errors in order to see the performance of this model. So I want to import the R square. So R2 underscore score. And then very easily I say r square is equal to r2 score that I imported. Yeah, this one. And again, the real values that are test set and the predictions that are here. Okay, again, if you don't have typo, it should work. So just select all these lines, press enter, press run, sorry, and then you can see the R square and RMSE in your variable explorer. So the R square here is 97%. Good job, guys. Our actual model shows a very good R square. 97 is perfect. And the RMSE, you can see that it's 009, so it's a very, very low error that we got for this model. So I think the model has done a very good job in order to predict into the future for 48 hours. So just for your practice and your exercise, I'm suggesting this very strongly to you to do that. So for example, work around with this number. Try to predict more into the future. For example, for 72 hours, for even 1 week, 168 hours, because from a value, after a value, you are actually predicting based on the prediction, and for sure the accuracy of your model should decrease, the error should increase when you are increasing this this horizon. So try to do that for yourself in a home. Try to increase this and see the reduction of the accuracy of your model, and also try to work along with these parameters. Increase the epochs, increase or decrease the number of dropouts, neurons, even change the optimizer for yourself in order to see what are the differences and how you can improve the performance of your model for yourself. And that's it. We have done a very good job by implementing and developing our first model, first LSTM model for univariate, for a single variant model. That was not easy. You have done a very good job. But for the single variant, it will be a little bit different and we need to concentrate more. And I will show you how you can do that. I think for the first time, you can see that in the next section of this course, and that will be very, very interesting. So until then, try to exercise more and more on the single variant to be ready for the next section that is multivariate, and it needs more concentration from your side. Thank you so much for listening. Keep exercising and enjoy time series. Hello and welcome back to the course. So in the previous tutorials, we talked about single variate model and how we can develop a LSTM model based on single variate, just having one variable, your target variable. But sometimes you have some predictors, you have some independent variables as well that you can get help from them in order to predict your target variable. So that's multivariate model. And the procedure of the developing this model, the multivariate model, it's a little bit different from the single variate, especially in the test section. So let's not waste more time and go straight to this multivariate model. But I selected another data set for you for this model. It's not solar radiation anymore, it's about electricity consumption, and it will be very, very interesting. So I want you to be familiar with other real projects that you may occur during developing your model, so you will be familiar with other data sets as well. So let's start with importing the important libraries, the basic libraries that we need. So as always, we import pandas as PD, we import numpy as MP, and also we import matplotlib .pyplots as PLT. So let's import these libraries first and then continue. So these libraries now imported and we can use them. So the next step is actually importing the data sets using Pandas Library, just like before. You know it. You can pause the video and do it yourself very easily. And as I said, we don't need to set the date as index and stuff. Just import the data set, and you can just download the electricity consumption data set by clicking on the resource button that's on this video, and just put that the CSV file on the place that you're saving your Python file, .py file, and that's okay. That will be fine. So VF, our data frame, is equal to pd.read_csv, and inside of the parentheses just mention the name of the CSV file that you can download it, as I said, from the resource button. So I just copy and paste the name here, and the name is electricity consumption. If you change the name, please just copy and paste the name here, and do not forget this .csv. And we can easily set our console as working directory, and then select this line and run it. Yeah, now we have our data frame. As you can see, the type of the type is data frame, and the size is 8,760 number of rows, number of samples with 4 dimensions. So if we look at the data set, it's something like this. So the first column, the first dimension, is actually the date that we don't need it anymore. It's just for your information. But the columns that we are using as our predictors and target variables are these 3. So humidity and temperature, and this is the electricity consumption of Ottawa in Canada. So I don't care. We don't care about the units. We don't care about the basics of the science behind this. So what we want to do is just taking care of the data and the forecasting. They give you such a data set, and you want to forecast the future of the electricity. So this is electricity consumption of a city in megawatt units, and you have it for 1 year in overlay resolution. You also have the temperature and humidity as independent variables or predictors of your data set in order to predict the electricity. So they gave you this, and they ask you, for example, okay, develop a model for us to forecast the next 2 days or the next week or the next hours for us. So let's do that. This is the aim of this tutorial. So first of all, before we continue, I want to just mention that this data set, I downloaded this from the open portal. That you can just check that out. This is the Ontario Open Portal data. So this data reference is coming from this website, ieso.ca, the Power Data section. You can download the other types of data that you need from here as well. The next step, if you remember, it's just exactly like what we have done for the single variate. We need to actually drop the missing values. I've already done that, but just do not forget this line of code. It's very easy. Just drop the missing values or replace them or deal with them in any way that you like. So here I want to just drop them, if any. So in place is true in order to implement it on my data frame. So if I run this line, you can see that the size is not changing. It means that we don't have any missing values, but in case I just put this line of code so you can use it for other data sets as well. The next things that I want to check, that we didn't do this in the previous single variate model because we just had one variable, but this time we have 2 other variables, and we want to check the correlation between these variables. And for that, I want to use the heat map method of the Seaborn library. So I import the Seaborn library as SN, and here I use this SN dot. So I want the heat map of these variables. So I check the correlation between them, and also I define that, go to data frame and check the correlation for me and show the correlation as a heat map for me. So that's what we need. If we run these two lines of code very easily, it will give us this beautiful heat map that shows the correlation between different variables. As you can see, for example, here between electricity and the temperature and humidity, we have not strong but medium to poor correlation between humidity and temperature. As you know, I chose these two variables, humidity and temperature, because it's easy to understand that with, for example, the reduction of the temperature in the winter, for example, you use much more electricity for heating your building or the place that you are living. Or also humidity, it has the direct impact on the amount of electricity that people use. So it's easy to understand that they have some correlation, but as you can see in our data, we cannot see strong correlation. It's just a correlation and it's poor. But let's hope that even that poor correlation can help us, can help our model to perform better. So this is how you can check the correlation between your variables, and as much as these correlation is stronger between your predictors and your target variable, for sure they can help your model better to understand the time series, the time series of your data. So this is the correlation part, and the next part is actually exactly like the single variate. So I just go ahead and type them down without explaining them so much because you know them already. So I want to split my data set into training and test set. So my training set will be equal to, for example, let's say df, I use the ILAC method. I want to split it again to 8,712 for the training, and the last 48 hours that will be 2 days for testing my model. That will be fine, I think. And so let's say from the beginning until 8,712, and I don't want all the columns. If you remember, the dates column is not important for us. So this is the 0, so we need 1, 2, 3. So let's say 1 to 4 in order to have 1, 2, 3. So I want 1 to 4, and that's it. And I want them as NumPy arrays, so let's say that values. And the exact same thing for the test set, but I need the last 2 days or last 48 hours. So let's say test set is equal to df log. I want it starts from this number 8,712 until the end of my data set. That will be 8,760. Again, I need 1 to 4 as my test set. So if I just run this, select these two lines and run it, you can see that in your variable explorer, these will appear as training set and test set. So this is my training set, and this is my test set that you can see that the size is 48. So last 48 hours for the test, the rest of the data set for training my model. So the other stage, if you remember, we had we should normalize our data. So it was optional for a single variate, but here when you have other variables as well along with your target variable, you have to, this is a must here, you need to scale your data before continuing. So for single variate it was optional, but I suggested that it is better doing the scaling and normalizing, but here it's a must. So let's do that. From I want to use the min max scaler again. So from Scikit-Learn, that's pre-processing. I want to import min max scale. Oops. think it's right. Yeah, min max scale, scalar, sorry. And then again, I define sc as my scalar. I use this min max scalar that I imported, and inside of the parentheses, I create a feature range. So feature underscore range, and as I said, I want the feature range just like single variate. I want it to be between 0 and 1. Oops, what happened? 0 and 1. And yeah, that's it for me. And the next line will be actually fitting my data, transform your data into this SC that you created. So I'm saying again, just like before, training underscore set underscore scale is equal to sc.fit underscore transform. Yeah, and inside of the parentheses, you should mention the data that you want to scale. It's a training set for us, so let's copy and paste it here. I just copy this line again and paste it here, and just change it as test set the scale. Test set the scale is equal to sc fit transform, and this time instead of training set, you should copy and paste the test set here. So that's what we needed. So let's do that. Let's select all these lines, all these 4 lines, and press enter, press run, and you can see that the test set the scale is like this, the training set scale is like this, and all is done. Okay, it's fine. And just before going to the last parts of our pre-processing, before developing our model, I need one other line in order, because this is very important. I don't want my test set scale to be like this. So the test set scale, because the reason behind this line, I will show you what is the exact reason. I cannot explain it very well right now, but in the test set, I will show you why why we have done this. So my test set scale is equal to test set scale. I just want all the rows, but I don't want but I don't want all the columns. So I say 0 to 2. This means that from my test set scale, I don't want this last column that shows the target variable. I just need the predictors. I just need the independent variables for my test. Why we are doing this, I will show you in the test set section, but let's do that now. So I just selected, I just extracted the first 2 columns from my test set scale, and I run it. Oops. There's one problem. Oh, okay, I have a problem here, so I need to use the column. Sorry. So I select this line. Sorry, I had a typo, and then run it again. So now you can see that my test set scale size, I have just the predictors, and I remove the target variable. So the size is actually 2-dimension here, you can see. So that's what we need to do. But before finishing this tutorial, going to developing our model, we need to do the exact same thing that we have done for the single variates, and I hope you remember that, and I hope you exercise that very much, that you can pause the video yourself and type it yourself, type the code yourself. It's just 4 or 5 lines of code, so you can actually create different batches, create different windows for training your model. I explained this for you completely through the single variate model, so we don't need to go through that part again. But if you don't recall that, just go back to the single variate model, the previous tutorials, and watch the videos again about why we are doing this. So to do that, again, this is not different. So it's exactly like before. Xtrain is equal to empty brackets. I need to create a list for my Xtrain and Ytrain. Again, empty lists, and then using a for I in range of, okay, so this time I want my window size to be again 24 hours, so I use 24, and the length of my training set. So you can you can say, for example, this, you can say window size just like what we did for the single variant. Okay, WS is equal to, for example, 24 hours, and here you can say I want the length of my training set scaled. Okay, just this. Okay, so this means again from 24 to 8,712, and that's it. Go to the next line, and I say, okay, Xtrain is the Xtrain dot append this to this empty list. What should be append from training set scaled? I just copy and paste this here. From training set scaled, I want I minus WS till I, and I want 0 till 3 because I want all the independent and target variable. And then the next line we have our Ytrain that append. So this time we just have our training set scale, and we need just I and the last column, that is 2, that is our target variable. Okay, so again, if you don't remember why we are doing this, just I don't want to waste the time here, so if you don't remember it, just go to that previous tutorials in single variate model and review again what I'm saying about why we are doing this. I explained it completely there, and just come back to the video, to this video. So the next thing that we should do is making these lists, because if we want this right now, we have Xtrain and Ytrain as list. Let's do that. Let's do that and then make them NumPy array. So I just make my Xtrain and Ytrain, and now I change them to NumPy array. So Xtrain, Ytrain, Ytrain are equal to MP array, my Xtrain, and also MP that's array Ytrain. Okay, now it's done. So if I run this, now you can see my Xtrain and Ytrain are not list anymore, and they are NumPy array. If we check Xtrain in order to make sure that we have 3 dimensions, as you can see. So the last dimension is exactly what I told you. So now we have another 24. We made it 24 features for ourselves. So you can see that we have 24 features instead of 3 right now. So that's what we needed to do. And the last step is actually reshaping in order to make sure that it is in a proper shape, or Xtrain is in proper shape before we make it as input to our model. So we say Xtrain is equal to, I use the reshape method of the NumPy, so reshape, and inside of the parentheses I use Xtrain, and I use now we need to define the shape. So Xtrain dot shape, so the first dimension is 0. Again, Xtrain dot shape, this time the second dimension I want, so it's 1, And the last thing is the number of features that you should define. Here we have just 3 features. If you remember, we have 2 independent variables, humidity, temperature, and 1 target variable that is our electricity consumption. So we have 3 features. So you need to do this, put 3 here. This is exactly the number of features that you want to give as input to your model. So if I select this line and run it, okay, all is done. Our X-train, we are sure that our X-train is in a proper shape before we give it as input to our model. So that's it. This is our pre-processing stage. We don't have any changes here, so it's exactly like what we have done before for the single variate as well. So if you cannot understand one of these lines, you can go back to the single variate model, because I explained all lines better in that part, and I just skipped some of the parts here because I already explained them. And that's it. This is our pre-processing. In the next tutorial, we are going after developing our LSTM model. That will be again somehow similar to what we have done for a single variate, with very slight differences. And that's it for this today tutorial. Until the next tutorial, keep exercising and enjoy time series. Hello and welcome back to this tutorial. Now we want to develop our model in this tutorial. So the structure is somehow same as the single variate that we have done it before. So you are familiar with this structure. So I go through it line by line fast. And so we start from importing the related libraries. So I want to use Keras model just like before. So again, from Keras, from Keras.models, I want to import the sequential. So I import the sequential method. Then from Keras.layers, I import the LSTM method. Then again from the layers, I import dense, and at the end from Keras layers, I import dropout. Okay, so if you don't have typo, you shouldn't have any problem. We select these lines, we import them. It takes a couple of seconds and that's done. So now we imported our related libraries. Quickly we go through developing our model line by line, just like before. I can use the name model P again, or let's say we can even say model. Okay, so our model or our regressor is equal to sequential, and then I use this model in order to add my layers. So the first layer, I use LSTM. I add the number of neurons. So here in the previous time we used 16 number of neurons. Now let's check, for example, something different. So let's say, for example, here we have 70 neurons. It takes more time, but it may lead to better performance. So let's start with this one. If we don't get good results, we will come back and change this. But this is a hyperparameter, as I mentioned, and you need to optimize them. You need to use different types of parameters to find the best parameter, optimum parameter for yourself, for your model actually. So the next thing is return sequence, that I need this until my last layer. So I put this as true, and the important thing that is input shape, that is actually our input layer. So our input shape is equal to, again, I use my xtrain dimension 1, xtrain that shape. I want the second dimension, and also the number of features that we have. So here it is important this number to be matched with this number that we already discussed it in the pre-processing. So any number that is here, it should be here as well. So it's 3. So here we need 1, 2, 3. Okay, parentheses, and then we use the dropout method in order to drop a couple of random connections. So let's say our model dot dropout, dot add, and then I use the dropout method. And this time, instead of, for example, okay, let's go for 20% again because it's a good number, and another parenthesis. And the other thing is the others are exactly the same. So I copy and paste these lines here as well, but I don't need the input shape in here. So I need to delete this, and it's fine now. So the second layer should include the number of nodes, and also the return sequence is equal to true, and the dropout 20. So I copy and paste this because I need another, I want to create another another layer of hidden layers. So now this is our input layer and first hidden layer, second hidden layer, third hidden layer, and the last hidden layer, as I mentioned before, we don't need this return sequence. So if you copy and paste it, do not forget to delete this one. Okay, so now it's fine because in the last stage we don't need the return sequence, as the output is going, the output of this layer is actually going to the output layer. And at the end, we need to create our output layer with the dense method that we imported here, this one. So we easily can say model dot add, and inside of the parentheses this time I use dense, and inside of this time I don't need 70 units, I just have one output, so the units will be 1 actually, units, okay, will be equal to 1. And I close this, and that's it. We created our layers. Now the next step is actually compiling our model. So let's say model that's compile, and inside of the compile you need to define your optimizer just like before. We use Atom, so optimizer equal to Atom optimizer, just like the single variance one. As I said, you can try other optimizers as well. So the loss is equal to mean squared error, just like before, mean squared error just like before. And let's close the parentheses. And the last stage is actually fitting our data, our model to our data. So let's say the model that we created, it's needed to be fed. So model that feeds, and inside of the parentheses you need to mention the xtrain and ytrain. And if you remember, we created our xtrain and ytrain. You should have it in your variable explorer. So this model used this data that this X-train and Y-train that we created in our pre-processing stage. So it's very easy. We just need to give the X-train Y-train to our model. So let's say X-train Y-train, and the number of epochs. You need to have the number of epochs. Let's say, for example, I want 18 number of epochs, and the batch size that is equal to 32. So you can use different number of batch size, different epochs, just as you wish. But refer to my experience, these are good numbers and will give you better, will give your model better ability to understand your data. But after that, we also check out if this 80 epoch number is a good number or not, just like what we have done for the single variate by checking the number of epochs with the loss, by plotting them out, and find out that if we will get better, if we can train our model better if we increase our epoch or not, number of epochs or not. So that's it. We developed our model. Now it's time to run our model based on this X-train and Y-train and train our model based on these data. And let's select all of these lines that we wrote together and press run. Now you can see in your console, as you can see, it is going to start the number of epochs. As soon as it starts the first epoch, because it takes time. It's not like the previous model that we waited for a couple of minutes and it was done. Here we have more data. We have 2 other features. So it takes about, for the configuration of my laptop that I'm using, it takes about 20 minutes, 15 minutes, something like that, but it depends on your system and your computer. So I pause the video, I wait this epochs to 80 number of epochs to be finished, and then we will come back to the video after that and continue this tutorial. Okay, now that it is finished and we came back, congratulations, we finished developing our model, and the model is trained in 80 epochs, as you can see, and the loss is very negligible, as you can see here. So it doesn't mean that our model is perfect, because it may cause overfitting, but it is a good sign. It is showing that our model trained good. So let's hope that it is not overfitted. And so the next thing is saving our model. So do not forget to do that anytime that you develop your neural network. So we easily save our model by model.save, and inside of the parentheses you can just mention the name of your model. For example, you can say LSTM multivariate, and close the parentheses. And anytime that you like, you want to just load it with from Keras models, Keras dot models. You want to import load model, and easily we can say, okay, just we can load our model in the model again with load model method, and inside of this you should have the exact same name that you have here. So I could just copy it until here and paste it inside of this. Oops, here we should have a, okay, now it's fine. And but before doing that, try to check out that if this number of epochs it's fine, and even sometimes you need to decrease or increase your number of epochs in your next running of your model. So I go before saving it and go to the next steps. This is what you should do, because if you go further in your codes and then want to come back, it doesn't understand the loss in your console again. So this is the first step after developing your model. So just like what we did for the single variate, we easily use the matplotlib. So I already imported the matplotlib, so I don't need to import it again. So I just say plt dot plot, and here I use as the x, I want the number of epochs that I have. So in order to do that, I just say range, and inside of the parentheses, I use the lengths of the history of these losses. So I say lengths and model and dot history. Dot history, and inside of that you should say the loss. Okay, now it's fine. And the y should be okay, now it's good. And the y should be exactly the same thing. So you should say model that history, because we need the loss. We need it to go to the history of the model and extract the loss for us. So history dot history, and inside of this you use loss again. Okay, that's it. So close the parentheses, and in the next line we just need to have our x label and y label. Plt that's x label. Plt that x label should be, for example, epoch number, just like before, and plt that y label should be loss. Okay, very easily. And at the end, plt that show in order to render it. And that's it. So if I select all these lines and press run, you can see that this plot will be created for us very nicely. So you can see that I don't know why we don't have the x label and y label. Okay, so this is our problem. So here you don't need to have this for your x label and y label. That's why it didn't plot it for us. So let's do it again. Now you have your x plot. So this is our epoch numbers. This shows the vertical shows our loss, and you can see that we have a very sharp drop after the first or second epochs, and after that we have another sharp drop, not as much as the first one, but this is also sharp. So until the 10th, and after the 10th epoch it goes down, but not as sharp as before, but it goes down until here, until 30, 40, and after this, with changing the number of epochs, the loss will not change significantly. So this plot shows us that we don't need to go after 80 number of epochs. So even 40 will be fine, even 30 will be fine. So you can try that and it will give you the same performance. And we don't need to use the number of epochs more than 80 that we have already used. So that's it. This is just for your information that shows you some information about the convergence, as we have checked that for the single variance as well. And we developed our model. Congratulations. So it's finished. So, but in my opinion, the most important part is actually testing your model in order to find out that if the model is working or not, if it can forecast into the future, or not. And for the multivariate, it would be a little bit more complicated than the single variant that we discussed it. But don't worry, we will go through that's line by line in the next tutorial, and I'm sure that you will understand it perfectly. Until the next tutorial, keep exercising and enjoy time series. Hello and welcome back to the course. So before we continue and progress in our codes and test our developed model, I need to explain some concepts here for you, that how this testing work, just like univariate. If you remember in the univariate, I just want to have a very quick review on the univariate. So we said we have, for example, for testing our model, we have T1, T2, T3, and T4 as our batch. So this is our look back period is, imagine that is 4. So we look over we give the last 4 steps of our training set to our model in order to test our model, and the model predicts T5 for us. Then we use that T5 and we go down 1 step, we remove the T1, and we add this T5 as at the end of our batch, and give this to our model in order to predict the next one, and it will give us T6. So this will continue and will update itself until the end of the lengths that we defined that we need for our prediction. For example, if you need 48 hours, this will continue until the 48 steps in order to give us the 48 prediction steps. So but for the this is for univariate, this is for single variates. Let's say we have a multivariate model, and now we want to test our model. So this time we are dealing with such a table. So we have not just having target variable, we also have the variable 1, 2, 3. Imagine that you have 3 variables, for example. And we want to deal with this type of data set. So imagine that this is the first batch of our variable 1, variable 2, variable 3, and target variable. For example, the last 24 hours of our training set. We extract this from our training set, and we will give it to our model in order to predict the next value of our target variable. That is, for example, this number, this predicted value. Then the next step will be like this. We forget about the first row again, just like what we did for the univariate, and we go to the next rows. And what we have here is something like this. We forgot about the first row, but here we just have the variable 1, variable 2, and variable 3. We don't have the target variable. So we need to use this predicted value here to put it here in order to predict the next value. So this predicted value will come here, will join the variable 1, variable 2, and variable 3 of our test set, and after that we will predict the next value. So if you remember from the previous sessions, I think the first session of the first tutorial of the multivariate, in the pre-processing stage, I told you that I will explain why we removed the last column that is our target variable from our test set. That's why, because we need just the independent variable for testing our model. The rest will be our predicted values. So our test set will be variable 1, variable 2, any variables that you have. For example, in our case, we have just 2 variables. So we have variable 1 and variable 2. And then the predicted value will join this variable 1 and variable 2 in order to predict the next value, and this will continue until the end of the length, until the end of the length of our prediction horizon. So this is how multivariate works. If we go to the coding area, that will be for sure you will understand more there. And until then, keep exercising and enjoy time series. Hello and welcome back. So I explained the concept of what we are going to do for testing our model in a previous tutorial, but now we want to actually implement it here. and progress in our code in order to test our developed model. So to do that, the initial structure is same, but we have some additional lines of code. We've added some additional lines of code to what we have done for the single variate. So let's do that. First of all, again, we start with creating an empty list. So prediction underscore test is equal to an empty list. And then again, this is the same as before. I want to make a first batch. So my first batch will be, let's say batch 1 will be equal to the training set scale. I want to training sets, I hope I don't have typo, scaled, and here I want the last 24 hours. Let's say we want to, because our window size is 24, we want to have the last 24 hours, so minus 24 and until the end. So this means that go to the training set of scales, extract the last 24 rows and put it in a batch 1 for me. And that's it. If we go to the next line will be our new batch. So batch new will be, let's do it like this. Batch new is equal to, okay, the batch 1 that we created here. So just copy and paste it. And I want to just reshape it and put it as a batch new. So reshape it as, I want to reshape it like this. I want 1, 24, and 3 as the input feature. So this is the first difference. If you remember, in a single variable, because we had just univariate, we had just one target variable and the number of features as the input was 1. But here it's 3 because we have 3 variables, not just our target variable. We have also 2 predictors in order to help us. So we have 3 input features. So this number is 3. This is the first difference. The next, let me just create some lines here and come back. Okay, so again, we need to put this in a for loop. So for I in range of 48. Why 48? Because I want to predict the next 48 hours. So if you want to predict the next 72 hours, you can just say 72. So this is the length of actually your prediction horizon. Okay, so because I want 2 days, so I mentioned 48. And inside of the loop, I have some lines. The first 2 lines are exactly similar of what we have done for the single variate. So I'm creating my first prediction, and my first prediction will be equal to model dot predict. I'm using the predict method and using the model that I have developed in order to, and what I'm giving to this is the batch new, this one, that I just reshaped it as well. So here I should just say predict, sorry, inside of the parentheses, I use the batch new, and in order to make it in a proper shape, I use this 0 as well. So what I'm saying here is exactly what we have done for a single variate. I just created an empty list. Let's review it together. Then I created my first batch, that is the last 24 rows of my training set, in order to give it to my model, in order to speed out our first prediction. So I will give this to the predict method of my model in order to give me the first prediction. Okay, so this is very crystal clear until now. So the last line will be appending this first prediction into my prediction test very easily, this list that I created. So I'm saying prediction test, this one, if I just copy it here. Prediction test dot append, and inside of this append parentheses, I should just use this first pred. Okay, just copy and paste it here. So now that I have my prediction, I append this to my empty list. So if I run this code until now, it should give me one number. Okay, but I don't want one number. I want 48 hours, not just 1 hour. So I need to update my model. Sorry, not model. I need to update this list for another i's in this range, I2, I3, I4, until the end of this length horizon that is 48. So to do that, I need your complete attention, and complete attention here, because it needs your complete attention actually, and you need to focus. So here we need to create another variable for ourselves, a new variable here, and I name this new var. Okay, let's say new var. Okay, just like this, and I need this. Why? I will show you. So the new var is actually our test set scale, test set scaled, and I want the I until the end. So if you remember in our variable explorer, if you check, we have our test set scaled here. This is our test set scale, okay, 48 hours. And if you remember, we removed the last column that is actually our target variable. So we have already, we just have predictors, we just have independent variables here. So what I'm saying here is get the I and all the columns. So for both columns, okay, and the i's row. For example, if I is 1, this will be 1. If I is 2, this will be 2. And copy it in my new variable. Why I need this? I also need to reshape it as well. If you remember from the concept session, we need to have our test set scale in order to add the predicted value to that and put that at the end of our new batch. Okay, so the next line will be this new var, because I need to reshape this as well. So new var will be new var dot I use the reshape method. So reshape, this time I use 1 and 2. So I want it in 1 and 2 dimension. So the next thing is creating our new test. So the new test will be something like this. So new underscore test will be equal to, I want to use the insert method. So I use the insert method of the NumPy. So let's say insert. Okay, I write the code, then I will explain it to you with more details. So np.insert, and inside of the parentheses, I'm using the new var that I created in a previous line, and I'm saying 2, and then I'm saying the first prediction. I'm saying the first pred, this one, inside of the parentheses, and that's it. In which axis? I forgot the axis. So the axis will be 1. Okay, so what does this mean? What this line is actually the most important line here. So what I'm saying is exactly what I discussed what we discussed in the previous session. We were saying that, okay, we need in order to add the prediction value, the first prediction, to our test set and go one step down and then add the prediction value to that. Okay, so what I'm doing here is saying, okay, this is our table. Imagine our table here. So let me open this up. So what we have here, this is our test set, okay? But we need our test set scale. So this one that we have just 2 columns, this is okay. So imagine this table, just like what we have discussed in the concept previous session. Now we have 2. Now we need to remove, for example, the first row, go to the next rows, and for the next rows, we need to add the prediction value here. So in order to add this here, I'm using the insert method. So I'm saying that, okay, you predicted 1 for me, just put it inside, put it beside this, these 2 columns, and then go to the next prediction. Okay, so I'm using this insert method in the axis 1. It means that here horizontally, just put it here and then go 1 step down. Sorry, go 1 step down and then put the prediction value here. So this is the order. So this is very easy. So if you look at this, I'm saying that after the second column, it means that, okay, if we have 2 columns here, it means that I don't want the 0 column, I don't want the 1 column. Put this prediction value in the 3rd column, that is the 2nd column actually in Python. So this 2 means the second column, second feature. And in the axis 1, it means that in horizontally, and just attach this new variable to my first prediction, okay? So that's all the things that I want to show you. This is the most important part actually. I inserted this and now it is ready to predict my next value. So the next line will be exactly the same as what we have done for the single variance in order to update. So before that, I need to also reshape my new test. So new test will be np, the new test itself. That's reshape, and inside of the parentheses we mention, okay, 1, I want 1, I want 3 here. So this is, then after the reshaping, the next line will be exactly like before. So we have batch new that we want to update, batch underscore new. This is equal to np dot append, and inside of the parentheses we have our batch new, this one that we want to update it. And again, just like before, we want all from this dimension. We want to go to the next line, next row from this dimension. So we mention 1 column and then all from this dimension. And the things here is what I'm adding, what I'm appending here this time is this new test, new underscore test, instead of the prediction itself. And the axis is 1. So the difference between this multivariate and the single variate, you understand as that is this for line. So in the single variate, we just say that, okay, we have a prediction. Now append this prediction to the end of our new batch and go 1 line down and append it to the new batch, the prediction, and in axis of 1, and that's it. Use that new batch in order to predict the next value until the end of these 48 horizon. But here we are saying that we have independent variables as well, so we need to create another thing. We don't have just one variable. So to do that, we made a new variable first, then we made a new test by adding the new variable into our previous predictors by adding the first prediction to our predictors by the insert method. And after creating this and reshaping this, we use this one in order to append it to our batch new. So that's it. This is the whole story. It's a little bit complicated, I understand, but if you listen to what I'm saying more and more, you will understand it better. And if you exercise this for yourself several times, you will understand it perfectly. Don't worry about that. And then after finishing this, now we want to, now we have our prediction test as a list here, and you need to make it an array. So let's say prediction underscore test is equal to, again, the prediction test, this one, yeah, we don't have a typo. Just copy it, and we need to make it an array. So let's say mp.array, and inside the parentheses just paste the prediction test again. So if I select all these lines, I hope I don't have typo, but if I select all these lines, if I don't have typo, it should work. So if I run this, it takes a couple of seconds, and now you can see in the variable explorer we have our prediction test as an array. This is our predicted values, but as you can see here, they are not in the original format. They are in a scaled format, and we need to bring them back, inverse them into the original format. But there is a very small trick to do that, and I will show you how you can do that in the next tutorial, and that will be very interesting to see the result. So let's wait until the next tutorial. In the next tutorial, I will show you the trick, and also we will discuss how our model works by plotting out the results and also calculating the related metrics. So until the next tutorial, keep exercising and enjoy time series. Hello and welcome back. So as we discussed, in this tutorial, we want to actually bring back our predictions into the original formats, not the scaled formats. And to do that, it's not as easy as what we did in a single variate model. Here it has a very small trick, because we cannot use the inverse transform, and if you use the inverse transform of this SC, where is it? Okay, here, this SC, it will give you an error. Why? Because you use this SC and you transform your training set that already has 3 features. And this time, if you want to bring back just one feature, it will give you an error. So you need to just bring back either all features, or you cannot do it for one feature. So to do it for one feature, it's very easy. Just follow what I'm saying. We will make another min-max scaler, just like this. We say, okay, SI this time. This is not SC, that SC that we created. This is SI, another min-max scaler. Min-max scaler, and inside of the parentheses, again, feature underscore scale equal to feature scale, feature range, why I'm saying scale, is equal to 0 and 1. And then what we have is here we just to extract one feature and fit our data on that first, and then inverse it. So we say based on the in the training set, we want this feature, this target variable. Okay, so it's 2 to 3, so it's our third column. So we say over, for example, let's say Y scale. Let's name it Y scale. Okay. Any name that you like. Y scale is training set. In our training set, go and extract all the rows, but not all the columns. I need just the last column. And oops, sorry. I need just the last column. That's it. And now I fit this data that I extracted from the last column. So let's say fit underscore transform, and into this Y scale that I just created. Okay, so the next step is actually I'm using this SI in order to inverse transform my prediction. So let's do that first and make SI. Okay, now it's done. And the next thing is our predictions is actually equal to, this time using this SI that we just created, and inverse transform method, and using the prediction test. So this is the prediction test that we want to bring it to the original format. So just copy and paste it here. And if I run this line, and if I check the variable explorer and predictions, now you can see that our variables, our prediction values are in the original format. We can just compare it by looking at predictions and also our test set here, or just this is our these are our prediction, this is our real, these are our real values. But let's do it professionally by plotting these two together and comparing them together. So I want to say our observed values or real values will be our test set. I just want the last column. So our observed values are all the rows and the last column. So if I run this, this is our real values, our observed values. I just extract it from test sets. And now I use the matplotlib in order to plot these two together. So already import the matplotlib, so I just need to say plt dot plot, inside of the parentheses I'm saying real values. The color that I usually pick is red, and the label is actual electrical consumption. And the next line will be plt dot plot, and inside of the parentheses it will be this time our prediction. So I can just copy it here to not have typos. So the color that I usually pick for the prediction is blue, and the label of this will be our predicted values. And the next thing is our title. Let's add a title to it. plt the title. This is electrical consumption prediction. Okay, and then we have our xlabel, plt.xlabel, and inside of the parentheses, xlabel. Inside of the parentheses, I'm using my xlabel is actually the time, so it's time, an hourly resolution, and the y label will be plt y label. It will be electrical demand in megawatt units. We don't care about the unit, but it's nice to have all the information in our plot. plt.legend, and also at the end plt.show to render our graph. So if I select all these lines and run it, oops, we have a typo here, as I guessed. This is our real values. Just copy and paste it here. Do not have a typo. So if I run this again, now it will give me a very exciting plot that shows the prediction for me. So look at this. As you can see, the red graph shows me our actual or observed values in our test set. And this is what our created model is predicting for 48 hours. As you can see, it's a very good prediction. I like that so much. So it captures the trend, it captures the seasonality perfectly. It goes up, it goes down, it goes up. It is not 100% perfect, but I like the performance of this model. As you can see, it can find out, it can capture the seasonality and trend of our model very easily and very good. So this is how you can visualize your model, the performance of your model. But in order to also have the metrics, create some metrics, I like to have the root mean square error as well. So I import math, just like what we did for the single variate. We use the Scikit-Learn that metrics, and we import mean square error from it. Error. And we calculate the RMSE that is equal to math.sqrt, because I want to calculate the SQRT of the mean squared error to give me the root mean square error. Mean squared error. And mean square error of what? Of real values. Just copy and paste it here as the first one, and this is the actual value, then this is our predictions. That's it. So if I calculate this, the RMSE will be about 49. So in the range of 0 to 1000, 49 seems a good RMSE. So it means that we have a good result. But in order to have a better sense of how much errors, how much is our exact errors, how many percent our model, how much our model has error in percentage, I want to show you how you can have another important metrics that names mean absolute percentage error. So we can use it. We can create that with defining a function very easily. So let's say I want to define a function named mean absolute percentage. I hope I don't have typo here. Percentage error. And inside of the parentheses, I have, for example, y true. Okay, let's say underscore y true and y pred. Okay, and I will go to the next line, and inside of this function I want to define the y true and y pred. So y true y pred is equal to, first I want to make them an NP arrays. So numpy np that's array of y true, and also numpy array of y pred. Okay, and then we have it needs to return. It needs to return actually np dot mean. You don't, if you don't have this line as well, it doesn't matter. Np dot mean. So I want to make the average of np dot abs. This is the formula of the mean absolute percentage error. So inside of the first parentheses, I need to have y true minus y pred, the difference of y true and y pred, and then I want to close this. Okay, after this line, I want to divide it by y true itself. So y true. And then we close the parentheses. No, it's fine. So what we have here is let's make another parenthesis here, so not confuse it with. Okay, now it's fine. So what I'm saying is actually I created a function named mean absolute percentage error. For any y true and y pred, it goes and calculates the difference of the y true and y pred and divide it by the y true. This is the formulation of mean absolute percentage error. At the end, you can also multiply it by 100, so it will give you as a percentage. Then the mean absolute percentage error will be calculated very easily using this this function that we created. And inside of the parentheses, you just need to define the y true and y pred. Y true is our real values, and y pred is our predictions. Very easily. And that's it. So if I select all these lines and press run, you can see that the mean absolute percentage error will appear in our variable explorer, this one, and it's about 14%. So 14% is the amount of error that our model has. So that means that our model is not perfect, but it's good. We actually developed a good model with a high accuracy in order to predict our 48 hours, our next 48 hours. So we developed, for the first time, we developed a very good model in order to predict a multivariate data set. So congratulations, that was not easy at all. And I hope you understood the concepts behind that and you exercise it more and more in order to understand it better. And this was very good. Congratulations. Until the next course, keep exercising on the time series. And if you have any question, just don't forget to put it in a question and answer section. Have a nice time.